सर पुरके सरांना नमस्कार सर.
नमस्कार. नमस्ते.
नमस्ते.
नमस्ते सर.
नमस्ते. ओके.
Welcome, Dr. S.D. Katore sir, Professor and Head Department of Mathematics, HUB.
मेरा गुरु आएगा.
गुरु. गुरु आया है लेकिन
कहाँ दिखा नहीं गुरु.
वीडियो ऑन नहीं है.
गुरु अभी तक आया नहीं.
आए हैं.
सर गुड मॉर्निंग सर.
गुड मॉर्निंग गुरुजी.
गुड मॉर्निंग. यस सर.
मेरा गुरु दिख नहीं रहा है. ही इज नॉट सीन.
यस सर, अभी दिख रहे हैं. गुड मॉर्निंग टू एवरीबॉडी.
इनफॉर्मल डिस्कशन है.
गुड मॉर्निंग सर.
गुड मॉर्निंग.
चैलेंजिंग है ना.
आ गया गुरुजी. नमस्ते.
आ गए.
यस सर. नमस्ते सर.
नमस्ते.
नमस्कार.
हाँ नमस्कार डॉक्टर
सर. नमस्कार. नमस्कार सर.
नमस्कार. नमस्कार.
नमस्कार.
सर गुड मॉर्निंग सर. गुड मॉर्निंग.
कतोरे सर नमस्कार.
नमस्कार सर.
कळडे सर, तुमचा जो व्हिडिओ कॅमेरा तो सर तो थोडासा खाली घ्या सर. दिसत नाहीये सर तुम्ही. कळडे सर.
ठीक आहे.
यस सर. नाउ इट इज ओके.
नमस्कार सर.
नमस्कार.
जी कतोरे आ गया. ये कौन है? स्वप्निल गोरे. नीलाश फोन.
नीलाइश फोन में सर करडे सर ज्वाइन है सर. करडे सर. नीलाइश फोन बोले तो करडे सर. नीलाइश आईफोन करडे सर ने ज्वाइन किया है सर इसका.
फोन पर है क्या?
हाँ करडे सर है ना सर. करडे सर है सर. ज्वाइन है.
नमस्ते.
नमस्कार. नमस्कार. नमस्कार.
नमस्कार प्रोफेसर कराडे साहब.
नमस्कार. नमस्कार.
Now you have a new look, it seems. Professor Karade has new look.
No. Same look. How can I change in the old age?
Hey, this one at cap.
Oh, because I have shaved down. It's complete. After shaving.
Acha.
So it is totally shaved.
Very good. Very good. That's good. How are you, sir? How is everything?
Everything is fine. Very fine.
Yeah.
Okay, sir. Shall we start the proceeding? Sanjit sir.
Yes sir. अल्फ्रेड सर.
हाँ सर.
चालू करना है. करो ना.
हाँ वही बोला हूँ मैं. चालू करूँ क्या बोले.
पुरके साहब तो हो गए ना ज्वाइन.
हाँ सर ज्वाइन हो गए.
प्राचार्य आगरकर सर.
हाँ सर भी ज्वाइन हो गए. आगरकर सर भी ज्वाइन हो गए हमारे प्रिंसिपल सर.
हाँ.
चालू कर देता सर. फिर मैं चालू कर देता.
हाँ.
A very warm good morning to one and all present here. Ladies and gentlemen, to this magnificent, glorious day, the world is full of diamonds and gems, and we are having some of them here today to build this event. The galaxy of intellectuals, honorable guests, and brilliant teachers respected participant, and beloved college colleagues. And how lovely is this day. At the outset, my humble pranam at the lotus feet of Sant Gadge Baba. A very famous quote of Sant Gadge Maharaj, the one who gets the victory over time gets the victory over the world. On behalf of National E-Conference on Recent Advances for Innovative Research in Mathematics, myself, Dr. Alfred Sheikh, welcome all the dignitaries. And this conference is arranged by Department of Mathematics and IQAC, Indira Gandhi Kala Mahavidyalaya Ralegaon, District Yavatmal, in collaboration with Department of Mathematics and IQAC, RA Arts, Shri M.K. Commerce, and Shri S.R. Rathi Science College Washim, District Washim. So I welcome all the dignitaries. Firstly, I would like to invite our Honorable President, Professor Vasantrao C. Purke sir, President late Chinduji Lakshmanrao Purke, Shikshan Prasarak Mandal Yavatmal, to be the chairperson of this inaugural function. Thank you, sir. Now I would like to request Dr. T.M. Kurde sir, former Honorable Vice Chancellor, Indian University Raipur, to be the chief guest and inaugurator of this function.
Yeah.
Thank you, sir. Again, I would like to request our distinguished guest, Dr. D.R.K. Reddy sir, ex-professor and head, Department of Mathematics, Andhra University, Visakhapatnam, to be the distinguished guest of this inaugural function.
Thank you. I'm here.
Thank you, sir. Again, I would like to request Dr. S.D. Katore sir, professor and head, Department of Mathematics, Sant Gadge Baba, Amravati University, Amravati, to be the guest of honor of this inaugural function. Thank you, sir. At the same time, I would like to request Dr. S.V. Agarkar sir, our principal, Indira Gandhi Kala Mahavidyalaya Ralegaon, the convener of this program, and also Dr. M.M. Sancheti sir, principal, RA Arts, Shri M.K. Commerce, and Shri S.R. Rathi Science College, Washim, the convener of this national conference, to be the part of this inaugural function.
Thank you, sir.
Lastly, I would request Mr. V.D. Samartha sir, IQC coordinator, and Dr. R.G. Maske sir, IQC coordinator of both the colleges, to be the part of this inaugural function.
Thank you, sir.
Thank you so much. A ray of light is a ray of hope. Let's all leave the darkness and step towards the bright path. Due to this pandemic, our traditional auspicious lamp lighting ceremony as a tribute to Mother Saraswati, the goddess of knowledge. The main objective of this conference is to provide forum for the researcher, eminent academician, research scholar, and students to exchange ideas, to communicate and discuss research findings and new advances in mathematical sciences. Now, with this, I welcome all the dignitaries with a token of with flowers as a token of love, and on behalf of Indira Gandhi Kala Mahavidyalaya and RA Science College, I welcome all the dignitaries. Thank you so much. Now, I would like to request Mr. V.D. Samartha sir for the introductory speech.
Am I audible, sir?
Yes.
Yes, sir. Yes, sir. Yes, sir.
Yeah. Thank you. Good morning. Good morning to one and all. On behalf of Indira Gandhi Kala Mahavidyalaya Ralegaon, myself, Mr. Vivek Samarth, Coordinator IQAC, welcomes all the respected dignitaries, participants for the National E-Conference on Recent Advances for Innovative Research in Mathematics, organized by Department of Mathematics and IQAC, Indira Gandhi Kala Mahavidyalaya Ralegaon, in collaboration with Department of Mathematics and IQAC, RA Arts, Shri M.K. Commerce, and Shri S.R. Rathi Science College, Washim. The main aim of the conference is to bring together learned mathematicians, scientists, engineers, researchers from industry and research scholars working in the different areas of mathematics. This conference will provide a good platform for exchange of innovative ideas regarding the research findings and the recent advances in the wide areas of mathematics. Further, it will provide an opportunity to enhance collaboration among mathematicians for strengthening research and development activities. I'm very happy to share that we got 450 registrations and 115 paper abstract for this conference. This conference is having keynote addresses of eminent dignitaries, invited talks, and paper presentations. I wish both the organizer for making this event a successful one. Thank you. Jai Hind, Jai Bharat. Thank you, sir.
Thank you so much, Samartha sir. Now I would like to request our principal, Dr. S.V. Agarkar sir, to guide us. Agarkar sir. I would like to request Dr. S.V. Agarkar sir, our principal, Indira Gandhi Ralegaon, to guide us.
Hello. 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 Hello.
Due to some technical reason,
Bandwidth is
sir
low. Bandwidth is low.
Yeah. So due to technical reason, some technical reasons are there. Now I would like to request Dr. M.M. Sanchiti sir, Principal RA Arts, Shri M.K. Commerce and Shri S.R. Rathi Science College, Washim, to please give guidance speech in this regard.
Thank you, sir. Good morning to one and all. Chairman of today's inaugural function, Professor Vasantarao Purke, Honorable President Chinduji Lakshman Rao Purke Shikshan Prasarak Mandal Yavatmal, Chief Guest and Inaugurator, former Honorable Vice Chancellor Dr. T.M. Kardesar, Distinguished Guest Dr. D.R.K. Reddy sir, and today's guest of honor Dr. F.C. Raghuvanshi sir, Dean Science and Technology, Sant Gadge Baba Amravati University Amravati, and my guru and guide and colleague in RA College, Professor and Head Department of Mathematics, Sant Gadge Baba Amravati University Amravati. Dr. S.V. Agarkar sir, Principal Indira Gandhi Mahavidyalaya Ralegaon, all the dignitaries, Sahu sir, and all the dignitaries, organizing committee members, and all the participants. I welcome all of you for this national e-conference on recent advances for innovative research in mathematics, organized by Department of Mathematics and IQAC, RA Arts, Shri M.K. Commerce and Shri S.R. Rathi Science College, Washim, in collaboration with Department of Mathematics and IQAC Indira Gandhi Mahavidyalaya, Ralegaon, District Yavatmal. Today, I am very happy and feels proud to say that on this occasion, all such eminent personalities are present on this virtual platform to discuss the recent advances for innovative research in mathematics. In the current scenario, mathematics plays an important role in developing robotics and automation systems, mechanical and civil engineering, and many others. During this decade, we are facing economic as well as ecological challenges. To sort out these challenges, it is necessary to develop innovative methods and solutions in the mathematical research to meet new demands. I am very much sure that today's national e-conference will be the step towards the innovation with the creative views of all the dignitaries present on this platform. As a convener of this national e-conference, I again welcome to all the mathematicians and participants of this conference. Thank you. Thank you very much.
Thank you so much, sir, for your valuable guidance. Now, our guest of honor, Dr. F.C. Raghuvanshi sir, is not here due to some technical reasons. So let's move forward. Now, I would like to request Dr. S.D. Katore sir, Professor and Head, Department of Mathematics, Sant Gadke Baba Amravati, to guide us.
Good morning to one and all. Honorable Professor Professor, Chairman of this academic event. Honorable Professor T.M. Karde, our mentor and guru and inspiring center. Honorable Professor D.R. Reddy sir, a motivating and inspiring center for us. Honorable Dr. F.C. Raghuvanshi sir, Honorable Dean, Science and Technology, Sant Gadke Baba Amravati University, Amravati. Conveners for today's event, Professor Sanjiti, Principal, RA Science College, Washim, Principal Agarkar sir. Convener Dr. Alfred sir, and the coordinators of IQAC of both the colleges. First of all, we must congratulate both the institute for organizing this national event, which is the first event from both the institutes in mathematics, and that too jointly they are organizing this event. We must congratulate and we must thank the managements of both the colleges for this event support. Is now the mandatory component in today's culture, as these factors, these
आवाज कटून राहिला. सरचा. माइक बंद केला.
As these aspects are related to the placements and promotions of the teachers, and hence every teacher must have the research aspect, and that too develop with the quality research in the relevant subject. Also, we must note that the interdisciplinary approach for the research is needed, and in that way we must have to select the problems, and the relation the publication is concerned, we must have the scopus and quality publications. For the today's event, the participants will be definitely benefited with the honorable speakers, and there are many research papers which will be definitely net issue. These problems will definitely will be beneficial for the current researchers, and the event will be beneficial for all the research community. The research, today's event will be beneficial for all the research communities, and as we have a mentors, our guru, TM Karde sir, Reddy sir, Honorable Purke sahib, and the guidance of them will also encourage and inspire all of us. Thanks for giving the opportunity to me. Thanks the organizer. Okay, sir. I thanks the organizer for giving the opportunity. Okay.
Thank you, sir. Thank you so much, sir. Thank you so much. It's a humble request to all the participants. Please mute your mic so that there should not be any disturbance to the speaker while they are expressing their views. Now, it's my privilege to invite our distinguished guest, Dr. D.R.K. Reddy, sir, ex-professor and head, Department of Mathematics, Andhra University, Visakhapatnam, to guide us for this inaugural function.
Good morning to all of you. Am I audible?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yeah.
Yes.
Good morning to all of you, all the honorable guests and honorable participants, for everybody. Now, my dear Professor Pudke Saab, Honorable President, Dr. Karade Saab, my friend, my philosopher, my mentor and everything, Dr. F.C. Raghuvamshi sir, Dean Faculty of Science, Dr. S.D. Katore, my guru, I call him my guru. So, and Dr. S.V. Agarkar and Dr. M.M. Sancheti and Dr. A.Y. Shaikh and other distinguished persons that are there on the conference. Thank you very much for inviting me as a, what do you call, you have called me distinguished guest. Okay. I am distinguished guest. I have been associating with the Nagpur or Amravati and every academic activity. Either it is a conference or it is a lectures or it is anything. I have been, this is because of my, I usually call him my brother, that is Professor Karade. That is, he is the one and only person in Vidarbha area who has introduced relativity to that area and who has strived hard to develop relativity, research in relativity, and I used to tell everybody that as far as I know, there are only 9 planets for the sun, SUN sun. 9 planets or 8 planets now going round the sun. I don't know how many planets are going to round this sun of the soil, Professor Karade. There are so many people he has developed and he has guided and he has acted as mentor for so many people. Now, I congratulate at the outset the organizers. I may not be in a position to name organizers, I will say, please excuse me. I congratulate the organizers for conducting this conference, e-conference. During this pandemic situation also, they have taken interest in conducting this conference. The only aim perhaps is to invite researchers all over the nation to interact with each and everybody on the subject, not only on mathematics, not only on relativity, but also on other mathematics subjects. So this is a very welcome activity, even though we have been suffering for the last 2 years, perhaps with the pandemic situation, but they have made a valiant effort to conduct this conference. Conferences of this type should be conducted quite often so that there will be very much continuous rapport with the researchers all over the country, and that will develop the activity of research in this country. Now, talking about relativity, you know, mathematics, of course, let me say first this one. Mathematics is the queen of science. Usually we call mathematics as the queen of science because physics is great. Physics is great. I usually say this. Physics is great. For example, if you take Newton's 3 laws of motion, everybody continues to stay in a state of rest or of uniform motion unless an external force acts on it and moves it in the direction of the force. To every action, there is an equal and opposite reaction. F is equal to ma. See this F. See, if you go on saying these laws, they will look like poetry. If you talk about Newton's laws, go on repeating the laws. They will look like poetry unless they are transformed into mathematics and work out the consequences. The physics will not be developed. You cannot go further without mathematics. Physics is great, I said, but mathematics is also great because mathematics is making the physics great. That is why I call it queen of science, because behind every king or a great man, there is a lady. That lady is the queen. That is the mathematics. So mathematics has that importance. Now, if you consider any real world problem, all the real world problems can be reduced to either engineering problems or physical problems or biological problems or socio-economic problems. So all these problems can be dealt with mathematics. The only subject that can be dealt with, we deal with all these subjects is mathematics. So the importance of mathematics is that, and therefore the mathematics should be developed in all respects, in every subject, in every area. So mathematics is there, and so that is the importance of mathematics these days. Now, all the people are attending this conference, and this type of conferences will invite people to do research. For example, if there are postgraduate students, they may be studying. So if they attend this type of conferences, they will be interested and they will be inspired and they will get motivation, and so that they will come for research. Now, what is happening these days is, let me say this, either you study BTech or you study PG, and immediately they are going for some jobs. Nobody is going for research. There are only a few people who are continuing for research. So if you want to develop the research activity in this country, you have to conduct this type of conferences. That way, I congratulate the colleges which are conducting this conference on this occasion. And one more thing I am disturbed is, conferences are also going on online. And there is a problem these days, the research is also going on online. There were days people used to sit together, discuss and get results and then publish the results. Now these days, when the online technology has been improved, one can be in India and one can be in America and one can be in London. They can join together and publish research papers. I don't know how. This is the online research. So that type of research, of course, I don't say anything about that, but the healthy discussions, continuous interactions, I don't think they are, I think they are missing. So what I suggest is people should sit together and discuss and then get results and then get them published. So that way there will be healthy research in the country and there will be many more publications and people will be also motivated. When a group of people are in the department discussing on research and the other students who are there in PG colleges or PG students, they will be inspired by these discussions. And therefore, this type of conferences will influence such people, such students. The conferences will attract those people towards research. And so therefore, I congratulate once again the colleges who have made this valiant effort during this pandemic situation. And I thank all the members or college organizers for giving me this opportunity, and thank you.
Thank you so much, sir, for your valuable guidance regarding with the research and the publications. And definitely this will motivate all the researchers for doing good work and should have a healthy discussion, sir. I'm really thankful on behalf of our organization committee. Now, I am profusely elated to take an opportunity to invite our chief guest and inaugurator of today's function, Dr. T.M. Curtis, sir, former Honorable Vice Chancellor, Indiana University, Raipur, to guide us for this session.
Okay. Good morning to everybody. Hope I am audible to you.
Yes, sir. Yes, sir.
Okay. Thank you. Honorable Chairman of the event, Professor Purkeji, guests of honor, my friend, brother, Professor Reddy, Professor Katore, Principal Raut, Principal Dr. Sancheti, other researchers, teachers. I'm happy that today you're organizing an e-conference on recent advances for innovative research in mathematics. This has been jointly sponsored by the Department of Mathematics of Indira Gandhi Mahavidyalaya, Ralegaon, and Department of Mathematics of Arts and Shri S.R. Rathi Science College, Washim. Indeed, it is a joint venture, and here lies the cooperation of two principals, two mathematical heads, Principal Dr. Agarkar from Ralegaon and Principal Dr. Sancheti from Washim. And heads of the department, Dr. Sheikh and Dr. Sancheti again, because he's playing, I hope he was the head of the Department of Mathematics. And here is a contribution of Professor Gore, a young researcher. I'm happy that he is a serious worker. When I am congratulating you upon the organization of the two conferences, I am rather disturbed with the two words, recent advances. The work is recent. And another is innovative. You know all that recent is not a scientific word, it is a fuzzy word. When I call it as something is recent, it may be 100 years ago or 1,000 years ago or 1 million years ago. So when we talk about mathematics and its innovation, what is my research? Which recent work you are talking about? As a matter of fact, if you see the today's scenario, nowadays all the academic communities are running after so many aspects of the scientific disciplines, including computer science, machine learning, and fuzzy discipline. So in this conference, I will say that I am not seeing any research paper on fuzzy discipline. Everything is fuzzy. You see, you all know our life is itself fuzzy event. No doubt when science developed, science never accommodated uncertainty. Science stands for certainty. But it was later on realized that you have to incorporate uncertainty in the scientific disciplines. And this has been achieved by the introduction of fuzzy logic. We were learning the Aristotelian logic having two values, 0 and 1, that is a false or true. But when I talk about any proposition or any statement, any open sentence, it can be true or it can be false. So the truth value is 0 or 1. In fuzzy logic, what happens is this: you include the whole spectrum. It is an open set, starts with 0 and 1, and all the values in between 0 and 1 are accommodated. It means now, when we talk about the proposition, it need not be only true or false, but it can be both. This is certainly a very, I can say, innovative idea, and this has been used in all our everyday working. Second thing, a very, very recent, advancement in research is machine learning. We operate these computers, and now computer is a machine. Now the idea is this: see, when we give some suggestions to machines, machines do react, right? Now the next stage is, can you see that machine can behave like a human brain? And you'll be wondering, those who work in machine learning, they are getting the grants to the tune of crores, and this is mostly studied by engineers and computer engineers. But if you see the contents of the machine learning, it is the whole and soul business of your mathematics. As I told you, I am born when India was not independent. So we are old people. Now the question is that when you are organizing these online conferences, please note, you may have the development, scientific development, computer development, but my dear friends, you cannot download bread. Google cannot download bread. Why? Because bread is the main content of the sustenance of your human body. Like that, mathematics is the main sustenance of all sciences. One of the Nobel Prize winners, Leon Lederman, has written a book on God particle. In his, he states particularly very, very precisely that sound mathematics forms a very sound basis of all sciences. Therefore, to me, you cannot learn mathematics online. Can you have your parents online? It's practically impossible, I tell you. And that's why, but nowadays it is very easy, very convenient to organize such conferences. So let me congratulate the two colleges. They have taken the lead to organize this scientific event. Behind this scientific event, I see one thing very common. and that is the role of Professor Kathore. Professor Kathore is retiring, and on his superannuation to celebrate these two colleges organized. I don't know, the reason is very simple, because Dr. Sancheti, he was his colleague and also the research scholar of Professor Kathore, and moreover, Professor Gore is the student of Professor Kathore. Therefore, these colleges have come together and organizing an event. As a matter of fact, I am not supposed to talk more. When Professor Gore told me that 5 to 7 minutes are enough for me, I hope so. And as a teacher of mathematics, I tell you, research doesn't mean that you are carrying a mountain on your head. This is the idea amongst these young researchers. You can take the very, very basic problems. And what is the basic problem? The basic problem, you see, geometry, algebra. Have you thought about this one? No. But live in space. We work in space. We die, we are born in space, and we are going to die in space. So the geometry is very important. How is space? Can you not think on this problem, very simple problem? And the first thought was given by the Greek mathematicians, philosophers, and the starting point is Euclid. Euclidean geometry. Euclidean geometry is only the elements written by Euclid. When 23, I think it is 2400 years ago. This is the only book befitting the Bible. These two old books, Bible and the elements, they are the oldest monuments and documentations of the human brain. My dear researchers, I tell you, can you not think at even the school level, have you thought about this? What are the basic things of the Euclidean geometry? And now you are working on Riemann geometry, general relativity, quantum mechanics, and so on and so forth, where the basic background is geometry and geometry only. Do the thought. See, the Euclid has developed the geometry having 23 definitions. You know, if you see the Euclidean geometry, there are 23 definitions, 5 notions, and 5 postulates. And the last, fifth postulate, or that is called the parallel postulate, has given the birth of so many geometries. We have to learn about the Riemann geometry, differential geometry, and non-Euclidean geometry. The basic is the fifth postulate of Euclid. Have you thought over all these problems? No. I am sorry to say that our teachers, where they are working in school or in colleges, I am doubtful whether they have understood the fifth postulate and the later developments of the geometries. Anyway, I am thankful. I don't want to, as a matter of fact, I am a retired professor. I can talk, a mathematics teacher can talk hours together, but I don't want to take much of your time. I am thankful to the organizers for giving me an opportunity to participate in the conference as a guest. With these words, I declare that the EE conference is inaugurated. Thank you very much.
Thank you so much, sir. Now, it's my privilege to invite our Honorable President, Professor Vasantrao Purke sir, late Chintuji Lakshmanrao Purke Shikshan Prasarak Mandal Yavatmal, for his presidential speech.
Good morning, everybody.
Good morning.
Sir, good morning.
Good morning to all. Honorable Chief Guest, Honorable Dr.
R.K. Reddy sir, Honorable Raghuvanshi sir, and outstanding Professor Dr. Katore sir, and convener Dr. S.V. Agarkar sir, Dr. M.M. Sanchiti sir, and Dr. Alfred Schmidt sir, and all participants in e-conferences. So far as the mathematics subject is concerned, our genius Professor Dr. Reddy said, mathematics is the queen of the science, and Dr. Karade sir said now the main sustenance of the science is the mathematics. As my is concerned, I belong to arts faculty. So far as mathematics is concerned, I will think that mathematics is the soul of science and of the world. So this is a very significant subject, and I am requesting all researchers and professors, those who belong to mathematics, whenever they teach the students, they should teach the students, and whenever the students are listening to the mathematics professor, they should be given the intoxicating experience of the effective teaching of the mathematics. So APJ Abdul Kalam says, education is the endless journey through knowledge and imagination. So this subject is very significant, very important subject, and it is to be taught to the students very simply, so that they will be in position to understand the mathematics. They will be in position to understand the basic concept of the mathematics. So it is a very significant subject, and this organized by both colleges, Arts, Commerce, Science College, Washim, and Indira Gandhi Mahavidyalaya, Ralegaon. I congratulate them that they have taken part in such a significant conference. So I will thankful to them, and all professors and all genius professors. They should, and already they have served the country. So far as their subject and their job is concerned, given a good service to the nation. So on behalf of all people, I must thanks to you. All the best.
Thank you, sir, for your guidance and the mentorship you have considered for organizing such a beautiful event. Now, I would like to request Mr. S.V. Gore, sir, to propose vote of thanks.
A lovely and warm morning to most valued and worthy guest, respected professor and all participants. Myself, Mr. Gore, Assistant Professor, Department of Mathematics, Indira Gandhi Mahavidyalaya, Ralegaon. It's a matter of pride for me that I am proposing a vote of thanks for this national e-conference on recent advances for innovative research in mathematics. On behalf of Department of Mathematics and IQAC, Indira Gandhi Mahavidyalaya, Ralegaon, District Yavatmal, and Department of Mathematics and IQAC, RA Arts, Shri M.K. Commerce, and Shri S.R. Rathi Science College, Washim. I would like to thank Professor Vasantrao-ji Purke, President late Chinduji Lakshmanrao-ji Purke Shikshan Prasarak Mandal Yavatmal, for guiding us throughout this organization of National E-Conference. Also, I am thankful to Dr. T.M. Kardesar, former Honorable Vice Chancellor, Indiana University, Raipur, for giving his valuable time and guiding us to make this event successful. At same time, I am thankful to the distinguished guest, Dr. D.R.K. Reddy sir, ex-professor and head, Department of Mathematics, Andhra University, Visakhapatnam, for enlightening us new innovation of research in field of mathematics. I am also thankful to the guest of honor, Dr. F.C. Raghuvanshi sir, Dean Faculty of Science and Technology, Santa Gadegava Amravati University, Amravati, for sparing his time and giving a motivational guidance, overall development of research in mathematics. Again, I am thankful to Dr. S.D. Katore, sir, my mentor and my guru, Professor and Head, Department of Mathematics, Sant Gadegava Amravati University, Amravati, to enlightening us and giving guidance throughout the arrangement of this national conference. I am also thankful to the convener, Dr. S.V. Agarkar sir and Dr. M.M. Sancheti sir, for giving constant encouragement and guiding throughout this organization of this national conference. I am also thankful to the IQAC coordinator of both the colleges for giving a chance to our department for organization of such a mega event. I am also thankful to Dr. A.Y. Sheikh sir, coordinator of this conference, for giving huge support and moral support and to organization this national conference. Last but not least, I am also thankful to Mr. Bhushan Bhatti and Mr. Amol Lidkar, along with all the head of departments and supporting staff of both the colleges, for giving hand-to-hand response and support for the organization of this national e-conference. Now, with the permission of chair, I hereby declare that the inaugural function is over. Now, please to join immediately after this function to keynote address of Dr. D.R.K. Reddy sir. Thank you.
Now I would like to request Dr. S.P. Hatkar sir, Assistant Professor and Head, Adarsh College, Hingoli, to please take over the charge for the keynote address.
Thank you, sir. Honorable dignitaries, learned delegates, respected teachers and students, a very good morning to one and all. I, Sachin Hatkar, feel privileged to welcome you all on behalf of organizing committee of one-day national conference. It will be my privilege to invite Dr. T.M. Karde sir as the chairperson of this keynote address. Ladies and gentlemen, Dr. T.M. Karde sir is Einstein of our region, who do not need to be introduced. The name is enough. Karde sir has completed PhD from IIT Kharagpur and DSc from Nagpur University and Amravati University. Sir was former professor and head Department of Mathematics, Rashtra Sant Tukdori Maharaj, Nagpur University, Nagpur, and former Vice Chancellor, Indian University, Raipur. Sir was Dean of Faculty of Science, Nagpur University, member of Management Council, member of Executive Council, Senate member, member of Academic Council, Chairman, Board of Studies of Mathematics, Chairman, Ad hoc Board of Studies of Computer Science, Chairman, Ad hoc Board of Studies of Environmental Science, Chairman, Disciplinary Action Committee. Sir has guided 22 PhD students and 13 MPhil students. Sir is editor of Proceeding of Einstein Foundation International and referee of Indian and foreign journals. Sir is a PhD examiner and sir has 120 publications in national and international journals. Sir is a member of academic board of academic bodies, Tensor Society, American Mathematical Society, International Association of Mathematical Physics. I welcome Dr. T.M. Karde sir. Welcome, sir. Hello. Hello. सर आवाज येतोय का गोरे सर?
आवाज येत आहे सर, आवाज येत आहे सर.
ओके. करडे सर, हॅलो, आहेत का सर?
Link must have gone. His link must have gone. आपने आइंस्टाइन बोले, आइंस्टाइन के पास गया होगा.
So
Karde
next,
sir, Karde sir.
And no problem, you proceed. What is that?
okay sir.
Karde sir must be join हो रहे हैं sir, join हो रहे हैं.
Okay, okay.
हाँ, हाँ.
So let us introduce our speaker. I will be a privilege for me to invite another distinguished personality and legendary Dandala Radhakrishna Reddy Garu. Again, whose name is enough and who do not need to introduce. But as a matter of this procedure, I would like to say few words in this regarding about Reddy sir. Sir has title of thesis of Dr. Reddy sir was a certain investigation in branch-dick scalar tensor theory of gravitation, and first time on this branch-dick theory sir has completed his thesis. Area of research: Einstein and other theories of gravitation, cosmology and astrophysics. Sir was an academician and administrative officer in Andhra University, professor and head of Department of Mathematics in Andhra University, chief of examination in Andhra University. Again, sir was a professor and head of math department, ANITS Engineering College, Visakhapatnam. Sir has completed one CSIR project and one DST project. Sir has given or guided 14 students, PhD students, and 3 are working now. Sir has a 260 huge international publications. And a special thing about is sir is an associate editor of astrophysics and space science, reviewer of astrophysics and space times, and International Journal of Theoretical Physics. Recently, sir is elected as a fellow of Royal Astronomical Society, London. Sir has written 4 books, and sir has organized 3 international and 10 national conferences. So I request Karde sir, please start the session. Hello, Gore sir, येतोय का आवाज?
Yes sir, I think sir again that Karde sir left.
Okay.
Don't worry. Don't worry.
Okay.
No problem. He is there. He is there, very much there. Don't worry. Okay, you can.
Please start your keynote.
Start the session. Reddy sir, you start the session.
Okay. Respected chairman sir, chairman of the session, and the interested participants, and the participants who have been motivated and joined to the e-conference. Now, your name Dr. Hatkar. See, Dr. Hatkar said Einstein of Vidarbha area. See, when Einstein is chairing, and D.R. Reddy is known as Einstein of Andhra Pradesh. That is the problem. One Einstein is chairing, another Einstein is talking. One Einstein of one area, another Einstein of another area are there in this great conference. So, but I know Professor Karade is the genius of the Vidarbha area. And he is the key for Vidarbha area, relativity, key for relativity in Vidarbha area. When a key of Vidarbha area is chairing, another myself giving keynote address. That is again a Herculean task. Anyway, but people from Professor Karade, not Professor Tade, Professor Katore, they have requested me to give keynote address. Now, generally, what is this keynote address? Keynote address should not be an advanced research paper. One cannot present research papers and get out saying that I have given keynote address. Keynote address should be a key to the subjects or to the research that is going to be presented in the conference. That means basically it should be fundamentals. There are participants who have just completed postgraduate courses. There are participants who have just started doing research. And these days, you know, people register for research immediately and people come, sir, give me a problem and I will do research. And so they take a problem and they take a paper and they have changed something and do the research without going into the fundamentals. So this keynote address should be always fundamentals. These fundamentals should be clear whenever anybody starts research. And therefore, the keynote address should attract researchers towards the subject. So here my subject is relativity, cosmology, and this. So let me go ahead with this. See, this is very simple. And there may be some things which I have already talked in many conferences, but what I want is that everybody should be clear about the fundamentals. And I said the title is Bird's Eye View of Universe, Black Holes, and the Wormholes. I said bird's eye view. I am a small bird, not a eagle bird. You know, eagle bird can see everything clearly, even from big heights. But I am not that bird and I will not go into the details. Okay, I am a small bird. I will have a small bird's eye view. Okay. So let me start with this introduction. So this is not for experts in the field. Please note that if there are experts, my keynote address is not for experts. It is only for students, PG students, or the researchers who are going to start their research. They should be clear about the subject, and therefore this is my keynote address. So this goes as universe, black holes, and wormholes. I will, because to save time, I will go reading with this. So next slide, please. Next slide. Who is there? There must be somebody to give next. Oh. So this lecture consists of the following: introduction, universe, everything about the universe, Big Bang theory, geometry of the universe, various physical sources used to obtain cosmological models, and dark energy, dark matter, modified theories of gravitation, general relativity, Einstein's theory. Everything comes in this. Next slide. Next, please. Who is doing this? Again, I will come to black holes. How do black holes form? What do black holes look like? How big are black holes? I told you I am not going into the advanced level of these black holes. And wormholes also. What are wormholes? There are experts in this conference who can present wormholes research papers also. Anyway, now, next thing is steps in constructing cosmological models. What are the basic steps? See, everybody start research. So first they should know what are the basic steps to construct models. Why you should construct models of the universe, I will come back to that. This is only introduction here. I am going through the steps. A quick review of literature and recent scenario of the universe. Next slide. Next, please. Introduction. Next. Next. No. Before that. Motion. Right.
Sir, your voice is not coming. You are not audible. सर आपने आपका माइक बंद कर दिया सर. You have to. आपका माइक बंद कर दिया आपने. You unmute yourself. Okay.
Now audible?
Yeah, it is audible.
Now
Yes,
should
sir,
I
yes,
start from the beginning?
Yeah.
First slide?
No, sir, no. Motion force.
Motion, okay. I said, in the universe, the basic thing is motion. Everything is moving in the universe. You may say that we are sitting and we are not moving, but everything is moving with respect to something else. So the motion is caused by forces. And what are these forces? Forces may be applied forces. That means you can apply force. With physical means, you can apply force that gives you a force. And motion causes. And another thing is force is central forces. They are not man-made forces. They are God-made forces. They exist already in nature, namely gravitation, for example. So applied forces are man-made forces, and central forces are God-made forces that already exist in nature. Next, please. There are four fundamental forces. The researchers should follow these things, basic things. Four fundamental forces of nature are gravitational forces, weak nuclear force, electromagnetic force, and strong nuclear forces. Now, there is another force recently, namely dark energy. The recent discoveries, they say there is another force, namely fifth force, that is dark energy. We'll come back to that later. Okay. Applied forces, all these applied forces are governed by Newton's three laws of motion. Newton's trio, we call it. Applied forces are governed by Newton's trio, and gravitational forces are governed by Einstein's law of gravitation. These are the two things that one should remember. There are some disturbances, I think. Okay. Applied forces are governed by Newton's trio. Gravitational forces are governed by Einstein's law of gravitation. Next slide, please. Okay. Now, knowing these things, we will come back to this thing. What is the need for research in relativity and cosmology? What is the need? Why should we do research in relativity and cosmology? That is the basic thing. The basic thing is to study the physical systems in relative motion. Because in the universe, nothing is at absolute rest. Everything is in relative motion. So the need for research is to study the physical systems in relative motion, to find the effects of gravity on the motion of planets and celestial bodies. That is another thing. To determine cosmological models of the universe and study the universe they represent. Why should you study the cosmological models of the universe? That is another question immediately. Because we are living in this universe. As somebody said, Jina yaha, marna yaha, iske siva jana kaha. You can't go run away from this universe. So you are living in this universe, and hence we should know about the origin, geometry, physical content, and ultimate fate of the universe. Suppose I am in this room, I should know about the geometry of the room and how to get out of this room, and how you cannot get out of the universe, of course. Okay, what is the shape of this room? All these things. What is the content, physical content of this room? Similarly, we are living in this universe. So we should study about this universe. We should know what is the origin of it, and what happens ultimately, and what is the physical content of this universe, and so on and so forth. How to study this. Now, one more thing we should remember is, we are going relativity and cosmology. Relativity goes along with cosmology. Why? Why not fluid mechanics? Because in cosmology, we study of the universe. In cosmology, we study this large-scale structure of the universe. Motion of planets, motion of stars, everything. Now, what is the basic force governing all these things in the universe? The basic force governing the planets are going around the sun. What is the force? Force of attraction. That is gravity. Sun's gravitational field. Similarly, in this universe, the basic force, God made force, is gravity. So, cosmology, in cosmology, we use Einstein's theory of gravitation, because Einstein's theory is the best theory that describes gravity. And gravity is the force that binds everything in this universe. And therefore, Einstein's theory is used in studying relativity and cosmology, in cosmology. Okay, next please. This can be done. Okay. I have given that slide already, everything. So we construct models of the universe to study about the universe. So I would say something about mathematical modeling. Not only in relativity, but in every subject, biology, social sciences, medicine, everywhere. What everybody is doing is research, research, research. What are we doing? We are constructing models, even in medicine, even in population, suppose social sciences, population control, population model, even in medicine, even in chemistry, even in physics, everywhere we construct models and then study their consequences. So mathematical modeling is a basic thing in this universe, whatever may be the subject. Next, please. Next slide. So what happens? Real problem. We have so many real problems in this universe. You come across real problems. Okay, motion of planets, motion of this thing, motion of that, everything. So real problem. Real problem will be converted to mathematical problem first. Take a real problem, convert it to mathematical problem, find mathematical solution, and then interpretation, and then go back to real problem and discuss. This is what happens in any subject. Next, please. This we do in relativity cosmology also, same thing. Next. All the investigations that we are doing in mathematical sciences, biological sciences, social sciences come under mathematical modeling. How do you do this? Given a physical situation, we form the differential equation first. Solve the differential equation. Determine the constants using initial conditions. See, these are the basic things. Given a physical situation, we form the differential equation. For example, I told you again, Newton's laws. Take Newton's second law of motion. Force is proportional to mass into acceleration. Force is proportional to mass into acceleration. Go on saying, this will look like a beautiful English poetry unless they put it into mathematics. So force is proportional to mass into acceleration. F is equal to ma. When you convert it to mathematics, force F is proportional sign ma is equal to k into ma, k1. So F is equal to ma. What is that? F, force. M, mass. A, acceleration. Acceleration means d square x by dt square. You get the differential equation. Simple thing. So given a physical situation, we form the differential equation. Then solve it. For example, take that equation is equal to F is equal to ma. Mass into acceleration. Switch off the force. Switch off the force. Force 0 kar do. What happens? You get d square x by dt square 0. What is this? Acceleration is 0. Integrated x velocity. Velocity is constant. That is uniform velocity. Then Again integrate, you get distance moved. So you can work out all the consequences. Once you get a model, you can get all the consequences. This is basic thing, what happens in each and every subject. Take a real world problem, make it mathematical. Mathematical means constructing a differential equation. So determine the constants using the conditions, initial conditions or boundary conditions. Next slide, please. No, not that. Before that. Using initial condition, interpret the solution, draw conclusions. That finishes everything. So you can now see differential equations play a vital role in every subject. Not only in mathematics or relativity or every subject, differential equations play the vital role. Even in life, I used to say this every time. Even if you are bored, I will again tell you this. Life is a non-linear differential equation. Wherever I go, I say this. Life itself is a non-linear differential equation with infinite number of boundary conditions. See, if you take life, it is function of so many things. Life has so many functions, okay? It is function of so many variables. Now, take a differential equation, non-linear differential equation. You don't get an exact solution for life. You have several problems. If you try to solve one problem, there will be another problem. You don't get an exact solution. Suppose I want to purchase a flight. I can't do it for my things. So I have to adjust. That is boundary condition for me. So for everybody, life is a nonlinear differential equation. You don't get exact solution because nonlinear differential equation will not have exact solutions. Generally, they don't have exact solutions. So that is why I compare life itself is a nonlinear differential equation with infinite number of boundary conditions. Next, please. So please realize the importance of differential equations in physics or mathematics or medicine or anywhere. So this is a picture of the universe. Just to see this, there is nothing I can say about this. It's a show. Okay, next. Now cosmology and Big Bang theory. What is cosmology? I told you cosmology is nothing but study of the large-scale structure of the universe. How do you study it? You construct mathematical models of the universe. Now, what is the basic theory that is at present it is in vogue is Big Bang theory. Now, the Big Bang theory is the present day, it is generally accepted theory is Big Bang theory. So, see this cosmology, the scientific study of large scale. The main aim of cosmology is to construct models and compare these models with the present day universe. You construct a model, study the physical situation, and study our present day universe. Okay. Compare it with our present day universe. Then you can say something about the universe. Next, the study of cosmology is based on the cosmological models. Next. Okay, next, please. Depending on the outcome of observation, once you construct models, study the physical conclusions, and depending on the outcome of the observations, the theories need to be abandoned, revised, or extended. The general theory of relativity is there. Use general theory of relativity, construct mathematical models of the universe, compare with the present day universe. If they are okay, you continue with that. If they are not okay, then you modify the theories, revise the theory, or extend the theory. This is what is happening. Now you can see these days, Einstein theory is lacking in certain things, and therefore there are so many modified theories. The first theory that has come is in 1961, branch decay theory, in which I am the first person to work in that in India. First, 1961, branch decay theory of gravitation, scalar tensor theory, because Einstein theory lacks in certain things, and therefore this theory has been developed. So what is this? What is happening is, take the cosmology and universe and construct models and get results and compare with the present day universe. Okay, for example, you take a model. For a model, if that model if it gives that model gives that the universe is empty. Suppose as a result of that model, you get that physical content of this universe is empty. Suppose you get that result. Do you accept that result? Do you accept that model? No, because universe is not empty. So we discard that model and again use the models which will be in accordance with the physical situation of our present day universe. Next, please. Okay. Next. So Big Bang theory. Big Bang model is broadly accepted theory. It postulates 12 to 14 billion years ago. The portion of the universe we can see today is only a few millimeters across. It is very narrow and dense. When 12 to 14 billion years ago, it has since expanded from this hot dense. Originally, when it is narrow, it was very hot. Now, as it expanded, cooled, now it is the present day universe. But still, what happens? There are remnants. Remnants means remains of this Big Bang still pervading the universe. That is known as the microwave background radiation. Usually we are calling that as cosmic microwave background radiation. What is this? This is because of the remnants of the Big Bang theory. The remains. See, it exploded. Again, hot, when it was hot and cooled, and today's position. So I will show you this. Next slide, please. Next slide. Oh, this cosmology, constructing models and everything, it is based on two things. You should know this fundamental thing, general theory of relativity. Why only on general theory of relativity? I told you. Because general theory of relativity is the best theory that describes gravity in a very well organized way. And recent experimental LIGO experiment, that also has proved that Einstein theory is correct. LIGO experiment, LIGO, you know that. Okay, next, cosmological principle. What is this cosmological principle? If you see the universe is homogeneous and isotropic. Homogeneous means, you should know this also, homogeneous means it is same at each point. A property of the space or geometry, whatever it is, if it is same at each point, that is known as homogeneity. Now, if the property is same in all directions, suppose you take elasticity. Elasticity is same in all directions, then it is called isotropy. Okay, so these two things are very essential to describe cosmology, because cosmology means universe. Universe is at large. You cannot conduct an experiment in a laboratory taking a universe. So what you have to do is you have to use these two principles, namely cosmology, Einstein relativity, cosmology. How do you do this? Assume the matter in the universe. In the universe, there is matter. Assume that the matter is in this universe is uniform, and that means homogeneous and same in all directions. How do you know this? Suppose you go on a galaxy. Suppose you are placed on a galaxy. Take a look into this universe. In all directions, it looks like same. It looks same in all directions. If you are sitting on a galaxy and take a look into the universe, okay, it looks the same in all directions, same at all points. This is what we know cosmological principle. We apply this principle to construct models of the universe. How do you do that? You smooth out the model, smooth out the matter distribution in the universe. See, I don't have time. You have to see all the basic things. Matter. When you take matter, matter has energy. Matter has momentum because it is moving. I said everything is in motion. And so matter in the universe is moving. So it is moving. Therefore, it has energy. It has momentum. It has strain. It has stress. Everything. So all these things you have to consider when you are doing research. But you cannot take all of them and do some models of the universe, because when you compare energy with stress, strain, everything, they are very negligible, and so you neglect them. If you compare density with other things, they are negligible, so you take density. When you compare pressure, the other things are negligible. Compare it to this, they are negligible. Therefore, we are not interested in them, and we take density, pressure, and all these things. So smoothing out the universe means that. Next, please. Since the universe has a finite age, 13.77 billion years, we can only see a finite distance out into space. Approximately 13.77 billion light years. You know what is light year, because the distance traveled by light in 1 year, that must be something like 9.5 into 10 to the power of 12 million miles, something like that. Okay. Next. You can see the picture of this, Big Bang expansion. I have just shown you the Big Bang. So this is this narrow part, green, inflation. See, quantum fluctuations. See, during Big Bang theory, when at the time of Big Bang, you have quantum fields. This quantum field pervades all the universe at the time of Big Bang. Array, it pervades all the universe. And God is there everywhere, like that. God is there everywhere, here, there, everywhere, like that quantum field. At the time of Big Bang, it pervades everywhere. And so what happens in inflation? This creates inflation. Inflation means exponential expansion. What is inflation? Inflation means exponential expansion. Because of that expansion, this expands. This has expanded. And you can see present day, present. The Big Bang expansion. First stars. As it cools down, it forms stars, then matter, and then it comes to the present stage. So next, please. So cosmological models. This is, I told you, mathematical representation. Cosmological model is mathematical representation of the universe. Einstein's general theory is used successful in studying cosmological models. The theory of cosmological, I told you everything already, okay. The theory began in 1917. Theory of cosmological began with Einstein's development of static universe. In the beginning, in 1917, Einstein thought that the universe is static. And he has developed some models, de Sitter model, some models are there, special relativity model, and Einstein model. All these models are static models. And all these models failed because one or other problem, there is a problem with these models. For example, you take de Sitter model. In that, we are getting that the universe is empty. Even special relativity model, universe is empty. But universe is not empty. And so this model should be removed. That should not be considered. And therefore, either theory should be wrong or mathematics should be wrong. So mathematics is correct means theory should be modified. This is how it happens. The research goes like that. Next, please. Now, as Professor Karade was telling us geometry. Professor Karade was insisting on geometry. So, any physical theory, for example, geometry is very important. If you want to describe mathematics also, geometry is important. I will tell you again the simple example. Suppose you take your car is moving on the road, discuss motion. Car is moving on the road, discuss the motion. That is what is given to you. How do you discuss? You have to, first of all, locate the body. Car is moving means where is it moving? You have to locate it. That means position. Position means Euclid geometry. Take that body there. From there, you take the distance x-axis and perpendicular to that y-axis and spot that body, x, y coordinates. That is geometry started. Then the body is moving. That means it is going from place to place. That means displacement, change in position, rate of change in position. Then velocity, rate of change of displacement, that is velocity. Okay, dx by dt. What has come there? Calculus. So geometry, immediately calculus. Again, differentiate, acceleration. Now, switch off the force, integration. Agaya. Then you get velocity. Then integrate, you get displacement. So every consequence can be worked out. So this was done, this was successful because of geometry. First thing is you have to locate the body. Then only you can discuss the motion. So that location is nothing but geometry. So Einstein's theory is also the same thing. You need geometry. Any physical theory, if it is successful, means you should have geometry. Without geometry, you cannot describe any theory. Okay, so geometry, even Einstein's theory, it is basically a geometric theory of gravitation. Einstein's theory is known as geometric theory. Next, please. So now we need geometry. So what is the geometry for this? See, I am going through step by step how to go for research. Okay, geometry. What is the geometry described in relativity? The geometry is described by the line element. That is, what is this line element? This line element is nothing but generalization of the distance concept. Generalization, ds square is dx1 square, dx2 square is the distance concept. Generalization, that is ds square is dij, dxi, dxj. From this, you will get that distance concept also. I is equal to j, but put there dij 1, 1, 1, then dx1 square, dx2 square, you will get. So this is generalization of distance concept in Einstein space. Now, geometry of the universe is governed by the four-dimensional space-time in general relativity. Four-dimensional. Or you call it 3 + 1 dimensions to be specific. The 3 spatial dimensions and the 4th dimension is time. They are not, time is unique. Spatial dimensions and time is unique. That you cannot describe time on a graph paper. How can you geometrically describe time on a graph paper? No, you have to study with clocks. And therefore you call it an imaginary axis. And how do you distinguish? Because how do you find light? Time. How do you see the time in a clock? The light should fall on that and it should reflect and go to your eye. When it goes to your eye, light is playing the role. What is playing? Velocity of light is playing the role in reading the time. And therefore, that 4th dimension is x4 is ICT. So what is C? C is the velocity. Why I? I is nothing imaginary because it is an imaginary axis. You cannot spot time on a graph paper. So this is everything about this. Next, gravity is the manifestation of curved space-time. Gravity is nothing but manifestation of the curved space-time because gravity is there because space is curved. Space is curved because gravity is there. There are two indispensable things. Okay, now next please, next slide. Go to next. So I told you the static models of the universe found in 1917 by Einstein, they have been ruled out because they don't represent our physical universe. And therefore, what should be done? So in the scene, he came to see Friedman 1922. In 1922, Friedman came with this geometry, this one. He has taken this geometry. What is this geometry? This is, you can see this metric or the geometry, Robertson-Walker metric is known as, it represents the cosmological principle. You can see what is cosmological principle. It is, universe is homogeneous and isotropic. Homogeneous means same at each point. That means it is function of time at each point. A is the potential. A is the potential, gravitational potential of the universe. That is same at all points and same in all directions. What are the special directions here? R, theta, phi are the special directions. See, for that same coefficient, A square is same for all these things, spatial coordinate. So your cosmological principle is there in this. See, well, I know many people taking this line element without knowing what is there in that. Oh, it is homogeneous isotropy. What do you mean that? Where is it? It is homogeneous, same. A is the potential. It is same in all places, same in all directions. That is spatial direction. So this is Robertson-Walker line element. And he has worked with that and he has found the models of the universe. Next, please. Next. Now again, he has worked with the models of that isotropic matrix. Now the problem is, at the time of Big Bang, what happens? At the time of Big Bang, there will be, what happens at the time of being confusion, chaos, from the point million, this thing, there is an explosion, cosmic explosion. When there is explosion, everything will be confusion, chaos and everything. So how can you talk about homogeneity there? How can you talk about same in all the isotropy in that at that time, at the beginning of the universe, at the time of Big Bang? So if you want to study the universe at that time, at the immediately after Big Bang theory, Big Bang, then you need that geometry, not isotropic geometry, but anisotropic geometry. That means, what do you mean by anisotropy? See, A square, B square, C square, they are all potentials. They are not same in all spatial directions. Dx square, A square coefficient. For this, B square, C square is the coefficient. So in all directions it is not same, but it is homogeneous because we take homogeneous. Otherwise you cannot work out. So say not same in all directions. So this is known as Bianchi type space-times. Bianchi, his name is Bianchi. He has given nine space-times which are anisotropic and homogeneous. We take homogeneous. They may be non-homogeneous also, but for discussions we take homogeneous. Otherwise you cannot work out. Next, please. These are the metrics. 2, 3, 8, 9 metrics. Now, you have to find the models. How do you find the models? So we have the geometry now. You see the Einstein field equations. Einstein field equations is left-hand side geometry and right-hand side. Where are the Einstein field equations matter in the universe? Okay. Later it is there. Okay, I will show you there. Okay. The left-hand side is geometry. Rij minus 1 by Dij R is equal to 8 pi Dij. That Einstein field equation. Tij is the energy momentum tensor. That energy momentum tensor are given by this. Matter can be different forms. Matter can be fluid, perfect fluid. Matter can be dust. Dust means without pressure, floating in the universe. Dust particles. That can be a form of matter. Perfect fluid. Perfect fluid means what? You neglect all the things, stress, strain, everything. You consider only rho, density and isotropic pressure. Pressure which is same in all directions we consider. Compared to these two things, everything is neglected for matter. That is known as perfect fluid. Next, please. Next. See, dust distribution. We had the geometry. Already I have shown you. Geometry is given by the line elements. Either Robertson-Walker line element or Bianchi space-times. Everybody is doing the same thing these days, research. Either recent research or tomorrow's research. They will take the line element, take the different distributions, take different distributions, matter distributions, put it in field equations, feed them into field equations and solve them. And now these recently everybody is now, because of this MathCAD or you can draw graphs also. Those days there were no technology to draw graphs in cosmology. Just find exact solutions, and seeing the analytical solutions only you have to discuss the physics of it. Now you have graphs. Everybody is drawing graphs, and from the graphs you can draw conclusions. That is another advancement in research. Okay, dust distribution. Electromagnetic field energy momentum tensor. This Fij, these electromagnetic potentials, okay, field tensors. Only electromagnetic, because matter not only has density, pressure, matter is also electrically charged in the universe. Electromagnetic force is there in the universe. So it is electrically charged. So if you can only consider electrically charged matter distribution, then the energy momentum tensor is this. When you consider only dust without pressure, this is the you take. Cosmic strings, so this is this. Strings. Matter may be in the form of strings. That means strings means particles attached to strings. Matter particles attached. They look like strings. That is another matter distribution. Now, this one, bulk viscous fluid. There will be viscosity in addition to that. Perfect fluid, in that you have viscosity. That is another type of matter. So take all types of matter distribution and do it. Next, we feed into Einstein field equations, solve them. Why should you take matter distribution like this? Because one other thing that one should know is Einstein field equations are highly nonlinear equations. The left-hand side geometry, right-hand side matter distribution. So if you take a general case, you cannot find an exact solution because nonlinear field equations seldom has exact solutions. You don't get exact solutions. So what to do? But you have to work out the consequences of the physical theory. What to do? So what one can do is either you choose the geometry on the left-hand side, choose the geometry, or choose the matter distribution. So choose the geometry means you take line elements, either Robertson-Walker metric. Geometry is given by metrics. So Robertson-Walker or Bianchi type metric or so on and so forth. So choose the geometry, work out and put it in the field here. That means what do you mean by putting it? Sticky tensor or calculate everything and put them, you get differential equations. Right hand side, you take matter distribution. Choose. You can take dust, you can take perfect fluid, you can take any matter, different kinds. So solve the field equations. Solve the field equations. We will get 1 minute, please. Okay. Sir, malli chestam nenu. Okay. Adi. So you have come to this. So while solving also, again, solving those equations also very difficult. So you take equations of state. These are again the tools to solve these nonlinear equations. So these tools have come now, decelerating phases, accelerating phases. Recently, it is the accelerating expansion. Recently, there is another case, accelerating expansion of the universe. The universe is expanding. The recent experiments have shown that there is a force which is driving the universe towards accelerating expansion. Okay. That is another concept, recent concept, accelerating phase, quintessence. So these are all, you have so many things now. Next, please. So I have to run through this now. So dark energy, dark matter. I told you there is a concept, recent concept. Supernova experiments. They have found that there is a unique force, negative force. There is a negative pressure which is driving the universe towards accelerated expansion. That negative pressure or negative force has been dubbed as dark energy. Now, experiments have shown that our universe consists of this thing: dark matter, dark energy, and baryonic matter. 3 types of matter. I will show you this. Next, please. So what is dark matter first? I will tell you how much dark matter is there in this universe, how much energy is there, how much baryonic matter is there. Dark matter accounts for the most of the mass in the universe. It surrounds galaxies across the universe and is invisible because it does not reflect light. This is dark because matter, it does not reflect light. It cannot be seen directly with telescopes, but astronomers know it to be out there because of the gravitational effects on matter. Because of their gravitational effects, they can be recognized. Next, please. Next. To realize this, as the European Space Agency says, how to realize this, whether dark matter is or not, is there or not. The agency said, shine a torch in a completely dark room. Take a torchlight, shine it in the dark room, then you will see only that part what the torch illuminates. You can only see in a dark room if you blow a torch, then what happens? You can only see that part which the torch illuminates. That does not mean that the room around you does not exist. That does not mean only that part exists. The part which is dark also exists, isn't it? So this is what they have said, that for the dark matter to recognize. Next, please. Next. Next slide. Okay. Next, you go without this. Next. I'll not go into the details. Next. Next. Dark matter and dark energy are a cosmological mystery in modern cosmology. They are still a mystery. Lot of research is going on this. Oh, so many. Thousands of people are doing research in relativity and dark matter, dark energy. Okay. And once dark matter, dark energy is exhausted, research is exhausted, there is no question of exhausting. But they are now going to what is known as black holes and wormholes. Next, the supernova observations of Reed 1998, that is what I am telling, Perlmutter 1990. Dist, they indicated that the universe is undergoing an accelerated expansion. The reason for this, there is an exotic force, exotic negative force, which is driving the universe towards acceleration. So cosmological observation, cosmic micro background radiation data suggest that the universe is spatially flat and dominated exotic component with a large negative pressure dubbed as dark energy. So these are all experimental results. Okay, next please. So dark energy is a recent concept, recent scenario of the accelerated expansion of the universe. Next slide, please. You can see about the universe. See, dark energy, 69%. I have written 69, it should be 68 point something. Let us not bother about, but most of this universe consists of dark energy. 25% dark matter. Only 5% or less than that also, the baryonic matter. That is the matter that we see. The matter that we are discussing, baryonic matter, with the pressure, density, everything, that is only 5% in the universe. So the exotic negative pressure believed to be driving the expansion of the universe is known as dark energy. The normal matter, the galaxies and planets, what is that? The normal matter is this. Galaxies, planets, which we are seeing, that can be seen astronomers with powerful telescopes, makes up only 5%. Even those things you have to see with telescopes. Dark matter 25%, dark energy 69%, normal matter 5%. Next, please. See, follow this. Geometry, then I am talking about matter distribution. Why? This because Einstein field equations consists of geometry on one side and matter distribution on this and on the other side. So whatever do you research in relativity or Einstein's theory, you have to choose geometry and you have to choose matter distribution. That matter distribution can be any of these things and solve the nonlinear field equations and interpret the results. This is what research. That is complete research in relativity. Okay, next. In order to explain the universe, two different approaches have been advocated. So now, quintessence. All these things are consequences of dark energy. The research in dark energy, they lead to these things. Cosmological constant. Once upon a time, Einstein said it is blunder of my life. He has included cosmological constant in Einstein field equations. And then he has removed it, saying that it is the blunder of my life. But later, now that it plays a vital role here in dark energy. Because the first candidate for dark energy is supposed to be cosmological constant. Then quintessence. Quintessence means scalar field energy. Next, phantom. There are so many types. Okay, I will not go into details of this. What I am trying to do is, this is what happens in research fundamentals. Next. Next slide, please. There is no time. Okay. See, there are so many tachyon, Chaplygin gas. These are all forms of matter, of dark energy that you can use to find out models of the universe. All these things, I have listed them. So this gives you everything, fundamentals for researchers who can do research. Okay, next please. Oh, modified theories of gravitation. This is another concept. I told you, Einstein theory is lacking in certain things. People say that, started saying, what is that? What is lacking in Einstein's theory? For example, Mach's principle. There is one thing, Mach's principle. There is another thing, the concept of singularities in the Einstein theory. The Mach's principle is not fully explained by Einstein field equations. Why? Einstein field equations, I told you, left-hand side geometry, right-hand side matter distribution. Given a matter distribution, you can decide geometry. Given a matter distribution, you can decide geometry of the universe. That is model of the universe. Geometry is model. Now, what Mach's principle says is, okay, given a matter distribution, principle says this complete principle. Given a matter distribution, there should be a unique geometry. Or given geometry, there should be unique matter distribution. This is what Mach's principle says. But in some cases, Einstein field equations is not in accordance with this principle. For example, there is what is known as Gödel's model in the general relativity cosmology. That Gödel's model, for same matter distribution, you are getting two different models. There, Mach's principle is violated. And similarly, there is the singularities. For example, Schwarzschild solution. We will come to that. Okay. There is a singularity in that. That means singularity is what? Singularity is nothing but a point where physics fails. Singularity is simply what? Singularity is something where physics fails. Okay, next slide, please. Einstein theory has been successful in the study of cosmological model. So Mach's principle, see, the geometry of the universe is uniquely determined by the inertial properties of matter distributed universe. Singularity is another serious problem in general relativity. See next, please. Next. Okay. Now, here and there has been a need for modifying Einstein. That is the need for modifying Einstein's theory. So when the need is there to modify Einstein's theory, there will be so many modifications. Next, please. Time is. How much time I have left, sir? Chairman, sir? Okay, let me finish this. These are the list of theories of gravitation that have come up. These things, the FR theory, FRT theory, so many things, modified theories have come. So the research is going on all these modified theories of gravitation. Next please. Next please. So this is all, principle of the Einstein field equations. Show the Einstein field equation. Next please. Next slide. You can see this is geometry. This is matter. This is geometry, Ricci tensor. Ricci tensor is function of coordinates. So therefore geometry. It is matter. In the energy momentum tensor, density, pressure, all these things matter. So here Max principle fails. And therefore there are so many theories coming up. These days so many theories doing research in FRT theory, FG theory, FT theory. Oh my God, so many theories. Next, please. All these things I told you, this is predicted LIGO experiment. Next. I don't think it is necessary now. LIGO, no. Now we come to black hole. What is this black hole? I have shown you a picture of a black hole in front of the large Magellanic cloud. Black hole. Next, please. Next slide. This is a picture of it. Then I will tell you what about this. This is also a picture of a black hole simulation. See, something goes inside, it cannot come out. Even light cannot come out. That is why it is known as black. Oh, next, please. I'll come to this concept. Okay. Here, this is square-shell solution. Square-shell solution of Einstein field equations. This is the basic thing for the singularity and theory of black holes. No, Penrose recently is awarded Nobel Prize for getting the concept of black hole from general relativity, mathematical theory, mathematical derivation of a black hole. For that he got Nobel Prize. Two others also got. One for stellar black hole in the galaxy, for finding a massive black hole in the galaxy. Gaze. 3 people got. Okay, next please. Next. So the concept of black hole comes from this here itself, square-shell solution. Because see this, a black hole, gravity pulls so much that even light cannot get out. The gravity is so strong because inside that the gravity will be so strong, it pulls everything inside. Matter has been squeezed into it. This can happen when a star is dying. When can a star die? Every star is in equilibrium position because of the hydrogen and the helium content. Once hydrogen and helium content is exhausted in a star, the star begins to fall under its own gravity. The star begins to fall under its own gravity. This can happen when a star is dying. So when star is dying, this black hole happens. Even light cannot escape from there. And so you cannot see it. That is the way it is known as black hole. Next, please. Next slide. Einstein first predicted the existence of black hole. Einstein. Next. Let us go through quickly. Okay. This is black hole, another picture of it. Next, please. This is another picture of a black hole. In the vicinity of that, if everything goes into the vicinity of that, it will, nothing can escape from that. When it happens means when the star is dying. When the mass exceeds 3 solar masses or 4 solar masses, it starts under its own gravity, it dies. Next, please. There are different kinds of stellar black hole, supermassive black holes, intermediate black holes. There are 3 types of black holes also. So I will not go into the details. Next, please. Stellar black hole. When a star burns through the last of its fuel, I showed you fuel, hydrogen, helium. It may collapse or fall into itself. It falls into itself under its own gravity. Next slide, please. Next, let us go through all these things. This is another. The birth of giant means supermassive black holes. I have given something about that. Next. Next, please. This is also next. Next. How do black holes form? Scientists think that smallest black hole formed when the universe began. Stellar black holes are made when the center of very big upon itself or collapses. When this happens, it causes supernova. A supernova is an exploding star that blasts parts of its star into space. Scientists think a supermassive black holes are made at the time of the galaxy. Okay, next please. Next. This is another picture of a black hole. Next. How big are black holes? Black holes can be very big or very small or intermediately. I will not go into the details. Next. The largest black holes are called supermassive black holes. For this only got a GAIZ, G-I-A-Z or something like this spelling. He got for finding or detecting a supermassive black hole in our galaxy. For that he got Nobel Prize. Okay, next please. Okay. Next. Next, please. I will not go into all these things. Take time. Oh, this is another picture of. Now, where do black holes lead? This is another thing. This is not completely seen picture. This is blocking this right side. The simple answer to this question is, where do black holes lead? The simple answer to this question is, as Professor Richard Massey explains, who knows? Where do black holes, who knows? As a Royal Society and Research Fellow at the Institute of Computational Cosmology, Durham University, Massey is fully aware that the mysteries of black holes run deep. Falling through an event horizon is literally passing beyond the veil. Once someone falls past into, nobody could send a message back. He said, nobody can send a message back. Next slide. Next slide. Okay. And that means everything that only. You cannot come out, nothing comes out of this. Okay, next. Okay. Next. This is the artist's impression of a tidal disruption. When a star passes too close to a supermassive, when a star passes too close to a supermassive black hole, it attracts everything into its, pulls everything. Next, that is supermassive black hole. Next, this uncertainty we don't want. Next. The previous slide, please. Previous. Just could a black hole destroy our Earth? That is the big question. Black holes do not go around in space, eating stars, moons, and planets. They do not go around space. They don't go around in space. Whatever goes in this vicinity, it will attract everything. But they do not go around in space eating stars, moons, and planets. Earth will not fall into a black hole. Our Earth will never fall into a black hole because no black hole is close enough to the solar system for Earth to do that. No black hole is close to our solar system. So we need not be worried about black holes. Even if a black hole, the same mass as the sun, were to take place of the sun, Earth would not fall in. Earth will not fall into the sun also, even then, if it takes place of the sun. Okay. So the sun will never turn into a black hole. The sun will never turn into a black hole. So we need not worry about this because we are in this solar system. Next, please. This is the first black hole that is from Cygnus X1. This is another picture of that black hole. Now wormhole, this is another concept, interesting concept. See, once a black hole, then you call wormhole. There is another concept, white hole. What is that white hole? If matter enters into a black hole, the universe, because of the conservation principle, if it enters into the black hole, it should come out somewhere because of conservation. So what is that point? That point where the matter that enters the black hole will come out is known as white hole. These are all hypothetical concepts. Only black hole has been detected. Now white hole, these wormholes, these are all concepts, beautiful mathematical concepts which have physical reasoning. Okay. This is another thing, wormholes. What are these wormholes? They are also known as Einstein bridges. That means if you want to go from one galaxy to another galaxy, then you can go through these wormholes. And my friend used to say that there is an apple or a worm will make a hole into the apple and from under thing it will come out through that hole. That is a wormhole. Okay. Here see, wormholes are solutions to Einstein field equations of gravity that act as tunnels. They act as tunnels connecting points in space-time. See that, show that figure, please. Tunnels. Backslide. The figure, see, tunnels from one galaxy to another galaxy. And next, please. Next slide. They act like tunnels. Now, steps in constructing cosmological models, I told you already. Okay. I need not go into that. Next slide. So a lot of research is going on this. A quick review, I said, so many groups working on this. You can see so many groups working on these modified theories and these anisotropic models, holographic dark energy models, Basali's holographic dark energy models, so many things. One basic thing you should know, the researcher should know the basic thing. Geometry, matter distribution. This matter distribution can be anything. And another thing is Einstein theory is lacking and therefore new theories. So take a new theory. Again, geometry, matter. Feed into the new theories, field equations, get the solutions. Draw the graphs, draw the conclusions. Present the paper, publish the paper. That is research. Okay, next. This is the universe, another picture. Okay. Future of the universe. Just a minute, please. Let me go through the future of the universe. After saying so much thing, I should say something future about. There are two basic scenarios describing the future evolution of the universe. I told you in the beginning, we are living in this universe, we should know about the universe, origins and content, and then what is the future, what happens, ultimate future of the universe. We don't know. There are two basic scenarios describing the future evolution of the universe. There are some scenarios, there are concepts. The first refers to closed pulsating universe. Universe may be closed. It will expand and close. That is, the Robertson-Walker metric gives you this mathematically. In this expansion will stop and contraction commences. Universe will expand, expansion will start automatically, stop, and contraction commences. Again will be crushed into pieces. And everything will become a point. Again, Big Bang. So that is, it happens. That may happen. Here, galaxies will start approaching each other. See, contraction means galaxies will start approaching each other. Temperature of background radiation will continuously increase. As you go nearer and nearer, temperature increases. You know that. Continuously increase. During contraction, galaxies will collide. During this process of contraction, what happens to galaxies? They will collide. the contraction proceeds until universe collapses to a singularity. It will collapse into a singularity, means point. This is called the big crunch. So universe collapses. It expands, expansion will stop, and contraction commences. Contraction, temperature increases, galaxies collapse and collide, and so this is called the big crunch. This is known as big crunch again. The second scenario lead to infinite and continuous expansion of the universe. This is another scenario. Either that can happen or this can happen. Or what is that second choice? It will continuously expand. If you go on expanding, what happens? What happens? The matter will be, see this, expanding universe will be disintegrates. Matter will be torn into pieces. Matter in the universe will be torn into pieces and finish, universe finish. So that is another thing. Expand until you take a rubber, you pull it, what happens? Ultimately, what happens to that? So you know that same thing happens. So recent scenario, we don't bother. There are some people from London, they said this dark energy, everything is not correct. The experiment, supernova experiment is also not correct. They given conclusions and the wrong notions or wrong the results, and we will not go into that. So I have made a bird's eye view of the universe, black holes and wormholes. Thank you very much for giving me this opportunity. Any questions, please? Our chairman is there. Chairman is present. So I should thank my chairman.
Thank you very much, sir.
Sir, I have one question, sir.
Okay.
You are telling about the wormhole. I am audible?
You are audible, tell me.
You are telling about the wormhole. I also work on the wormhole. I have published several papers on the wormhole, but still I don't understand the concept of the two hole, because wormhole is the connection between the two hole. One hole is the black hole, another hole is the white hole.
See, people are publishing papers.
Yeah.
Still they are not able to understand because it is only a hypothetical concept.
Yeah.
See, going from one galaxy to another galaxy, you can see there is a throat. Throat also. As we go inside that, a tunnel, there will be a throat-like structure. You can see that because you have published papers.
Yeah. That I know. Throat.
See,
Yes,
if there is a mountain, suppose you are going on a road. If a mountain comes, what happens? You have to go around and go to that side. Okay. Now, if you have a tunnel through that mountain, you can go very easily to that side, isn't it? So that concept is here.
Yeah, sir. I understand. It is a hypothetical concept, but it is possible to enter in the black hole.
You need not enter into black hole if you go to
how to go, because now wormhole is the shortcut to go from one universe to the another universe. So if you go from one universe to another universe, there is a shortcut, and that shortcut is called the Einstein bridge. So is it possible to enter in the black hole and out from the white hole? Is it possible?
Why you want to enter?
No. This a man can travel through the white hole, through the wormhole.
Through the wormhole or black hole? You want through wormhole or black
hole? Wormhole. Entry of the wormhole is the first in the black hole. Is it possible to enter in the black hole?
That I cannot say because research should decide. In future, you can whether you can enter or not. See, that may be possible. Right? Previously, also black hole was a hypothetical concept.
Yeah.
Now they are okay. Now with advanced research, now you can see Penrose. They got Nobel Prize also for that. Okay, black hole was also a hypothetical concept originally.
Yeah.
Okay.
Yeah.
Yeah, this is another Einstein bridge saying that you can see. Idea is beautiful.
Yeah.
You come across a mountain. You have to go to that side. How do you go? You have to go around and go to that side.
Yeah.
Now, if you have a tunnel through the mountain, you can go very easily. So that concept has been taken out here. People are talking about there are so many papers publishing on wormholes. What they are also doing is same thing. Again, taking a metric, this wormhole, that wormhole, taking a theory. You know, you are. I have seen so many papers, Professor Karade Saab. I'm sorry, Kadekar Saab. You are my guru.
Sure. Thank you very much.
Sir, can I add something?
Huh?
Can I add something?
Yeah.
You can add or you can
Sahu
ask
is
or
adding
add.
something. Sahu is
No,
adding.
you can add.
He is not going to ask the question. He is just adding something.
You can also ask me, what is there? He is my another guru there.
No, sir. No, sir. We all are here due to your blessings. So,
okay, please add.
So actually, when you start this space time, that Professor Khadekar asked about the whole. Actually, there is a whole. So since this space time is a core space, so in place of traveling from one end to other end of the space time, so somebody should travel through the core space. So in place of traveling through the core, one can go from one end to other end through a hole. Actually, that is a name they told that it is wormhole, basing upon the concept of the apple.
Yes.
Because apple, if any worm want to travel one end to other end of the apple, so instead of traveling the skin, so he can travel from one end to other end, making a hole. So
see, one can travel from one end
shows
to
the
another.
figure. So that is the core. In place of one travel through the complete core from one end to other end.
One end to another end, you have to go through the throat.
Yeah. So then one can go through the throat.
Yes.
There is no hole or it is not a black hole. This is basically a shortest.
See, black hole is different, wormhole is different.
Yes.
You should distinguish between two things separately. Black hole is something different. Okay. You can enter your wormhole. Wormhole will not drag you into it. Okay.
And this is basically made more popular in the Hollywood movies.
Okay.
They use this concept in Hollywood movies to travel from one galaxy to other galaxy. Then it was more popular and people started doing more.
Thank you.
Thank you. Thank you, sir. Thank you very much, sir.
Any more questions, please? So since the chairman is not here now, so I have been asking any more questions, please, any more questions, please. Okay. If there are no more questions, thank you very much, Professor Hatkar, for giving me this chance. Okay, giving me for inviting me to give what I call the keynote address. Okay. Otherwise,
thank you very much. After the pandemic,
I don't know how far it has helped the research community, but
yes, sir, very much helpful. Like us, for beginners, it is a very basic and a very deep, sir. It is your sharing was it is a very deep and it's enthusiastic, sir, and very valuable to all of us.
Thank you, thank you.
Thank you, sir. Now I would like to call Gore for present vote of thanks.
Good afternoon to all of you. Myself, Mr. Sandeep Gore. I am here for the vote of thanks of this session. In the first session of this national conference, we have the dynamic personalities who interact with us. Initially, I am thankful to Chairman of the session, Dr. T.M. Karde sir, former Honorable Vice Chancellor, Indiana University, Raipur, for his valuable time. I am also thankful to Dr. D.R.K. Reddy, ex-professor and head, Department of Mathematics, Andhra University, Visakhapatnam, as he expressed his views on universe, black holes, and wormholes. This will helpful to broaden our spectrum of thinking. I am also thankful to all the participants on the behalf of organizing committee for being present for this session. Thank you very much. Hatkar sir.
Now, Gore sir, Swapnil Gore sir.
Yes, sir. Yes, sir. Yes, sir.
Please continue, sir. Next
Okay.
session.
Thank you, Dr. Hatkar sir. for your cooperation regarding with the keynote address. Now the second session is our invited talk. Dr. B. Mishra, Professor, Department of Mathematics, BITS, Pilani, Hyderabad, will deliver a talk. And the chairperson of the session is Dr. G.S. Khadekar, sir, Professor, Department of Mathematics, Rashtrasan Tukadoji Maharaj, Nagpur University, Nagpur. Now, first of all, I'd like to introduce the chairperson of this session, Dr. Govardhan Sakaram Khadekar, sir, currently working as Professor, Department of Mathematics, Rashtrasan Tukadoji Maharaj, Nagpur University, Nagpur. Sir has teaching experience of 30 years for UG and PG, and Sir has administrative experience of 12 years, worked as a head, dean, and director of SAIF. Sir has published 65 research papers in the international journals, 15 in the national journals. Sir has published article in the conference proceedings and article published in the books.
अच्छा अच्छा बरं बरं ठीक आहे मग काही प्रॉब्लेम नाही ठीक म्हणजे येणार नाहीत का मग
Sir has three awards. And Sir has delivered invited talk guest lectures in various national and international journals. Sir has completed 2 UG minor research projects and 1 major research project. At the same time, Sir has published 1 international research project. Sir is also a coordinator of DST FIST, which is going on. At the same time, Sir is also a coordinator of UGC SAP DRS level 2, which is also going on. Sir has research collaboration, national and international levels. Sir have organized 3 national, 4 international, 2 workshop and symposium events. Sir has participated in various national and international conferences. Sir had delivered 24 invited talks. Sir has participated in 55 conferences, symposium, seminar, and so on. Sir is currently nominated as a member of Management Council. Sir is working as a ex-dean, Faculty of Science and Technology in Rashtrasan Tukadoji Maharaj, Nagpur University, Nagpur. Sir is also a member of Academic Council. Sir is also a member of Senate as a dean since 2018. Sir is also a chairperson of Board of Studies of Mathematics, RTM Nagpur University since 2018. Sir is also a member of Board of Studies of Mathematics, Bajaj Science College, Wardha since 2017. Sir is also a member of Research Recognized Committee RRC of Nanded University, Amravati University, and Gadchiroli University. Sir is also a member of IQAC of RTM Nagpur University, Nagpur, and such a great personality is here in our session to chair the session. Now the next eminent personality, Dr. B. Mishra, sir. Sir is working as a professor, Department of Mathematics. Sir is also working as Associate Dean, International Program and Collaboration. Sir is a fellow of Royal Astronomical Society, UK. At the same time, Sir is also a fellow of Institute of Mathematics and Applications, UK. Sir is also a visiting associate Inter-University Center for Astronomy and Astrophysics, that is IUCAC, Pune. And Sir is also a foreign member of Russian Gravitational Society, Moscow. Sir has received his PhD degree from Sambalpur University, Odisha, India in 2003. His main area of research is cosmology and relativity. And currently, Sir is working on the theoretical aspects of dark energy and modified theory of gravity. Sir has published around 100 of research papers in this area of research in journals of national and international repute. Sir has presented several research papers and delivered invited talks in these areas in the national and international conferences held in India and abroad. He has conducted several academic and scientific events in the department. He has become a member of Scientific Advisory Committee of National and International Academic Events. Sir has successfully completed 2 sponsored projects, one from UGC, University Grant Commission, UGC New Delhi, and served DST New Delhi. Sir is also an awardee of DAD RISE 2019. Sir has also reviewed several research papers of highly reputed journals, PhD examiner and board of study member of several universities. Sir have also visited countries like Canada, UAE, Germany, Republic of China, Malaysia, Italy, Czech Republic, Russia, Australia, Switzerland, Japan, UK, and presented his research work in different scientific events. Sir is also a visiting associate of IUCAC Pune. At the same time, he is also active in academic administration like head of department from September 12 to October 2016, and sir is working as associate dean since 2018. So these two eminent personalities are there. So I request our honorable chairperson of today's invited talk, Dr. G.S. Khadekar sir, Professor, Department of Mathematics, to take over the charge. Please, sir.
Thank you. Thank you very much. So first of all, I am very much thankful to the organizer who gave me this opportunity to chair the session. Actually, today we gathered here in the view of the retirement programs of or celebrations of the retirement programs of Dr. S.D. Katore sir. So I am also thankful to the team of the S.D. Katore sir. Special thankful to the Dr. S.D. Katore sirs who insist me ki sir, आपल्याला यायचं आहे. So I am very much thankful to all of you. And now today, today's speaker, Dr. Mishra, B. Mishra is my very good colleague, and he is working in the field of general theory of relativity. And he is a student of my old guru, Dr. Mohanty sir. So with this, I request total B. Mishra sir to deliver the talk on matter-bound scenario and the dynamical aspect in FRQT gravity. So Professor Mishra sir, so I request you to start the session.
Okay, my screen is visible?
Yeah, sir.
Okay, thank you, Professor Khadekar. It was nice to see you after a long gap.
Yeah.
And blessings to my guru, my philosopher, and my examiner, Professor D.R.K. Reddy sir. I think Professor Karade is not here. Both are the contemporary of my guru, Professor Mohanty. So with their blessings, I'll start this talk, but there is something that I wanted to share you. You please note my email ID. And because I have already communicated to the organizer that I have an important assignment around 1 o'clock. So I wanted to be out by 12:45, but it is not feasible now. But anyway, I'll stretch up to at least up to 12:55 or maximum to 1 o'clock. So if I may be excused to answer any questions now, because I have limited time here. So I wanted to go through the work that I have done, and please feel free to write me an email for any kind of queries are there, and questions or any comments are there. I'm sorry because I have some important assignment at 1 o'clock, so I cannot skip that. Anyway, because the time was given to me from 12 to 12:45, but after listening to Professor Reddy, so you cannot know that, or you will not able to know what is the time now and how the time passes so fast. Anyway, this matter-bound scenario, the dynamical aspects of acute gravity. So first few things, it will be a kind of repetitions that Professor Reddy has already elaborated, that in the modern cosmology, there is a challenge. And before I go into the contents of this presentation, let me tell you, it's a kind of game we are playing about our universe. So something has come up. We are trying to resolve those things. And before we resolve those things or find that, okay, our approach is not correct, then something new is coming. So it is happening. So post supernova observation in 1998, that the one line has come that our universe is expanding. And subsequently, another statement comes that our universe is expanding, not only expanding, but also the expansion is in an accelerated way. And there are a lot of research post supernova observation went on to get into the reason behind this. But at the same time, there were some group, they told, no, the universe is not accelerating. It is a kind of hypothetical assumptions. But again, experiment shows something, mathematical formulation has shown something, physics has told something. So all these three need to be aligned in order to give a concrete outcome about the universe. And this work is with in collaboration with the PhD students. So mostly I'll go through this kind of my sequence of talk would be a little bit about the problem statement, and mostly I put into some kind of mathematical formalism that normally helps the researcher to give a kind of standard platform. So once you're having a platform, then you can play with many things in between. So bouncing model, I'll tell you why the bouncing model is required, and subsequently, this normal way of studying the energy condition, cosmographic test, stability analysis also. The reason behind studying all these things is that once you're fitting a model, as Professor Reddy was telling, you have to give a model. But what is the viability of that model? What is the testing mechanism of that model? So if you are aligning with the physical aspect of that, and nowadays, post supernova, the observational result, if you keep on aligning with your model, then you can say your model is a successful model or it is a physically viable model. Now, standard cosmology, because there are great disciple of Albert Einstein is here, Professor Reddy and Professor Kennedy. So I do not want to comment much on Einstein's general theory of relativity. Every theory has its own merits and demerits. The standard cosmological models have many success stories who tells about the information about the universe. The cosmology relativity, mostly they are closely associated with each other. The one problem that could not be resolved is the initial singularity. It means if the singularity would happen at the evolution of the universe, then what will be the outcome? So it was something like, the work has done much before, but in 1995, this NCRAIRM group had told something that if the occurrence of initial singularity makes the physical laws presuppose the space-time. So it cannot always change your physics. You cannot change the physics instantly without filling it the physics. And if the singularity would occur, the space-time, the description of the space-times would break down. So in order to avoid the singularity means you have to find a non-singular approach without inflation. This horizon problem, inflation issue, initial singularity, and present post-supernova, the late time cosmic acceleration. All these are the problems that you need to address. You need to find out a solution for this. Though the flatness issue is somewhere resolved, but again, the initial singularity is still a burning problem. Now, one thought process has come on that before it attains the singularity, can the evolution would bounce back? Means if you're coming down, contraction is there. If you're coming down, instead of getting into a singularity, fall into a well, can it again go back? It means this is a matter bounce scenario. And what importantly it is done, why it is not able to solve as of now, is if it happens, the strong energy condition would violate. This Novelov and this Melnikov, etc., they put it will violate the strong energy condition. And the strong energy condition is a very valid thing in Einstein's GR. So in the context of general relativity, the cosmological bounds could not be well addressed in an homogeneous and isotropic background. So these two, and all this kind of space-time, Professor Reddy was showing some Bianchi type space-time, then this is your isotropic space-time. This Bianchi type is the anisotropic space-time. But in the context of general relativity, if we talk upon the homogeneous and isotropic background, then the matter bounce scenario, the cosmological bounds cannot be well described. So this is one issue, the problem that you're facing nowadays. Sorry. Oh. Another thing, the picture has been shown by Professor Reddy. the post-supernova Rees et al. Then the Perlmutter, recently the Planck collaboration started with supernova to Planck, LIGO that is started. So, the universe is accelerating, expanding and accelerating. And this is an unknown form of energy. A kind of anti-gravity effect is happening, which making the pressure to be negative. And again, you cannot see this. No one has seen this as of now. And the present data, because the different observations is giving a slightly modified data on the share of dark energy, dark matter, and the ordinary matter. The dark energy, as I have told and earlier also Professor Reddy has told, it is an exotic form of energy. This also violates the strong energy condition. So the energy conditions, which one of the strongest component, Einstein GR, in that the strong energy condition is now a question mark. So this late time cosmic acceleration, the singularity issue is still in our mind, how to get or how to resolve this. And somewhere there is one Sarkar group has already told what is dark energy, etc. This is nonsense. Leave it. Again, one group has told, let me tell you, when the universe is expanding, so whether the expansion is in an uniform manner or not, if it is not in uniform, means it is an anisotropy way. In case some 2-3 years ago, we had given some mathematical approach to see that what could be the rate of anisotropy. Means if there is an anisotropy, if there is an increment or there is a kind of expansion in one direction, one spatial direction, what could be in the other spatial direction. So that is something was discussed. It was established, but again, one group has told, no, there is no anisotropy. Again, one CMB has told the cosmic microwave background, at least at the late phase of cosmic evolution, some amount of anisotropy can be noticed. So whom to believe, how to believe, and where to believe. So the research will go on like this. Still we get a full form concrete approach, but still I say that GR is evergreen, though it has certain limitations, but it is evergreen. Coming forward, Professor Reddy has listed a set of modified theories of gravity. In 2011, the FRT theory was started by Harcourt group. And in that particular case, the recess color and trace of energy momentum tensor, that were taken into consideration in some form. Now, this extended gravity is nothing but by extending the geometry, one relation that is shown that Rij minus half Rgij is equal to kappa Tij. Left hand side is the geometry part, right hand side is the matter part. When we wish to work on the Einstein theory, the matter part need to be changed accordingly. Instead of this matter pressure and matter energy density, you can get in the dark energy matter and the energy density. Or you can get my geometry to be changed. This Rij minus half Rgij to be extended, or it can be modified. One such modification has been done most recently in 2019, Zhu et al., known as the FQT gravity, where Q is the non-metricity and T with the trace of energy momentum tensor. So our previous knowledge says that the general relativity can be represented into equivalent geometrical representation, the teleparallel representation, and the curvature representation. So whatever the FRT theory, FR theory, FRG theory, that is based on the curvature representation. And in the teleparallel representation, the curvature and non-metricity would vanish, but torsion is nowhere non-zero. But in curvature representation, the torsion and non-metricity vanishes and the curvature is non-zero. So these two equivalent. In fact, there is one more equivalent representation is available in the literature, but it needs to be well established. So here in this particular approach, in the teleparallel representation, I can say that an equivalent approach is the symmetric teleparallel gravity, where the basic geometry of the gravitational action would be represented by the non-metricity. You can see this non-metricity actually it was a brainchild of Nestor in 1999, which further has been developed into active gravity by Jimenez and et al. Most recently. So first I'll show you the investigations on the role of activity gravity in getting a matter-bound scenario and how it can be addressing the late-time cosmic speed of phenomena with the cosmological models. To glance through a little bit on the mathematical formalism of the activity gravity, you know, all gravity starts with the action and the Lagrangian. So here you can find those people who are working on FRT gravity that must be well equipped with FRT. Now this R has been replaced with the non-metricity Q. And there is some formula, as you know, you need some amount of your tensor calculus to calculate the non-metricity, the disformation tensor, and then you can find out a field equation for activity gravity. This is the standard process in any of the gravity. Whatever gravity will take, it start with an action, and what are the components available, or what are the components there in the action, the Lagrangian, what are the other parameters involved there. Those need to be taken together, and by the usual process, you can frame a field equations for any of the gravity, and in this case is the activity gravity. So the superpotential of the model and the trace of the energy momentum tensor and trace of the non-metricity, both of these can be calculated. Now another thing, just let me to mention here that we consider here a homogeneous isotropic and spatially flat FLRW space-time. And here you can find out one function that is called NT. This NT is nothing but the kind of lapse function. What is its role? In this case, though we have taken NT is equal to 1, but any global hyperbolic subspace-time can be sliced by a family of space-like hypersurfaces. When you go to the Bianchi type, all these 9 types, you can find the algebra behind that. So here, if you go a little bit the background to the calculus, you can find out that this globally hyperbolic space-time can be sliced by a family of space-like hypersurface. It means there exists a smooth scalar field. So different form of this NT which favors some shape of the geometry can be worked upon, but here you have taken only the simple case that n is equal to 1, and when you take n is equal to 1, the non-metricity becomes 6h squared. This h is nothing but your Hubble parameter. So you are getting a space-time, you are getting a theory. Then we have framed it was already framed by Zhu in 2019, Zhu and his group, and he has started a standard case FLRW metric with the pressure and energy density. Here we make some kind of permutation combination kind of things. We have made some kind of format that where you can find out this F, some notations F is equal to dou F by dou Q, then 85K and FP are related, and kappa 1 is equal to kappa by 1 plus kappa. So if you see the pressure and energy density, which is the most fundamental thing you need in order to start your discussion on the matter while studying about the model of the universe, in that case, this pressure and energy density. You can see it here, all this pressure and energy density can be expressed with respect to the Hubble parameter. And the Hubble functions can also be established from these equations with this zeta dot equal to 4 pi p plus rho 1 plus kappa. Now, one thing remember here, that when this p plus rho is equal to 0, we are talking about similar matter form. When p plus rho equal to 0, ultimately the right hand side becomes 0. So xi dot is equal to 0. So ultimately when I integrate this fh, I'll be living with some kind of constant function. So when this Friedman equations that has been long back, 1922 or 26, sorry. So from the Einstein's GR, if you take the Friedman equation, now this is no longer we are telling the pressure and energy density. We are taking into the effective pressure and the effective energy density. So this is the equation. 2h plus 3s square is equal to minus 8 pi p and 3s square is 8 pi rho. That is the normal way you can say. But once you take a modified or extended theory of gravity, the pressure and energy density is not only that of matter, it also involves some more component. So this formalism we have started somewhere most recently, and this has been published in one of the journal, good journal, this Physica Scripta. And then in this particular case, just to recall back your FRT gravity, here also there are 3 such cases are given. FQT is equal to lambda 1 q plus lambda 2t, and lambda 1 q power m plus lambda 2t. Here you observe when m is equal to 1, you can go back to the first model or first case, and third one is minus lambda q minus lambda 2t square. And all these, whatever the form are given, you can get all these things in the paper that is published, that how these constants are arranged with this FQT is equal to lambda 1 qm plus lambda 2t. Then, these algebraic expressions we take and we make some kind of arrangement on these terms or equations, and you can find out p and rho and omega. Why I'm interested for omega? Because omega, as Professor Reddy was telling, the most simplest candidate for dark energy is the cosmological constant. And when omega is equal to -1, that leads to my lambda CDM model. So that is why I'm a bit interested how this omega is behaving with this arrangement, with this formulation, which has been done mathematically. So before I move to the model, I give a little bit on these energy conditions. And if a null energy condition violated, then all other pointage energy conditions must be violated. And for a dark energy model with negative pressure cosmic fluid, the dominant energy condition is satisfied even if the NEC is violated. But in the bouncing model or models that is dominated by a phantom field, the NEC has to be violated at least at the bouncing epoch. Because for the bounce is happening, the null energy condition must be violated. Then this is with respect to your FQT gravity, and in this FQT gravity, how the energy conditions would be derived. It is simple addition and subtraction, that all. But some constants just I would like to mention it here when we worked upon this problem, that we are interested to do some bouncing models. So before we go into further analysis, what kind of constant we need to adhere to for getting a viable model. So for NEC violation, the null energy condition violation within the framework of FQT gravity, I should have this. Means this need to be rho plus p need to be negative. And it leads to that constant that kappa 1 should be less than 1, or we can have a negative value for this zeta naught. If the first condition will hold, then 1 by 8 pi dou by dou t should be less than -1. If the second condition holds, then this relation should establish with respect to the Hubble parameter. And the symmetric bounce models that satisfy h is equal to 0 and h dot is greater than 0 at the bounce. So at least at the bouncing epoch, as I've told you, violation of NEC should be there, and for that kappa 1 should be positive. That needs this dou by dou q to be negative. So this is one of the constraints that you need to adhere in the FQT gravity. And in the previous publications, we have already taken this FQT as a negative quantity, and it is a decreasing function of the redshift. So in view of this, the second condition is most satisfied. Now, matter bound scenario, and in this matter bound scenario, I think this is not for these people who are already working on this, possibly for the new researcher, that what are the certain constraint or conditions that you need to move upon, that the scale factor, it contracts to non-zero finite size, the Hubble parameter h equal to 0 at the bounds point, and this distillation parameter should be singular. The violation of NEC, because the Hubble parameter changes sign from the bouncing point, which is a constraint in general relativity. So there is need of any alternative kind of relativity. The slope of the scale factor increases after the bounce, and during the matter contraction phase, the Hubble parameter remains negative, and it becomes positive during the matter expansion process. So this is the basic background and the formulation that we have made. Then after that, we have taken two forms of the Hubble parameter, the two scale factors. And after this, simply we have framed the model with all these graphs that you put it here. And after doing that, actually, as I've told you, I have a constraint of time. I cannot go into the detail. I'm sorry, but I have to run for another meeting. So these are the different dynamical behavior that you can find from the models. And for both the models, if the people will be interested, I can share my paper, or I can share the slides with them to get into details. And for both the models, the dynamical parameters like pressure, energy density, your equation of state parameter, and other geometrical parameters, as well as the violation of strong energy condition. So one observations that we made, that throughout the cosmic evolution, the equation of state parameter remains near the concordant lambda CDM value. It evolves from a lower negative value, crosses the phantom divide line, and attains a minimum in the phantom-like region at the bouncing epoch. It again rises from a phantom-like region to a quintessence region. Professor Reddy was showing you different region, quintessence, phantom, lambda CDM. And it assumes a value of, omega naught is equal to minus 1.002, which is much closer in the range of the cosmological observations prescription of the value of the EOS parameter. And there are the energy conditions for both the model. You can see the violation and the cosmography parameter, all these geometrical parameters, the distillation parameter, jerk parameter, snap parameter, and the lurk parameter. You know, the state finder pair that distinguishes between the cosmological model that is based on dark energy. So these are things. And one thing is that it should be unstable, at least at the bounce. That is again a prescription from this, if you are taking thermodynamical aspect to get into the stability analysis. Okay, so the same results and discussion we have listed it down here. And this work has been recently published in Physics of the Dark Universe. And thank you. May I request you to kindly relieve me? It is already 1 o'clock. And please feel free to write a question to me. I'll be happy to answer your questions. Thank you, Professor.
Thank you, sir. Thank you very much for your nice talk. So you have covered a lot of things in your talk that is related to the singularity, related to some models, extended model of the gravity. So you are giving some very good idea related to FR, QT gravity. And all these things is covered in your lecture. So with this, I am very much thankful to you for giving the wonderful talk, because your time schedule is very important.
Yes.
So I permit you, you can leave the class, no doubt.
Thank you.
If anybody asks the questions, Professor Reddy will be here. Maybe we can solve your questions if it is possible. Otherwise somebody maybe mail you, and accordingly you can solve the
I'll be happy. I'll be certainly happy.
I'll
be certainly happy.
So
anyway,
thank you.
My regards to Professor Katuri, because he is superannuating today.
Yeah.
And thank you very much for you all for giving me this opportunity. Thank you all.
Thank you, sir. Thank you very much. So I request Professor, you leave the class.
Thank you.
I request Dr. Gore, sir, to please propose vote of thanks.
Thank you, sir. Good afternoon, all of you. I am again here to express the vote of thanks for this second session. Initially, I am very much thankful to the chairman of the session, Dr. G.S. Khadekar, sir, Professor, Department of Mathematics, RTM University. I am also thankful to Dr. B. Mishra, sir, Professor, Department of Mathematics, BITS Pilani, Hyderabad. He expressed his views on the topic. It will helpful to all the participants. I am also thankful to all the participants of this session for remain peacefully. Thank you very much. Alfred, sir.
Thank you so much, sir. Khadekar, sir, thank you so much.
Yes, sir. Thank you very much.
Now, the next session is for the invited talk of Dr. P.K. Sahu, sir, Professor and Head, Department of Mathematics, BITS Pilani, Hyderabad. The topic is energy conditions in modified f of q gravity. And the chairperson of this session is Dr. D.D. Pawar, sir, Professor and Director, School of Mathematical Sciences, SRTM, MU, Nanded. Now, before going to start, I just want to introduce our respected chairperson, Dr. D.D. Pawar, sir, currently working as Director and Professor, School of Mathematical Sciences, SRTM University, Nanded. Sir is having specialization in theory of relativity, cosmological models, fractional differential equation, fractional calculus. Sir is having a teaching experience of 23 years, 14 years in Government Reserve Institute of Science and Humanities, Amravati, and 9 years in SRTM University, Nanded. Sir is also a research guide in mathematics in SRMT University, Nanded, and Sant Gadge Baba Amravati University, Amravati. Sir has published 103 papers in various national and international journals. Sir has presented 36 research papers in various conferences. Number of PhD students under Sir, 5 awarded and 8 are currently working. Number of MPhil students, Sir has guided 7 MPhil students and 3 are currently working. Sir chaired the session in various national and international conferences, 22, and more than 50 in conferences. Sir has delivered his invited talk. Sir has completed 2 research projects. A very recognized award, that is Mahatma Phule, Dr. Babasaheb Ambedkar Puraskar from Government, Reserve Institute of Science and Humanities, and the second award, Fellow of Maharashtra Academy of Sciences, has been awarded to Honorable Dr. D.D. Pawar, sir. Sir have organized 22 seminars, conferences, workshops. Sir have attended 32 national and 15 international conferences, workshops, and seminars. And Sir is member of many apex bodies. At the same time, Sir is a member of Board of Studies, SRTM Nanded, SRM Latur, KBCNM University Jalgaon, SPP University Pune, Government of Science and Humanities, MGVK Nasik. So this is a brief profile of Honorable Dr. D.D. Pawar, sir, the chairperson of this session. Now next, I would like to introduce the great personality and the eminent speaker, Dr. P.K. Sahu, sir, currently working as a Professor and Head, Department of Mathematics, BITS Pilani, Hyderabad. Sir has done MSc, MPhil and PhD in Mathematics from Sambalpur University, India. Presently, Sir is working as a Professor and Head of the Department of Mathematics, BITS Pilani, Hyderabad campus, India. Sir is also a Fellow of Institute of Mathematics and its application, FIMA, London, Fellow of Royal Astronomical Society, FRAS, London, and also a foreign member of Russian Gravitational Society. He has ranked among 2% top scientists from India in the area of nuclear and particle physics, as reported by Stanford University on October 8, 2020. His research area include relativity, cosmology, gravitation, dark energy, modified theories of gravity, wormhole and their resources, and field theory. He has guided 3 PhD scholars and currently 7 scholars are working for doctorate program under his guidance. Sir's publication exceeds more than 130 research articles in peer-reviewed journals, including Physics Review, Physics letter B, Physics of Dark Universe, European Physics Journal C, and many more. Sir has visited Canada, Germany, Belgium, Spain, South Korea, Japan, London to deliver invited talks. Sir has taught various subjects in the postgraduate program of mathematics at BITS Pilani. So I request our chairperson to please take over the charge. Over to you, sir.
Okay, thank you. Thank you, Alfred, sir.
Thank you, sir.
Am I audible?
Excuse me.
Yes, sir. Yes, sir. Yes, sir.
So
Okay.
can you add me? I am leaving this. I will go for another system. Just add.
Hello.
I am just leaving this one. I will go for another system. Can you add me? Because it needs that.
Yes, sir. Yeah. Yeah.
Yeah, please.
Hello.
Sir, we have
Alfred,
added you. We have added you, sir. Sao, sir, we have added you.
okay, can I start?
Yes, sir. Yes, sir. Yes.
Hello. Okay. Okay. Hello. Good afternoon, one and all. It's my great privilege to chair the session of respected Professor P.K. Sao. He is my good friend, and all of us know that he is young, energetic, enthusiastic, and dynamic personality, and he is emerging relativist. Before going to start his session, first of all, I want to share some memories about the Professor S.D. Katore, sir. Because when I was in Amravati, Government Institute of Science and Humanities, Amravati, Dr. Katore helped me a lot. Dr. Katore is not only a very good researcher, but also a good teacher, also a good mathematician, and as well as he is one of the very good human beings. He has helped not only in terms of subject, but in terms of counseling of student also. Because I have came across many students, they have taken the name of Dr. S.D. Katore, and I have very good relation with him. So I wished very good future and healthy life for him. So without wasting time, I requested Professor S.K. Sao to present his work. Sir, Sao, sir. Please present your work.
Good afternoon to all. So I am audible? Hello, I am audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So first of all, I will give the thanks to the organizers. Then my respected gurus, Professor T.M. Korade, who was my examiner. Then the best friend of my guru, Professor D.R.K. Reddy, and all my known faces, Professor Khadekar, my friend Professor Power, and then so many people, because I am a regular visitor to Nagpur University and Amravati University. So most of all knows me. So after listening these two talks, one is from our guru, Professor D.R.K. Reddy, and the second talk is from my senior, Professor Mishra. So I'll just go through the energy conditions in the modified FQ gravity. So the details about the general theory of relativity and the modified gravity already discussed by Professor D.R.K. Reddy. Okay. So another thing is, I'll not take much time because all of us know that this is the lunch time. After lunch, we'll feel hungry. So when one is hungry, then nothing will enter in the brain. Okay. So the outlines are like this. I will go a little bit in the introduction where I will introduce about the modified gravity and the energy conditions. Then I will go for the field equations in the modified FQ gravity. Then what are the energy conditions in FQ gravity? And we constrain this FQ gravity with the present observational data. Then how the deviation, so whether it is aligned with the standard cosmological lambda CDM model, or it is deviating, our model is deviating from the standard lambda CDM model. Then the conclusions. Okay, so coming to the Big Bang theory. So regarding Big Bang theory, Professor D.R.K. Reddy explained the details that it started with a big explosion where the universe, we used to say that the universe started from a Big Bang with a cosmic explosion. So that is what already Professor Reddy told us. Then after Big Bang, there is a few seconds of inflation. Then inflation, we have the radiation dominated phase. After radiation dominated phase, the matter dominated era, where we used to tell the dust, the pressureless matter. And the radiation dominated era, if you go for the equation of state parameter, then we used to the relation between the pressure and density in terms of the constant omega, P is equal to omega rho, where omega is called the equation of state parameter. And when the omega is 1/3, the relation between the pressure and density is P is equal to rho by 3. So that we used to tell the radiation dominated phase or the radiation dominated era. So after Big Bang, there are few seconds for the inflation, then the radiation dominated era, and after that the matter dominated era where the pressure is 0, or we used to tell the dust matter. Next is the accelerated phase of expansion, which is the current scenario, where we will get the equation of state parameter omega is less than 0, because at equal to 0, it is the pressureless matter or the dust. After that, when the equation of state parameter omega less than 0, then the current expansion, the accelerated expansion of the universe, which is the current phase. Now, coming to the history. So already Professor Reddy told how the Einstein's theory of relativity was started in 1915. That is what the early 20th century. That the modern cosmology was started by Einstein. But the major part was very popular nowadays with the observation. Because earlier what used to happen, everything is theoretical. So after this 1998 and 99, the two groups, Rees group and the Formental group, so when they gave the supernova data with the observation, and later they got the Nobel Prize in 2011, showing this accelerated expansion in the universe. So after that, the observations came to the picture. So before that, everything is based upon the theoretical, as Professor Reddy mentioned, the exact solutions. So earlier people used to go through the exact solutions of the field equations, then they will describe this exact solution through dramatically and physically. But the current scenario tells that there are so many observational data and we have to align our work with the observation. Okay, then how the observation come to the picture? So basically the person who is behind this observation is Edwin Hubble. So through the Hubble Space Telescope, in 1929, Edwin Hubble started this observational data through the redshift parameter. So he has taken 20 galaxies, so 20 nearby galaxies, and he measured the distance through the redshift parameter. Then he made this first graph. So this is the first graph where you can see the linear graph, the linear line. That is the Hubble data in 1929. Okay. So the Hubble's law tells that the recession velocity v is equal to h naught r, where r is the distance of the galaxy from the observer and h naught is the Hubble's constant. Okay. At that time, the Hubble's constant, what he measured is 500 km/s per megapascal. Okay. But what is the value he got that time in 1929? It is 10 times more than the present value, because at present time the Hubble's constant ranges from 67 to 74. Okay. So coming to this modern cosmology, so there is as I told, there is so many number of so like, started with 1998 by the supernovae data, then the bio data, then the Planck data, then the Pantheon data. Okay. So many observational data are come to the picture nowadays. And the most prominent is the Einstein's field equation, which is given in equation 1. And the details of equation 1 was already told by Professor Reddy. What is the geometric properties on the left-hand side and the physical properties on the right-hand side. So all the terms he explained very well. Now coming to the dark sector. So the dark sector also already covered. So actually it makes a speaker when he speaks later is easy, because most of the things are covered by the previous speakers. So both of these speakers covered this dark sector of the universe, that the negative pressure and the dark energy. So 96% of the matter and energy are the dark energy or the dark sector. And only known is the 4%, that is the baryonic matter.
Professor Sahu,
Yes,
Professor
sir.
Sahu, your slide is not moving. I think so. You are on the first slide still now?
No, in my system it is showing the slides are moving.
No, slide is not moving here. On my system.
वो मेरे रिपोर्ट्स आपके कार में
Anybody other can check.
It is moving. Slide is moving now.
No, slide is not moving.
So please check. You can leave and then again you join.
मेरे को विद्यापीठ में काम है आज, तो मैं डायरेक्ट उधर ही जा रही थी. हाँ, इनके साथ आ जाओ.
Then I will leave and I will join again.
बारिश बहुत है ना.
Organizer, I request you to please mute the other mics. So somebody is talking between the lectures. I request to the organizer, you mute the other mics. You unmute the speaker's mic, please. And you mute the other mics. The chairman and speaker mics will be.
Now all mics are muted, sir.
So, but there is a disturbance.
Hello, Professor Sahu joined or not? Alfred, sir.
Sir, Professor Sahu is going to join. He leave it. He left the, I think so, screen. Then again he is going to join.
Hello, I'm audible now?
Yes, sir. Yes, sir. Go ahead.
Let me share the screen. So the screen is visible now?
It is
Screen
visible.
is visible.
Please check it. Is it movable or not?
1 minute. Is it moving now?
No.
No. Only first screen is seen.
We enlarge the screen.
Sir, if you do slide showing, then it will move.
If you do slide showing.
Yes, sir. Slide showing, then it will move.
You can send,
It is in the
otherwise you
view.
can send an email, your file to the organizer. He can just start. Otherwise you can see. It is PDF file now.
Yeah, it is a PDF file actually.
So you can take the full screen. Go to the full screen. Yeah.
Is it moving?
It is now moving. It is now moving.
It is now?
Yeah.
Yeah.
It is Big Bang, inflation.
Now it's okay.
Now it is okay.
Okay.
Yeah, it is okay.
Okay, thank you. Okay, so I'll just start. Okay, so just we reached up to the field equation, so sorry for the inconvenience. Okay, so coming to the next, the dark sector. So I was discussing about the dark sector, right? So basically the standard description of the Einstein-Hilbert field equation based upon the general relativity. Okay, so the issue on the dark sector, such a theory has successfully tested in 1919 and predicted the perihelion advance of the Mercury. As both the speakers told, like the Mach's principle, the initial singularity problem. So there are many drawbacks in Einstein's theory. Okay, so the recent observation, so if you go for the LIGO and the Virgo group, so which is given in the reference 2. Okay, so it confirmed the success of Einstein's general theory of relativity. So that is what Professor Reddy already mentioned, that the LIGO group has told that the Einstein's theory is very successful. But there are some fundamental theory which is explain the gravity interaction at the quantum level, right? So there are several motivations to explore the theories beyond the standard formulation of the gravity. And the most prominent is the FR gravity, which was proposed by Starobinsky in 1980. After that, there are many theories, and most of us are working on the FRT gravity, which is proposed by Harko and his team in 2011, where R is the Ricci tensor and T is the trace of the energy momentum tensor. Then after that, there are two popular theories based upon the FR, like F of R is the function of the Ricci scalar. So there are two more theories come, the teleparallel gravity and the symmetric teleparallel gravity. So that is basically the F of T theory and F of Q theory. Okay, so the T is the teleparallel gravity and Q is the symmetric teleparallel gravity. So here Q is known as the non-metricity term. Okay, so this F cube gravity was proposed by Siemens in 2018. So this is a recently proposed theory, 2018, and now as the works in FRT gravity are saturated, so the people started works on the new theories, that is basically FQ and FQT. So the FQ gravity was proposed in 2018 and FQT gravity was proposed in 2019. So already I told this in FQ gravity, which is a function of Q, and Q is known as the non-metricity term. Okay, so these investigations of the FQ gravity has rapidly developed, and going through the observation, if you see nowadays, particularly this year, there are many articles are coming in FQ gravity constraining the observational data. So that's what the basic idea for us to go for the constraining these energy conditions in FQ gravity using the present observational data. Okay, so another relevant analysis about the FQ gravity is understanding its behavior in different energy conditions. So now coming to the energy conditions. So most of us are using these energy conditions in our cosmological models, and these energy conditions are essentially the Rai-Choudhury equations. So the Amal Kumar Rai-Choudhury from Calcutta, so he gave these energy conditions, and this is the behavior of the space-time, whether the space-time is time-like, space-like, or light-like. So to describe the geometry or the behavior of the space-time, so A.K. Rai-Choudhury, Amal Kumar Rai-Choudhury has proposed these energy conditions, and they are mostly used in the black holes and wormholes. Okay, because as you know, the violation of null energy condition indicates the presence of exotic matter in wormholes. So these are the singularity problems where the energy conditions are mostly used. So there are 10 energy conditions if you go through the literature, but generally we use these most prominent 4 energy conditions: the null energy condition, then weak energy condition, dominant energy condition, and the strong energy condition. So the first one is the null energy condition. The violation of null energy condition we use to tell the presence of exotic matter. So it is the minimum requirement which is obtained from the strong energy condition and weak energy condition. So the null energy condition says that the pressure plus density is always greater than or equal to 0. Then the second one is the weak energy condition. So weak energy condition, as we know, the density is always positive. Okay, so it is the effective density should always be non-negative measured by any observer. So for any stress energy tensor, the density is positive and add the null energy condition, so which gives us the weak energy condition. Then the third one is the strong energy condition. So the strong energy condition tells that the gravity is always attractive, and the violation of strong energy condition indicates the presence of accelerated expansion of the universe, which was proposed by Matt Visser in a paper in 1998. Okay, then the last one is the dominant energy condition. So the dominant energy condition tells that the energy density must be positive measured by any observer, and it dominates the pressure. So the energy density is always greater than or equal to the magnitude of the pressure. As we know that for dark energy, the pressure is negative. That's why the magnitude was taken. And if you go for previous, the deceleration era, so in our deceleration phase or the radiation phase, so the pressure is positive. So when you go for the radiation domination era, that time the pressure is positive, and the present acceleration phase, the pressure is negative. That's why we use the magnitude of the pressure. So the density is always greater than the magnitude of the pressure. Okay, so coming to the present talk, so we'll discuss the energy conditions in a modified FQ gravity, and to go for the actual accelerating phase of our universe, we constrain the energy conditions, and it should be violated, particularly the strong energy condition. So this constraint, together with the values of the Hubble and deceleration parameter, will allow us to test the FQ gravity, as it is a modified gravity which is proposed in 2018. Now coming to the field equations. So the field equations in FQ gravity proposed by Siemens is given in equation 6. As all of you know, so we need a Einstein-Hilbert action to go for any modified gravity. So particularly if you go for in equation 6, this f of q. Okay, so if you go for f of r theory, this is f of r. And if you go for general theory of relativity, when you compare with general theory of relativity, so in equation 6, this is r. In place of f of q, in gr it is r. Then when you go for f of r theory, it is a function of r, f of r. When you go for FRT theory, it is f of rt. That means the Einstein-Hilbert action was modified when you go for the modified gravity. So that is what the major point for the researchers. So here the Einstein-Hilbert action given in equation 6 was modified in presence of a function of q, where q is the general function of f of q is the general function of q, and Q is the non-metricity. And Lm is the matter Lagrangian, which is considered as pressure or density, because as its name is matter, so we can consider the matter is either pressure or density. So here we have considered the standard FRW metric, where the scale factor A is a function of time, and the non-metricity Q is equal to 6h square for the FLRW metric. Then we have considered the standard perfect fluid matter, which is given in equation 8. It is the pressure and density, and you know the Fourier velocity vector. Gij is the metric potential. Now considering this Hilbert action 6 for the metric 7, and in the presence of matter, which is in equation 8, we'll get two field equations, which are presented in equations 9 and 10. So still now we have not considered the function. What is the function Q, f of Q? Okay, so here the dot, overhead dot is the time derivative, and we know the Hubble parameter is the first derivative of A by A. Okay, so now if you go for equation 9 and 10, we have two equations having three unknowns, the scale factor, pressure and density. Okay, so what we did here, we have went for different functions of f of Q. So now, before going to the f of Q, so what we did, we derived the field equations from 9 and 10 for the modified pressure and density. Okay, so these equation 9 and 10 are in FQ gravity. Now we took its GR representation. Okay, so how this field equation will be reduced to general theory of relativity. So if you take f of Q is equal to minus Q, particularly in this FQ gravity, so then the FQ gravity will be reduced to general theory of relativity. So considering that, we wrote the general theory equations in 11 and 12. So what are the field equation in GR? Now then we compare. Okay, we compare the field equations of GR with the field equations of FQ gravity. Then we wrote this rho bar and P bar in terms of function of Q. So most of you can go through a paper by Capizolo and his team, which is published in Progressive Reports. So there he described all the details of modified gravity. So these are the four energy conditions which are given in the GR. Okay, so the strong energy condition, weak energy condition, and the null energy condition, and the dominant energy condition. Now, from considering the equation 11 and 12, okay, so we constrained this weak energy, null energy, and dominant energy conditions. So we want to prove that this weak energy condition, null energy condition, dominant energy condition, okay, so they are satisfying, and the strong energy condition is violating. So we majorly focused on the strong energy condition, because the violation of strong energy condition, okay, so which is, as I told, the Capizolo group was published in Physical Letter B in 2018. Okay, so there we majorly focus on that paper actually, to violation of the strong energy condition. So we constrain based upon the strong energy condition, so which is given in equation 13. Okay, so now the equations of strong energy condition and null energy conditions are represented in equation 14 and 15. So explicitly, then we know the deceleration parameter Q is minus 1 by h square A double dot by A. Right, then the weak energy condition and the dominant energy condition are given in equation 16 and 17. Now we'll go for the constant. So how will you use this observational data in this FQ theory? Okay, so what we did initially, so we have taken the values of Hubble parameter. Okay, the present Hubble parameter H0 and the present deceleration parameter Q0 at 67.9 and Q0 is minus 0.503. So remember, these are the present values of the Hubble parameter and deceleration parameter given by Planck data. So these two we have taken from these two papers, the Planck collaboration, okay, which was released in 2018, and the article is published in 2020. Then these data are used by Capizzulo and his group in which is published in IGMPD. Okay, so as I told, these energy conditions. Okay, so the energy conditions as completely described by Matt Visser in this article, and this is the archive number. Please note this archive number, which tells that the violation of strong energy condition implies the presence of acceleration of the universe. So basically, these three articles are the most referred article in this paper. So we give more importance to these three articles. Okay, now what we did, we considered two functional forms of FQ. Okay, so one is the linear form. We have taken a linear equation. So Q to the power n. So that makes the field equations are non-linear, because if you take n is 1, then it is fine. It is linear. Then you take higher powers of n, then you will get a non-linear form of the FQ. And the second form, we took an logarithmic form. To make a comparison between two models, we have taken one linear form and another is the logarithmic form. So two functional forms we have presented in this article. Okay, so coming to the linear equation, f of q is equal to q plus m q to the power n. So from the energy conditions, what we constrain, taking the present values of Hubble parameter and the deceleration parameter, we saw that the values of the free parameter m is less than equal to -1, and the value of n lies between 0.9 to 2, as our major constraint is violation of strong energy condition. To violate this strong energy condition, we found the particular values of the two free parameters m and n. And always you need to show that your density is always positive. So which is there in the first figure. So the density is positive, the strong energy condition violated, the weak and dominated weak energy condition and the dominant energy condition both are satisfying. Okay, so this shows the accelerated expansion of the universe. Now coming to the logarithmic model, so to again show the density is positive and the violation of the strong energy condition with the present values of the Hubble parameter and the deceleration parameter, the alpha ranges between 18 to 20 and beta ranges between -2 to -1. So in the previous model, we have two free variables, m and n, two free parameters. And in the second model, we have two free parameters, alpha and beta. So how to, the major concern is, so those who are new in this area, so how we are choosing the constants? That is the question. How will, when you go for plotting the figures? As Professor Reddy told earlier times, there are no figures. They used to go for the exact solutions and their behavior in geometric and physics. But nowadays, due to the softwares, so we have the technology. People use the Mathematica, MATLAB, and so many softwares. Okay, so when you put a figure, basically you go and teach in a blackboard and show experiment to the student. Then when you show something to the student as experiment, then it easily captures to our mind. Because teaching in the classroom, in the blackboard, they will listen, after some time they will forget. But what we saw, some experiments, we used to remember these things very easily. So that is the main important part of this, why people used to go for the figures, why they use the graphicals nowadays. So that is what the benefit of the technology. So when you take a graph, so from the graph, because when you go for exact solution, we can write for some alpha and some beta, these are the constant, we will go for this. But exactly what are the values of alpha and beta? To get a numerical solution, okay, so you can go for the figures. So from the figures, we can show that for this range of the free parameter, we are getting this type of behavior. So that is basically the idea why the people used to go for the figures in cosmology. Okay, so here you can see in the previous model, the weak energy condition satisfied. But in this model, the weak energy condition violated. So we have not given more importance to weak energy condition, because as per the cosmological model, our density is always positive. So in both the models, you can see the density is positive. So as I mentioned, we have given more focus on the strong energy condition. So we try to show that in both the models, the strong energy condition is violating. So that is what the major importance of this article. Then coming to the comparison with the standard model. Okay, so when you go for the standard lambda CDM model, the cosmological constant cold dark matter. Okay, so far this standard lambda CDM model is the most success model used to describe the actual observation of the universe. Okay, so this is mostly used by WMP, Planck, and the dark energy survey, the DES group. So these observational groups or the research groups has used this lambda CDM model as the standard cosmological model. So now coming to the FQ and comparison with standard lambda CDM model. Okay, so we have taken this FQ as F lambda Q. Okay, so already I told if you go for FQ, the function of Q is equal to minus Q, then this FQ gravity will be reduced to GR. Okay, so that is how we can compare your modified gravity to general theory of relativity, right? Similarly, if you go for FRT gravity, so if you in your FRT gravity, if you make this T term is 0, then your FRT gravity will reduce to GR. So that you can make a comparison between your modified FRT gravity with general theory of relativity. What is the behavior in your modified gravity and what are the behavior in the general theory of relativity? So in the same way, in this FQ gravity, you take your function of FQ as minus Q, then the model will reduce to GR. Then immediately you can go for a comparison. Okay, so when you took this FQ is equal to minus Q in this article, then these are the behaviors of the energy conditions. Okay, so see, all the energy conditions are written in terms of the Hubble parameter and the deceleration parameter. So that is what the importance of this paper. That we wrote all the energy conditions with Hubble parameter and deceleration parameter. Then you put the values of the present Hubble and present deceleration parameter, then easily you can get the behaviors. Okay, so by taking the actual value, as I mentioned, the H0 and Q0, all the above conditions are satisfied above except the strong energy condition. So what are the lambda CDM? Okay, for the lambda CDM model in general theory of relativity, these are the 4 energy conditions. Now you put the present values of Hubble parameter and deceleration parameter. Then you can verify that this null energy, weak energy, and dominant energy condition satisfied where the strong energy condition violated. That is what our main importance of this article. Okay, so we saw that the strong energy condition is violating as per the lambda CDM model. Again, another important observation which Professor Reddy also told, that when omega is equal to minus 1, the equation of state parameter, we used to tell that the cosmological constant. Okay, so in P is equal to omega rho, so Professor Reddy mentioned you that the radiation, then when omega is less than 0, the quintence model, then the cosmological constant and the phantom era. So when your omega is less than 0, that means it is less than 0 to minus 1. So that era we used to say that the quintence era. And when this omega is minus 1, because the equation of state parameter is minus 1, then that is the cosmological constant. And when it is less than minus 1, below minus 1, then it is the phantom region. And particularly if you go for the bouncing model or the big rip singularity model, all the singularities, even if the black hole and wormhole, all will be in the phantom region. Because the phantom region, you will get the singularity. So anybody is doing the article in bouncing or big rip singularity, then they have to go for the equation of state parameter less than minus 1. So here, as per the Planck collaboration, it confirms that this lambda CDM model will be minus 1 for a standard cosmological model. So this behavior corresponds to the negative pressure. Okay, so which configures its current acceleration phase. So this part already we discussed. The negative pressure tells about the current acceleration. Okay, so now coming to this FQ for both the models. Okay, so in the first model, the linear model, when you choose f of q is q plus m q to the power n. So this is the value of the omega, which is given in equation 18. And the values what we have chosen for m and n, the free parameter, taking the same values of m and n, you can see. So this equation of state parameter omega is approaching to minus 1. So it clearly indicates this FQ gravity is approaching to the lambda CDM model. So it is as par with the general theory of relativity, satisfying the standard cosmological model. Okay. Then coming to the second case, in the logarithmic model, here you can see it is going up to minus 0.9. It is not going up to minus 1. So it is nearly approaching to the lambda CDM model. So the second model is approaching towards lambda CDM model, whereas the first model shows the exactly to minus 1. So that indicates that the linear model is as per with the standard cosmological model, the lambda CDM, and the logarithmic model is approaching towards the cosmological constant. Okay, so now coming to the outline, the conclusion. So already we told there are several modified theories of gravity, which was told by Professor Reddy, starting from the branch decay, where he started his research in 1970s. Then this is the particular modified gravity f of q, where in the first model we have two free parameters m and n. To satisfy the lambda CDM model and the density is positive and the violation of strong energy condition, we got the value of m is less than equal to -1 and n lies between 0.9 to 2. Then coming to the second model, the logarithmic model, there the free parameter alpha lies between 18 to 20, whereas beta lies between -2 to -1. And the matter, so as a matter of completeness, so finally in the last section, we went for the standard cosmological model, where we saw that this linear model is exactly approaching to the lambda CDM model. Okay, so it is, the value is completely close to -1, but in the second model it is approaches to -1 because we are getting -0.9. Okay, so it is interesting that this FQ with inflation field looking for possible analytic model in the cosmological parameter. So one can use the inflation also in the future problem. Okay, so that is basically the last sentence I wrote. One can go for the inflationary model for the future study. And these are some references. And the detail of the article is published in Physical Review D. Okay, so with my student Sanjay Mandal and my collaborator from Brazil, Professor JRL Santos. Okay, so this is available in the archive. This archive number, or you can get the complete article from Physical Review D. So thanks a lot for your patience. And
Hello. Now the session is open for discussion. Any question, any queries, please ask. Unmute your mic and ask your queries. Any questions from audience? Okay, I think no questions from audience.
there is no question means either nobody understand or they understand everything. So the second part is not possible. Everybody cannot understand everything. So I can say that nobody understood my talk.
No, we suppose that the second part is over. Many of us understand everything that you just taught about us. So just now Professor P.K. Sahu presented his talk. Initially he was started from very basic things. Also he has explained about the different energy conditions, and he has given the detailed deliberations about the alternative theory of Q gravity, and also discuss about his cosmological applications, and given some results, and he has compared his result with the lambda CDM model. So with this nice talk, I express my thanks to Professor P.K. Sahu, and I declare that this session is over. Thank you, sir.
Thank you, sir. Thank you, my dear friend Pravar sir, sharing for the session.
Now I'd like to request Dr. S.S. Gore sir to propose vote of thanks.
Thank you, sir. I'm again here for vote of thanks for this third session. Initially, I'm thankful to chairman of this session, Dr. D.D. Pawar sir, professor and director, School of Mathematics, SRTMU, Gandhi. I'm also thankful to Dr. D.D. Pawar sir, Dr. P.K. Sahu sir, professor and head, Department of Mathematical, Pets Pilani, Hyderabad, for his nice lecture. I am also thankful to all the participants, all the stakeholders of this session. Thank you very much. Dr. Alfred sir.
Thank you so much, sir. Now I request all the participants to go for the technical session, paper presentation, to the respective links. And for this, paper presentation, there are 3 links we have considered. We have uploaded in the particular group. Now, for this link, I would like to request Dr. Nimkar sir, then Dr. Bayaskar sir, Professor Solanke sir, and Dr. K.S. Wankade sir to chair the session.
Okay, Dr. Sheikh, excuse me. I will go for launch. After launch, I will join.
Okay, sir. Okay. Okay, sir. Okay. Okay.
Thank you. Thank you.
Okay. Thank you so much, sir.
Okay, sir. Alfred, sir. Thank you.
Thank you so much, sir. Thank you so much, sir. Hello. Hello, Solanke sir.
Hello, sir.
Hello, namaskar sir. Bayaskar sir, namaskar.
Hello.
Hello. सर आवाज आ रहा है
अच्छा मी काय म्हणत होते पेपर प्रेझेंटेशनचं सेशन चालू करायचं आहे ना हा
हो,
आवाज
चालू
आलाय
करा
ना
सर. चालू करा सर. चालू करा.
चालू करायचं ना
हो बिल्कुल सर. बिल्कुल.
हॅलो
हेलो.
ठीक आहे हा ठीक आहे सर.
Okay. 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 So I would like to request Dr. S.N. Bayaskar sir, Professor Solanke sir, Dr. K.S. Wankade sir, and Dr. A.S. Nimkar sir to be the chairperson of this paper pattern technical session. Now, I would like to request on behalf of the organizing committee of National E-Conference, I request all the chairpersons to please do the proceeding. Over to you, sir. Bayaskar sir.
Okay. Now in paper presentation session, I call firstly Rahul Mapali sir for presentation. मापारी सर as per list.
राहुल मापारी झाले.
Next. मापारी सर.
हॅलो जॉईन केलं सर, त्यांना जॉईन केलं सर मी.
हॅलो सर.
हा जॉईन केलाय ना. हा
जॉईन केलं.
Hello, sir. Am I audible?
हा ओके ओके. Yes yes.
Okay, sir. So, screen दिसत आहे सर माझी?
Yes yes yes.
Okay, sir. Thank you. So, I'm Rahul Mapari, and the presentation topic is cosmological model of interacting field in modified theory of gravity. I arranged this presentation in this part, introduction of the problems, and then what about Lyra geometry, and then metric and field equations, and then we find the solutions of that field equation, and I put a conclusion on in the last of this presentation, and then references. So this problem which I have found in regarding dark energy, but without using the special source or additional source of the dark energy, because I relate this dark energy to the cosmological constant, and cosmological constant, the role of cosmological constant plays the scalar field phi I in the Lyra geometry, and so I have used here the modified theory of the Lyra geometry. So dark energy is what actually I feel this is a magic power or villain or invisible or unseen power or dark power. In the beginning, dark energy described on the theoretical basis. It means concepts, some theories and equations are used to explain the existence of dark energy and accelerating expansion of the universe. But actually this description is not wrong and gives evidences in 1998 theoretically by Perlmutter, Brand and Race. Up to 14 years, this will become this is only a theoretical part. But after 14 years, after one of the team research on this topic, and that project name is Supernova experiment, and for that experiment they got Nobel Prize also in 2011. But after 14 years, nowadays cosmologists found the dark energy is the best candidate for the expansion of the universe, and most of the cosmologists accepted the phenomena of dark energy, but some of them are not agreed. Still, it's a big question that what exactly is the dark energy. There are some observations by the cosmic microwave background radiation that observable universe is a 4%, and mysterious matter called dark matter is around 23%, and remaining 73% is unknown, and that 73% is so-called dark energy. Now the story begins with the Albert Einstein, because Albert Einstein when found the field equation, and he feels that universe is he found the universe is not static, but at that time they have to assume this is static, and for making the field equation in a static mode, Albert Einstein introduced a lambda. There is one very famous statement by Albert Einstein that this is the biggest blunder of my life. But mistake of genius is also a good thing, and that mistake of Albert Einstein nowadays it is very useful to represent to study the nature and behavior of the dark energy. And the De Sitter is also have also worked on the same, and he have found the solutions of Einstein field equation. And then the entry of Alexander Friedman, and he changed the mind, he changed the direction of the thinking of the universe, that it is not a static. First of all, Alexander Friedman, and he put his one equation that is called Friedman equation, and then George Lemaitre is parallelly worked on the Friedman equation, or we can say Albert Einstein equation, and then Edwin Hubble is the I think very importantly, or Edwin Hubble gives the proof that universe is a non-static. And finally, in 1998, James Peebles got half Nobel Prize, if you know, in 2019. Theoretical discoveries in physical cosmology gives very important observation about 73% of unknown universe, and that was dark energy. He revised the Einstein cosmological constant, described the existence of dark energy, and this is the first equation is Einstein field equation. Then Einstein introduced a cosmological constant to balance the universe. This is the theory I have used to study the Big Bang theory, actually, because we are follower of a Big Bang theory. We subscribe Big Bang theory, and we are trying to give correctness of that theory. That's all. So modification of Riemannian geometry done by Well in 1918, but it was not satisfactory theory in view of physical significance. Again, Riemannian geometry modified by Lyra in 1951 and introduced a gauge function into the structureless manifold. Here we are interested in Lyra geometry since alternative idea of Riemannian geometry suggested by Lyra with the new idea of gauge function, which resolves the problem of non-integrability. Consecutive research done by Sen and Dunn. There are so many authors. So the field equation in form of in the Lyra manifold, Sen gives in 1957, and that is equation 1, where phi I are displacement field, and that phi I is the component 0, 0, beta. It is very important to note that constant displacement field phi I in Lyra geometry can be act as a cosmological constant lambda in GR naturally, and lambda is the best candidate. Many authors said that lambda is the best candidate to observe, to study the nature of dark energy, and that's why we have not used here external source of dark energy. We are working with a modified theory of gravity, which itself gives the presence of a dark energy. So many researchers have investigated Lyra geometry to describe origin and evolution of the universe. So in this paper, we have studied the plane symmetric cosmological model in the framework of a Lyra geometry. We have taken the energy source as an interacting field. And interacting field means we form relativistic field equation of Lyra geometry for a plane symmetric cosmological model linearly coupled with charge perfect fluid, massless scalar field, and electromagnetic field. I think Bhaskar sir have done one paper on the linearly coupled interacting field. I have read sir your paper. Then to solve the field equations, we have assumed the relation between the scalar field beta and the average scale factor A of t, and relation between metric potential. We have discussed two models here: exponential expansion model and power law expansion model. And for that purpose, I have referred the paper of Sheikh sir. And also, we have discussed some physical and dynamical parameters. So we consider plane symmetric metric of the form, this equation number 2, and the Lyra manifold is the modification of general relativity. The field equations of Lyra manifold are given by Lyra. This is equation number 3. Here T Wiggle is a linearly coupled interacting field, that Sij plus Tij plus Eij, where Sij is the perfect field distribution, Tij is the massless scalar field, and Eij is the electromagnetic energy momentum tensor. And so after solving all these equations, we get field equations, 3 field equations, equation number 5, 6, and 7. But these 3 equations are highly nonlinear with the 7 unknown. 6 unknown, and that's why we use the external constraint, and in which first constraint is we use relation between the metric potential A and B, where A equals to N B A, and second constraint we use the relation between scalar field beta and the average scale factor A of t. And we have discussed here 2 models, that exponential expansion and power law. So first model is a model for exponential expansion. We have solved the field equations, and we got Hubble parameter is constant, rate of expansion is constant, it is shear free, it is anisotropic and accelerating. So here we get the universe is expanding because h equals to k. Universe is expanding, but the rate of expansion, we get equation number 9 constant. So rate of expansion is constant, and it is shear free. We get universe is anisotropic throughout the universe, and clearly we have here the universe is in the accelerating phase. So this can be matched with the present day universe results. And the pressure and density profile is we got naturally, as I have said already, that Lyra geometry, we don't need to use additional dark energy source. Here we get pressure as negative pressure, which is a decreasing function of time, but it is negative still, and density is increasing function at positive. And this is the profile of a gauge factor beta of T and average scale factor, and this is massless scalar field. So this is the graph. We got all the functions are increasing with the time. And then second model is for power law, and we have here the Hubble parameter n by 3d, the scalar expansion n by t, and it is again a shear free and anisotropic, and this model is accelerating to the particular when we restrict the n. So if n is greater than 3, then it is accelerating, and if we use n equals to 1, 2, then it is decelerating. So this we can say this is transition phase. But here we get universe is expanding, h is n by 3t, and which is decreasing function of time. But rate of expansion in the exponential expansion law, we get rate of expansion is constant, but here the rate of expansion is decreasing with the time. So this is the profile of pressure and density. Here again we get the same profile of pressure in the both model, but about density is decreasing function. It's positive but decreasing function of time. And this is the profile of gauge factor, average scale factor, and massless scalar field. So this is also increasing. All these are the increasing function. So we can say we have matched the profile with the exponential expansion law with and power law. So, and this is the conclusion of my work. We observed that the profile of pressure, which is we get a negative, is the same in the both the model, but density is increasing in exponential expansion model, whereas decreasing in power law model. We have found universe is expanding and accelerating in both the model. So in exponential expansion model, we have constant rate of expansion, whereas in power model, rate of expansion is decreasing with time. And both the models are shear free and anisotropic throughout the universe. And these are the references I have used. And thank you very much. So as time permit, I just take a short presentation. Thank you, sir.
Now, any question for audience? Hello.
Sir, you are audible.
Hello. Any question for audience? Okay. Okay. Now next, Veena Deshmukh.
भास्कर सर, हॅलो
हॅलो सर.
हा थोडं वेळ 5 मिनिट दिलेला आहे प्रेझेंटरला, कारण फक्त 5 मिनिटाचा वेळ दिलेला आहे, त्याच्यामध्ये ते व्हायला पाहिजे त्यांचं प्रेझेंटेशन.
ठीक आहे, ठीक आहे.
Sir, I'm Miss Vrinda Sharad Chandra Deshmukh, and today I am going to deliver my presentation on topic 5-dimensional cosmological model in 2-fluid cosmology coupled with zero mass scalar field. Sir, I am working under the guidance of Dr. V.G. Mette, sir. Abstract of my paper that we have considered 5-dimensional plane symmetric Bianchi type 1 metric in 2-fluid cosmology in presence of zero rest mass scalar field. In two fluid model, one fluid represent the matter content of the universe and another fluid represent cosmic microwave background. The radiation and the matter content of universe are in interactive phase. We obtained exact solution of field equation by assuming that the anisotropy in model is inversely proportional to power of average scale factor. Also, we obtained two classes of anisotropic cosmological model, one with the power law expansion and other one with the exponential expansion. Also, the physical and geometrical behavior for both the model are discussed. So this is introduction. Currently, the study of higher dimensional space-time is an active field of research aiming to unify gravity with other forces in nature. It is believed that the universe had some higher dimensional era at its early stage of evaluation, which motivates us to investigate the cosmological model in 5-dimensional as well as higher dimensional space-time. Weinberg studied the unification of the fundamental forces with gravity, which reveals that the space-time should be different from 4-dimensional. Since the concept of higher dimension is not unphysical, the string theories are discussed in 10-dimension or 26-dimension of space-time also. Because of this, studies in higher dimension inspired many researchers like us to enter in such a field to study and explore the hidden knowledge of the universe. Several cosmologists are interested to study the two-fluid cosmological model by considering various space-time in general relativity. Samantha et al. Have investigated a class of two-fluid model of universe in 5-dimensional spherically symmetric space-time. So these are some research reviews. And in this present paper, we have investigated plane symmetric space-time with two fluid sources in higher dimension and also discussed the physical behavior of corresponding two fluid model in details. So this is line element. We consider this 5-dimensional plane symmetric Bianchi type 1, that is d square equals to dt square minus a square t dx square plus dy square minus b square t dz square minus c square t dw square, where abc are the function of cosmic time t and w is extra coordinate which is taken to be space-like. Then for Einstein field equation, we are using this one r mu nu given in equation 2, where energy momentum tensor is given in equation 3. Here T mu nu m is the energy momentum tensor for matter field and T mu nu r is the energy momentum tensor for radiation field, which are given in equation 4 and 5. Here, rho m, pm and rho r are the matter energy density, matter pressure and radiation density respectively. In co-moving coordinate system, the 5 velocity vector can be taken like in equation 6. Then the field equation of equation 2 for the given matrix with the help of equation 3 and 6 reduces the Earth system in following equation, that is given in 7 to 10. And the scalar function phi satisfies the equation given in 11. Here the overhead dot denote differentiation with respect to cosmic time t. The average scale factor and the spatial volume V of the matrix is defined in V equals to A square BC. Now the solution of field equation, here from equation given in 7 to 10, here the value of A is C1t plus C2 raised to power 1 upon 4 minus m for m not equal to 4 and A equal to L.
Deshmukh madam, please.
Yes, sir.
Conclusion क्या direct?
Yes, sir. So this is conclusion for both the model. Here we obtained the exact solution of field equation by assuming anisotropy in model, which is inversely proportional to mth power of average scale factor. So for model m not equals to 4, the spatial volume is 0 and as time t equal to minus c2 by c1 provided m less than 4. At this epoch, the rho m, pm and rho r, theta, sigma are all infinite and hence the model starts evaluating Big Bang singularity at t equal to minus c2 by c1. So the spatial volume become infinite when t tends to infinity, but the physical and kinematical parameters are 0. and anisotropy in the universe is maintained throughout, since the anisotropy parameter tends to constant here. And for the second model m equal to 4, the special volume increases exponentially as time increases. For this model, this rho m, pm and rho r tends to constant when t tends to infinity. And anisotropy in the universe is maintained throughout, since anisotropy parameter tends to constant. As we know that the sign of deceleration parameter q indicates whether the model accelerates or inflates. The positive sign of q corresponds to decelerating model, whereas the negative sign indicates the acceleration. And here, since the deceleration parameter q equal to -1, thus the model m equal to 4 inflates. And so these are some references. And thank you, sir.
Hello.
Any question for audience?
Yeah, I have one question.
Yes.
Hello.
Haan, sir.
हाँ sir, बोला ना.
What is the reason behind using the 5-dimensional space?
Sir, as my topic is higher dimensional space-time, and today higher dimensional space-time is more interesting area for researcher. And as that is my topic, so I selected my paper in this topic, sir.
Interested in which sense? Interested in which sense?
Sir, means the general existing universe is 4 dimension, and now by using higher dimension space-time, we can investigate the universe in 10 dimension and also up to 26 dimension also. Sir,
what you have observed in 5-dimensional space?
Sir, may I interfere? No, may I interfere?
Just a minute, sir. Just a minute. Hello. Yes, sir. Yes, sir.
You are asking some question?
No, yes, you can. You are free, sir.
May I interfere?
Yes.
You are the chairman, huh?
Yes.
Yes, sir.
You are asking why 5 dimensions. And the question is why higher dimensions? Why at all higher dimensions? He is saying higher dimensions, higher dimensions. See, he is talking about the universe at the time of Big Bang, immediately after the Big Bang.
Yes, sir.
Now we have what is the present is Big Bang theory. In the morning I was saying that. Immediately after the Big Bang, that is a cosmic explosion, you cannot decide about the dimensions also. Everything is in confusion. So it may be 4-dimensional, it may be higher dimensional, it may be many dimensions. So if you want to study immediately after the Big Bang, how the universe evolves, then you have to consider 5 dimensions. That is the importance of 5 dimensions. Otherwise, there is no importance, because we always deal with 4 dimensions in general relativity. In the present age, we have only 4-dimensional space-time. From the time of Big Bang, the universe has, from the hot, dense state and from cosmic explosion, it has cooled down to the present state of 4 dimensions. Meanwhile, the higher dimensions have been, what we see, there is a compactification of the higher dimensions. So we have only 4 dimensions. If you want to study at that time what is happening to the evolution of the universe, then you have to go about 5 dimensions and okay. This is the reason why you talk about higher dimensions.
Yes, sir. Thank you, sir.
Thank you, sir.
I have interfered, if you excuse me, because
no, sir. You
now she has presented her paper and she is saying something, but she should know why she is doing that, at least now.
Now, actually, sir, you are big boss in this area of research. Sir.
Not because I am still a learner, sir. I am still a learner. I am still learning, sir. After publishing 300 papers, I am still learning relativity, you know.
Yes,
more than 300.
Everybody wants to learn, sir.
Yes. Sir, more than 300.
More than 300. Don't bother about my number, but still I am learning, trying to learning. That is why I said in the morning in the keynote address, all the fundamentals. Why 5 dimensions? Why 4 dimensions? Everything. Okay, thank you.
Okay, thank you.
Yes, sir.
You should thank me for clearing it out.
Thank you, Reddy sir.
No, she should
Thank you, sir.
Who is she? Deshmukh.
Sir,
What are you doing?
I am working under the guidance of Dr. V.G. Mete, sir.
Mete, wonderful. Badnera.
Yes, sir.
Badnera, wonderful. Very good.
Thank you, sir.
Okay, sir. Now I call next participant Dipti Kapse. Kapse, madam. Now I call next participant Chandrakant Khudre. Khudre sir. Absent. Now next participant Smita Kolode.
You must have seen
Now
they must have seen Reddy साहब आ गया scene में इसलिए भागे होंगे. But they don't know Reddy sir will help them.
Reddy sir.
Namaste. Reddy sir will help them. They don't know that.
हाँ, वो आपको देख के डर गए.
अरे निमकर आ गया.
Yes sir, yes.
Next Sachin Hatkar. Hatkar sir. Next Suchita Mohta.
Yes, sir. Suchita Mohta present.
Yes, sir.
Sir, am I audible?
Yes, yes.
Yes.
Good afternoon, all. Can I share my screen?
Yes.
Yes.
You can share your screen.
Sir, is it visible to all?
Yes, proceed, madam.
Yes, sir. I am Suchita Ankit Mohta, JJT University, Rajasthan's research student. In this National E-Conference on recent advances for innovative research in mathematics, I would like to present my PPT on the study of consistency of dark energy with the Chaplin gas in F of R theory of gravitation. These are my contents. This work is based on the state finder with Chaplin gas as a pair of RS having Bianchi type 60 space-time in modified theory of gravitation F of R. This work is divided into the 3 regimes. Here it is observed that the universe is accelerating and decelerating also as depends on the value of beta. The starting of evolution of the universe in delta CDM for state finder parameter, it is at steady CDM, and while at an end point state of model having any arbitrary value, whereas regime second shows the accelerating universe with consistency, and regime 3 gives an expansion universe having constant rate of expansion with anisotropy model of the universe having no singularity. The theory of the dark energy with Chaplin gas is studied by us. It is observed that in 2003, Shahani et al. Introduced the pair RS, which is called as a state finder. And with the help of this cosmic scale factor, which is dimensionless. While Hubble and deceleration parameter are generalized by this kind of pair like RS, which is used to reflect the dark energy and dark matter also. It is used as the couple of equation of state for dark energy, and it is observed that usually its first order derivative is normally used by the researchers. The pair Rs is expressed in the form as given by the equation R is equal to and S is equal to. To explore this study, I would like to study in Bianchi type 60 universe with the modified gravitational theory F of R for dark energy with the Chaplin gas, and I would like to discuss here the consistency also. This work, as I already said, that it is divided into 3 regimes. First regime, from my first regime, I would like to say that it is very easy to say the function is time depending function, and also it shows the behavior of Chaplin gas versus the cosmic time t. These are my plotted about the first regimes. Here I don't find the consistency, while in the second I found the consistency from this graph. The modified Chaplin gas can move from phase of matter dominated of expansion to the phase of acceleration. Here it is early stage, it behaves like a matter and acts as a quintessence. But for large value, it is observed from the graph that is it likes as a big bang, like matter firstly, means at initial stage, after that it behaves like a quintessence. From my third regime, I would like to say that with the particular choice of all constant and physical parameters, it is observed that expansion scalar is time depending function, so that at present the universe seems as to expand with fixed rate. On other hand, it is also found that deceleration parameter is occurred with negative values of all possible stages of the evolution. Hence, we can conclude that the universe is accelerating. Furthermore, it is observed that mean anisotropy parameters value is never be 0 because it is calculated as 1/8, so that the model in the universe is anisotropy. From my whole work, I conclude that this work is divided in 3 regimes, from which the first regime is observed that the rate of expansion of the universe is decreases at large time. Also, deceleration parameter is occurred in both positive and negative side. Hence, it is understood that 0 value of the universe is neither accelerating or not decelerating. Other parameters suggest that the universe is anisotropic since its value is 0. And hence the evolution of the universe in delta CDM for state finder parameter, it is started at its steady for delta CDM and its end at steady state of model with a constant value of any arbitrary function. Now we will conclude that in second regime, universe expand with expansion of rate as for present universe. Current observational data suggests that the universe is accelerating, and it is also shows that the consistency is there. Also, we conclude that the universe is anisotropy for this parameter pair, that is Rs. Whereas for the third regime, it shows the expanding universe which expands with constant rate of expansion. Also, the model is anisotropy of the universe. It has no singularity for the third regime. Hence, at last, we got the anisotropy cosmological model. Same result is already obtained by the Chakravarti sir and Devinath sir in 2009. Also here, the present fluid in the universe does not act due to the anisotropy expansion increases. The modified Chaplin gas shift the universe from phase of matter dominated to the phase of expansion. Sometimes it look like the quantum phantom in the current study due to the interaction between the dark energy and model with the cosmic acceleration happens. Acknowledgement. Thank you.
Where are you working?
Sorry, sir.
Where are you working?
Sir, from JJT University, Rajasthan.
Who is your guide?
Ma'am, Prabha Rastogi, ma'am.
Who is that?
Prabha Rastogi, Dr. Prabha Rastogi. She is from Bombay, And my co-guide is Dr. M.M. Sanchiti sir from Washim, RA College, Washim.
What do you mean by saying consistency of dark energy? How do you see the consistency here? I don't see any consistency. The dark energy, the concept itself is a mystery. And you are talking about its consistency. What do you mean by that concept? I don't understand.
Sir, actually, there is so many work is already done with the modified universe gravitational field.
But so many, excuse me, so many works are done, but I have not seen anywhere consistency of dark energy.
Sir, consistency
Why
of
do you
model
use
in
that
that
word?
particular.
Why do you use that word consistency?
Sir, consistency of model, consistency of not dark energy, sir.
You are saying consistency of dark energy.
सर मॉडल का कंसिस्टेंसी चेक करते हैं जैसे पावर एक्सपेंशन हो गया एक्सपोनेंशियल एक्सपेंशन
Show me your title, please.
यस सर
Dark energy, consistency of dark energy. I am not able to see complete title. Consistency of dark energy.
On Chaplin gas, sir.
You are not talking about the model here. Consistency of dark energy. The applicant gas is different. That is a type of matter distribution. Dark energy.
Okay, sir. Yes, I got your point. I will change my heading, sir. Title.
How do you decide consistency of a model?
Sir, by finding the angular diameter and black hole.
Black hole.
Yes, sir.
What is this consistency? How do you decide? How do you black hole kahan se aa gaya beech mein?
Sir, look back time, sir. Sorry, sir, I hesitated.
Okay.
Look back time, sir. Look back time.
You change the title. No. Consistency of dark energy.
Yes, sir. I will.
Is this published anywhere? This paper?
No, sir. No.
Okay.
Still, I work on it.
Change it, please.
Okay. Thank you.
You are saying in the introduction, the universe is accelerating and decelerating, both?
Yes, sir.
In the introduction, I have seen a sentence. In the introduction, the universe is accelerating and decelerating. Somewhere you said both. Next page. The previous page, you show me previous.
Sir, introduction.
Yes.
Abstract.
In this, see. No, the next one. In this. Here is observed that the universe is accelerating and decelerating also.
Yes, sir. It is depend on the value of beta, sir.
No. You are talking about the accelerating universe, dark energy. On dark energy, you will have Q, the deceleration parameter negative, then it will be only accelerating.
But sometimes the value of beta is also positive. So it
What
got
is
as
beta? Beta, it has nothing to do with your deceleration parameter, beta. Okay, you see about these things. Okay.
Okay, sir.
Now the universe is accelerating. It has decelerating phase is over. Right. Thank you.
Okay, sir.
As far as I am concerned, thank you.
Okay, sir. Thank you.
Hello.
Now I call Miss Apurva Gupta. Hello. Absent. Next, Atharva Hussain.
Hello.
Hello. Hello. Next, Mahavir Dhave.
Sancheti is also there. Mrs. Suchita Ankit.
Absent. Next, Kailash Mude. Absent. Next, Guttarkar. Absent. Then next, Vaibhav Boke. Then NS Bayaskar. Absent.
He is SN by NS Bayaskar.
NS, I am SN Bayaskar, sir.
Yeah, that is what I am observing. You are SN Bayaskar and he is NS Bayaskar.
Then next, Prashant Dongle. Absent. Then Sharwari Wankhade.
Yes, sir. I am here. Should I share my screen, sir? Hello?
Yes, yes. Yes,
okay.
Sir.
Just give me a moment, sir, please. Is it visible?
Yes, yes.
Okay, thank you, sir. So myself, Sharwari Wankhade, and topic of my presentation is Kaluza-Klein cosmological model in self-creation theory of gravitation. I have done this work under the guidance of Dr. Anil Ninkar. Abstract of my paper, that in this proposed work, we have investigated 5-dimensional cosmological model in Barber's second self-creation theory of gravitation with cosmic fluid in presence of creation of matter and bulk viscosity. With due consideration of reasonable cosmological assumptions, within the limit we have obtained a deterministic model of the universe. Also, some physical and kinematical properties of the model are studied, and these are the keywords. First section contains some introduction. The origin of the universe is one of the greatest cosmological mysteries. These mysteries are being predicted by many researchers, and the models which are used in this research include dissipative processes. So, in the early stages of universe, the forms of matter are uncertain, but as bulk viscosity is the only possible dissipative mechanism in homogeneous and isotropic space-time, bulk viscous phenomena have been widely considered for this investigation. So I have, and also there is much more possibility that early stages of universe may have more than 5 dimensions, so that I have considered Kaluza-Klein 5-dimensional space-time. And the theory of gravitation which I have used is Barber's second self-creation theory. The field equation for this theory is given in equation 1 and equation 2, where the symbols have their usual meaning, and these are some recent work which was done in Kaluza-Klein and higher dimensional cosmological model. Second section contains metric and basic equations. So the Kaluza-Klein space-time is considered in the form as given in equation 3, where R and A are the functions of time only. Equation 4 gives the energy momentum tensor for cosmic fluid in presence of creation of matter and bulk viscosity, where rho is the energy density and P effective is the effective pressure defined in equation 5, where P is equilibrium pressure, Pc gives the creation pressure, and pi is the bulk viscous stress. And equation 6, 7 gives the coefficient components of component and trace of energy momentum tensor. By using field equation 1, 2 and metric tensor space-time 3 and equation 6, we obtained some field equation which are given in equation 8, 9, 10 and 11 respectively, where the overhead dot denotes the differentiation with respect to time. Here equation 12 is the continuity equation. And next, the simplest and most commonly used linear relation between bulk viscous stress and divergence of pore velocity is given in equation 13, where xi denotes the bulk viscosity coefficient and theta is the expansion scalar. in section 3, I have enlightened the concept of bulk viscosity with particle creation. Here equation 14 gives the particle number density and entropy flow vector. Equation 15 and 16 gives the covariant differentiation of particle number density and entropy flow vector. And for no particle creation, the source term gamma vanishes. Equation 17 gives the Gibbs equation for the open thermodynamical system, where T is the temperature of the fluid. And by some calculation using previous equations, I have obtained the rate of entropy change per particle. Then equation 19 gives the formula for creation pressure. This expression is adiabatic creation regarding the pressure arising from matter creation to rate particle production. Using above equation 19 in equation 18, I have obtained this change in rate of particle creation, entropy, and this equation 20 shows that if the bulk viscosity coefficient is 0, then the entropy rate per particle is constant. And using above equation 18, we have obtained this relation of source term. Combining equation 12, 13, and 19, we obtained this relation 22. Here we have considered barotropic fluid, and the equation of state for this fluid is given in equation 23. Using equation 23 in 25 and integrating it, we obtain this equation. And similarly, we can do it for temperature. If we consider the temperature as barotropic also, then using equation 25 and 20, we get equation which gives the entropy rate per particle in terms of temperature. Above equation shows that if bulk viscosity is 0, then the entropy per particle is constant. Then fourth section contains the cosmological solutions of the considered model. For this, I have considered average scale factor, volume, Hubble parameter, anisotropy parameter, expansion scalar, and shear scalar as shown in equation 27-31 respectively. Then I have considered a linear relation between shear scalar and expansion scalar as shown in equation 33. Using this equation and this relation, I have obtained the relation between metric coefficient as shown in equation 34. Then deceleration parameter in terms of average scale factor is considered, and from this equation, average scale factor is obtained as shown in equation 36. Equation 27 and 36 gives the value for metric coefficient A, and using this value of metric coefficient, I have obtained the another one as shown in equation 38. And also scalar field, energy density, effective pressure are also obtained as shown in equation 39, 40, and 41 respectively. And using the above values of metric coefficient, the space time which I have considered takes the form as shown in equation 42. Then to find the equilibrium pressure P and creation pressure PC, I have considered that the model is with uniform particle number density, that is eta dot equals to 0. Hence, I get the source term equals to eta into theta. Also, bulk viscosity coefficient is obtained as shown in equation 44. Similarly, bulk viscosity stress is obtained. Then using above equations, I have obtained the pressure, equilibrium pressure as shown in equation 45. Also, creation pressure is obtained as shown in equation 46. Then some physical and kinematical properties are studied, which comes under the section 5. So in this section, I have obtained spatial volume, expansion scalar, Hubble parameter, and shear scalar as shown in equation 47 to 50 respectively. Then some discussions about these parameters are done in section 6, and the graphs are plotted against time. First figure shows the plot of spatial volume versus time. It shows that the volume increases as time increases. This means that at early stages of universe, the universe must be expanding. Similarly, equation 2, 3, figure 2, 3, and 4 shows that expansion scalar, Hubble parameter, and shear scalar decreases as time increases, and these quantities vanishes as time tends to infinity. Then Lastly, the conclusion. In this paper, we have worked on higher dimensional cosmological model in Barber's second self-creation theory of gravitation with cosmic fluid as source of gravitation in presence of creation of matter and bulk viscosity. Some physical and kinematical properties of the model are studied. The obtained model is observed to be expanding. It concludes that in early era, the universe was expanding. Equilibrium pressure and creation pressures are calculated by considering the model with uniform particle number density. It was observed that if bulk viscosity is 0, then entropy per particle is constant. Particle number density and temperature of the fluid are also calculated. And these are the references which I have used. That's all. Thank you. Thank you, sir.
Any question for the audience?
Show me your references.
Yes, sir.
Please show.
Yes, sir. Yes, sir.
Please show me your references. All right. Kaluza-Klein model and self-creation theory of gravitation. There is a lot of work done by Reddy and his group. Not even a single reference is that you have not seen. You have not gone through the literature.
Yes,
Perhaps
sir,
who
actually,
knows?
I have-
Reddy, Professor Reddy must have done Kaluza-Klein model also in 300 papers.
Yes, sir. I have referred many research papers, but
Where is this? Lot of work has been done in self-creation theory. No reference. Okay. You are talking about continuity equation. You show me your continuity equation, conservation equation.
yes, sir. Just a minute. Yes, sir.
This one.
Yes, equation 12.
Is it the usual conservation equation?
Yes, I have derived it from conservation equation. Covariant derivative of energy momentum tensor equals to 0.
0. That's all. That is not there in this theory. That is not satisfied. You have to do something with pressure and density. These papers, original papers.
Hello?
The usual conservation equation will not be valid here in this theory. You have not seen that also. You have taken usual conservation. This is self-creation theory. When there is self-creation, usual conservation theory will not be valid. You must see the literature.
I will see for it, sir. Okay.
Okay, you just verify those things.
Yes, sir. I will go for it. Thank you, sir.
Lot of disturbances.
हो शांत वाढा म्हटलं आता शांततेने क्लासेस घ्या हा असं वाटलं
It is better to mute everyone except the chairman and the speaker.
पगार घेतला मी
What is happening?
No, someone is discussing, sir. Yeah, they can mute themselves.
त्यांना म्यूट करा सर.
It's a humble request to the participant. Please mute their mic. It's a humble request to all the participants. Please mute their mic. It's a humble request. Please mute your mic, please. Bhaskar sir, over to Bhaskar sir.
Next participant, Bhaskar sir. Nimkar sir.
Bhaskar sir.
Hello.
Call to the next participant.
Next participant, Yendamuri Shoban Babu.
Yes, sir. Am I audible, sir? Sir, may I audible?
Yes, yes.
Yes, yes, yes.
Okay, sir. So just a moment, sir. I am sharing my screen. Okay, myself, this is good afternoon to everyone. Myself, this is Shoban Babu. I would like to present my paper entitled Anisotropic New Azigraphic Dark Energy Model with Sign Changeable Interaction in a Scalar Tensor Theory. The main contents of the paper. These are the contents and the introduction. Okay, so the introduction, the cosmological observation, namely supernova, Rice-Whittle 1998, Parliameter Vetter 1999 have provided convincing evidence that our universe is dominated by two dark sectors containing dark matter and a dark energy. The behavior of dark matter and dark energy is one of the most important issues today in modern cosmology. The approaches to answer these dark energy problems and cosmic acceleration issues fall into two categories. First one, introduce dynamical dark energy models in the right hand side of the Einstein field equations in the background of the general relativity. Second one, modify the LHS left hand side Einstein field equation. It leads to the modified theories of gravity. We refer Padmanabhan Copeland 2006, Bomba Whittle 2012 for detailed investigation of dark energy models and modified theories of gravitation. So in this context, the holographic dark energy and azigraphic dark energy, which contain some vital role properties of the quantum gravity, have been proposed a candidate as a candidate of dark energy. These dark energy are able to present a unified model of the universe, explain some other problems of the modern cosmology, like coincident problems, and refer Noseri Presta 2006. By this motivation, Cohen-Whittle 1999 have investigated vacuum energy density is proportional to the Hubble square. Zhu have proposed 2007 have proposed the original new azigraphic dark energy model in which the dark energy the energy density of the azigraphic dark energy is defined as in the form of the equation number 1, the main abstract. So this work examines the dark energy phenomenon by studying the new azigraphic dark energy and dark matter within the framework of trans-decay scalar tensor theory of gravitation. To achieve a solution, we consider Weibull deceleration parameter, which contributes to the average scale factor. A is equals to e to the power of 1 by gamma into square root of 2 gamma t plus C1 here, gamma 1, C1 respectively arbitrary and integration constant. We have derived the field equation of trans-decay scalar tensor theory of gravity with the alpha of axially symmetric universe. We have constructed two cases of non-interacting and sign-changeable interacting component scenario. So we have investigated cosmological parameter, namely deceleration parameter, energy density of dark matter, and new azigraphic dark energy, trans-decay scalar field, skewness parameter, and equation of state parameter. The physical debit of these cosmological parameters are investigated through graphical representation. So moreover, the stability of the models are explained through square speed of sound, and well-known cosmological planes RS, RQ, and omega A, omega A dash are constructed, analyzed to graphical representation for our model. So metric and field equation of the new azigraphic dark energy model in branch decay. We consider spatially homogeneous anisotropic axially symmetric universe as equation number 2. Here A and B are functions of the cosmic time t. So here the branch decay field equations are equation number 3 and 4 equation represent the scalar field 5. These are the branch decay field equation for axially symmetric universe. So equation number 5 to 8. Solution of the field equation and model. And U of the field equation number 5 to 8 constitute a system of 4 independent equations with 6 unknowns. Here unknowns are, these are the unknowns A, B, rho, M, omega, A, pi, and alpha. Hence, in order to find the determined solution of these non-linear equation, we use the following feasible condition, physical condition. The shear scalar sigma square is proportional to the scalar expansion theta, which leads to the relation between the metric potential. So this is discovered by Collins Whittle 1998. A is equals to b to the power of equation number 9. Here beta not equals to 1 is a positive constant, preserves the non-isotropic character of the universe. The deceleration parameter is taking a linear function of the average scale factor. Tiwari and Sharma is discussed. So Q is equals to K2 plus gamma into A dot by A. So equation number 10. Here K2 and gamma are arbitrary constant. So whenever taking K2 is equals to -1, we get the solution. Equation number 10 is equation number 11. Here C1 is the integration constant. Hence, the auxiliary symmetric universe equation number 2 can be written as equation number 12. So in this, here also some of the properties are also physical properties also mentioned, and also geometrical representation also discussed. But here I couldn't mention here. Just I am giving the key points. So in this work, the conclusion of the paper, in this work we have studied spatially homogeneous anisotropic axially symmetric new azigraphic dark energy model in the branch decay scalar tensor theory of gravitation. To obtain a determined solution of the model of the universe, you consider some physical feasible condition. These condition leads to the varying deceleration parameter, which represent a transition from past decelerating universe to present accelerating universe. The main conclusions of the paper is mentioned here. So in non-interacting new azigraphic dark energy model, we have observed that scalar field phi is increasing function of the cosmic time t, and cosmic evolution scalar field phi stays positive. The skewness parameter alpha is positive and decreasing function. So we also noticed that alpha is approaches to 0 at late time, and energy density rho A of new azigraphic dark energy. The trajectory of rho A is increasing function of the cosmic time t, and it is positive behavior throughout the evolution. So we can observe EOS parameter omega A is completely varies in the pattern region. Only the plane omega A dash for our model is freezing region. So for the various values of small delta, the square speed of sound is a decreasing function of the cosmic time t. So it is negative throughout history of the universe for various values of delta, which describes our non-interacting new azigraphic dark energy model is unstable. In case of sign changeable interacting in new azigraphic dark energy model, we have observed that EOS parameter of equation state parameter of our model start from quintessence region, crosses the pattern divide line, and finally approaches to constant value in the pattern region for various values of delta and C. The trajectory of omega A dash provides freezing omega A is less than 0, omega A dash is less than 0 in the region only for the chosen values of gamma and small delta and C. The square speed of sound for sign changeable interacting new azigraphic dark energy model in branch decay theory is stable for a small time and exhibits unstable with the passage of the cosmic time. So the deceleration parameter Q, observe that there is a sign change in the trajectory of deceleration parameter Q from positive to negative value. So it represents that universe smooth transition from the early decelerating region to accelerating region at a late approach. The trajectory of RS plane, the model behave like a quintessence model. In early time, it passes through lambda CDM model, and later approach it reaches to Chaplin gas model. So, and the trajectory of QR plane, our model approaches to steady state when R is equals to 1, Q is equals to minus. So these are some references. Thank you. Thank you, sir. Sir, may I audible, sir?
Yes, sir. Yes. Ask us, sir. Ask us. Hello. Bye. Sir. Nemkar sir. Dr. Nemkar sir.
Sir, may I stop my screen, sir?
Yes, sir. Yes, sir. Yes, sir.
Hello. Hello.
Yes, sir.
Ask us, sir.
Hello.
Hello, Bhaskar sir. Hello.
Hello.
Hello, Bhaskar sir.
Hello.
Hello.
Hello. Hello.
Bhaskar unmute तुम्हाला unmute करा सर तुम्ही.
Hello.
Yes, sir. Yes, sir.
Hello.
Hello, Bhaskar sir. शेख सर बोल रहे सर.
हाँ बोला ना सर.
सर टाइम पार्टिसिपेंट खूप सारे आहेत. हॅलो.
हाँ आणखी 12 लोक आहेत. हॅलो.
सर आपण एक रिक्वेस्ट करू सर कारण की आपला हा जो कार्यक्रम आहे तो पण घ्यायचा आहे. वी आर रनिंग आउट विथ द टाइम. So it's a humble request to all the participants that we will consider this presentation after this ceremony. So it's a humble request to Bhaskar sir, please conclude the session so that we can start with the felicitation program of Dr. S.D. Katore sir.
Okay, sir. Hello.
Bhaskar. Hello. Hello.
हाँ सर.
Hello. Hello. Bhaskar.
Yes sir.
Bhaskar. कुठे आहे कतोर कुठे आहे?
हॅलो. हॅलो.
अरे कतोरे कुठे आहे? स्क्रीनवर दिसून राहिला पोरगा दिसून राहिला कतोरेचा.
अच्छा ठीक आहे ना सर. ते
तेच म्हटलं अरे मी अमरावतीमध्ये आहे. तुम्हाला काही जाणीव आहे की नाही? काल सकाळी मी अमरावतीमध्ये आलो. हॅलो.
बोल रहा है पता नहीं.
अमरावती इटसेल्फ.
ओके.
हाँ सर.
हॅलो.
हॅलो. सर आवाज येतोय तुमचा?
2 मिनिटं सर.
हे तुमच्या आजूबाजूला जनता आहे, त्या जनतेला म्हणा एखादा फोन तरी केला का आढाव सरांना.
अरे कतोरे कैसे आ गया? हाँ, बड़ा ये बन के आ गया, बड़ा साहब बन के आ.
अरे बड़ा साहब बन गया, सुपर प्रोफेसर बन गया, लेकिन
अरे
अपने को भूल गया ना.
हमारे कतोरे साहब बन गया.
हाँ साहब बन गया. तो सर मैं कल से यहाँ आया हूँ.
अरे आडो साहब ये तो साहब बन गया.
हाँ
आ तो माया हो गया. सुबह से दिखाया नहीं.
देखिए सर,
अरे थोड़ी सी डिफरेंस है. ये साहब बन गया, तू गायब बन गया, गायब हो गया.
नहीं, ये तो बिजी होगा, आई कैन अंडरस्टैंड. लेकिन जो आजू बाजू पीछे जो चल रहे हैं, इनमें से किसी को भी याद नहीं आया कि भैया यहाँ पर कोई है करके, किशोर नाम का आदमी अमरावती में वापस आया है पुणे से अकेला. हाँ, सो आई वाज वेटिंग. सवेरे मैंने करड़े साहब से बात की. करड़े साहब बोले
आ गया हमारा गुरु आ गया, साहब बन के फैमिली के साथ आ गया हमारा गुरु जी.
ये अभी ये फंक्शन फेलिसिटेशन का कंक्लूड करने जा रहे थे.
अच्छा.
So I thought I should interfere it. कतोरे
You always interfere. You don't participate.
या. अभी फंक्शन चालू है कि खत्म हो गया? भास्कर
नाही सर, चालू व्हायचं आहे सर. जस्ट चालू व्हायचं आहे सर.
चालूच व्हायचं आहे.
चालू आता.
मला असं वाटलं 3:30च्या जवळपास चाललो होतो तुम्ही, म्हणजे चला चांगली गोष्ट आहे. चला चालू करा.
हो.
कैसे है मैडम कतोरे? अरे कतोरे साहब, मैडम को बोलने दो. कैसे हैं?
रेड्डी सर, उनको अभी सुनाई नहीं देगा सर, क्योंकि कैमरा यानी मोबाइल उनके पास नहीं है सर अभी.
अच्छा, सुनाई नहीं देगा.
हाँ, सिर्फ वीडियो उनकी तरफ लेके जा रहे हैं, उनको आवाज नहीं सुनाई जाएंगे अभी तक.
ठीक है.
जब वो माइक पहनेंगे.
अरे सुनने में क्या है, देखने तो है. देखते तो रहे. But Katore, he is becoming old. No, he is retiring all right, but he is looking old, very old. यादव साहब तो लुकिंग यंग.
अरे आप साथ में है तो हम लोग यंग हैं. क्यों
साथ में कहाँ है?
आप लोग साथ में है तो हम लोग यंग
हैं भैया. मुझे बे ऑफ बंगाल में
थके नहीं हो तो हम क्यों थकेंगे?
आप लोगों ने बे ऑफ बंगाल में फेंक दिया मुझे.
सर यू हैव डिलीवर्ड वेरी नाइस स्पीच.
कहाँ सुना है?
मैंने सुना है.
हाँ. थैंक यू. इट इज नाइस.
करड़े साहब का बंद हो गया था, कुछ प्रॉब्लम आ गया था.
करड़े साहब बंद हो गया, भाग गया.
नहीं ये सर, ये अभी मैं क्या बोलता हूँ, कंप्यूटर से ये मेरे मोबाइल का नेटवर्क यूज कर रहा हूँ.
अच्छा.
अभी किसी का फोन अगर आ गया है ना तो नेटवर्क कट हो जाता है. दैट इज द प्रॉब्लम.
यू डोंट हैव.
बेटा सुरू करा ना. अरे कोण आहे तिथे, सुरू करा. ऑनलाइन ला वेळेचं महत्व असते.
जब आडव साहब आ गया तो शुरू करना है क्या?
यस.
अरे मैं तो राह देख रहा था कि किसी का फोन आएगा. कोणीही आठवण केली नाही. मी अमरावतीमध्ये काल सकाळी पोहोचलो एकटा पुण्यावरून.
ऐसे कैसे शुरू करेंगे? जब आडव साहब आ गया शुरू करेंगे क्या? सबको आना है.
मैं तो सर मेरे घर में बैठकर वे कर रहा हूँ. ये लोग मुझे अगर बुलाने के लिए आते थे या मुझे एक रिंग भी करते थे कि भैया तुम ऑटो करके आ जाओ.
कहाँ आ जाना? सब घर में बैठेंगे एक बार. ये तो ई कॉन्फ्रेंस है.
ये तो डिपार्टमेंट में बैठे हैं सर सब लोग, जो दिखाई दे रहे आपको.
हाँ, सब लोग कहाँ में 2 बैठे हैं.
नहीं, आप आजू बाजू का देखो ना, तब इसके पहले का वीडियो देखो.
आजू बाजू का पता नहीं,
अभी इसमें नहीं दिखाई दे रहा है, बाद में देखेंगे.
Now it's a humble request to all the dignitaries. Yes, sir. all the dignitaries, participants, and well-wishers, we invite you to the superannuation function of Dr. S.D. Kature, Professor and Head, Department of Mathematics, Sant Gadge Baba, Amravati University, Amravati, along with Mrs. Sandhya Shivdas Kature.
Many disturbances.
Invite all the dignitaries, participants, and well-wishers for the superannuation function of Dr. S.D. Kature, Professor and Head, Department of Mathematics, Sant Gadge Baba University, Amravati, along with Mrs. Sandhya Shivdas Kature on 20th September 2021. On successful completion of more than 36 years of service in various capacities at Sant Gadge Baba Amravati University, Amravati, and MK Commerce and Shri Rathi Science College, Washim, District Washim. Now, before to start with the felicitation function, a few lines I would like to share for Professor S.D. Kature, sir. You are a special person who teaches us in class and help us to learn in a world that moves so fast. You inspire, groom us so that we can grow, but we are touched because of the love you show. Every day you plant a seed so that we can learn and succeed. We are thankful what you have done. Oh, my teacher, you are number one. So these are the few lines, specially designed by my daughter, Ashlyn. So for your respect, sir, she had done a poem. And now, Dr. S.D. Kature is working as a professor and head in Department of Mathematics, Sant Gadge Baba, Amravati University, Amravati. Sir worked as Sir is having a research experience of 24 years in Science College, Washim, and 10 years in postgraduate of mathematics. Sir have attended 52 seminar, conferences, symposium, refresher orientation courses all over India. Sir have organized and conducted 46 seminar, conferences, orientation refresher programs. Sir worked as a member of organizing committee of International Conference ICR 2005 in Sant Gadge Baba, Amravati, Amravati during the year 2005. Sir also worked as organizing secretary of International Conference ICGR 2008.
Yes, sir. Connected.
Hello. Am I audible? Am I audible?
You are audible, don't worry. Yes. Am I audible?
Sir worked as
Yes,
a
sir.
convener. Yes, sir. Yes.
Okay.
Sir worked as a convener in the National Conference on Recent Advances in Mathematical Sciences, NCRAIRM 2016, in Sant Gadge Amravati University, Amravati during the year 2016. Sir also worked as a co-convener in the International Conference on Recent Trend in Science and Technology, which held in 2018. The gray area of research, general theory of relativity and cosmology, and theories of gravitation. Sir read 28 research papers in various conferences at national and international levels. Sir is also a referee and editor of various international journals. Sir have more than 131 papers in national and international journals. Sir has guided 11 PhD students and 3 are working under him. At the same time, Sir have under his guidance 11 MPhil dissertation have been awarded and 2 are still working. Sir have published 5 books and Sir have been appointed on 11 confidential apex bodies. The administrative experience as a head of department of Sir is 33 years for UG and PG. Sir worked as a coordinator of IGNU Study Center, Sant Karke Baba Amravati University, Amravati. Sir also worked as a coordinator in for National Mathematics Day, DST and university sponsored programs. Sir also held the chairperson of Board of Studies of Sant Karke Baba Amravati University, Amravati, and president of Sant Karke Baba Amravati University Mathematics Teacher Association. At the same time, Sir holds various positions of the apex bodies. Sir is also Board of Studies of member in Mathematics, SRTM Nanded and Gondwana University. Sir is also a member of Board of Studies in Mathematics, JP Science Mahavidyalaya Varda, Autonomous Institute. Sir is also a member of RRC, Rashtrashan Tukdoji Maharaj Nagpur University, Nagpur. Sir is also ex-member of, worked as ex-member of Board of Studies in Mathematics, ex-member of Management Council, Academic Council, RRC, Faculty of Science. Sir is also a life member of 10 bodies. The most important part of Sir is, Sir has been awarded as Maharashtra Government Research Scholarship in 1996 and Mahatma Jyotiba Phule Rashtriya Adarsh Shikshak Puraskar in 2016. Now, with respect to this, the main part in the life of Sir is the better half of Mrs. Sandhya Shivdas Katore. Madam is working as a junior lecturer in RDIKD Badnera. Along with this, Sir has got support of 2 children, Dr. Mayur Katore, finished ME in Electronics Telecommunication. At the same time, Mr. Piyush Katore, he has completed B Computers. Now, with these words, I would like to request Professor V.G. Mete sir and Professor Kandalkar sir, S.P. Kandalkar sir, Mrs. Kandalkar sir and Dr. Prachi Agrawal ma'am to please felicitate Professor S.D. Katore sir and Madam Sandhya S. Katore ma'am.
फेलिसिटेशन सुरू आहे
ते त्यांनी ऍक्सेप्ट नाही केलं माझं
त्याच्यातून नाही होत का माझा संपला आता
Now I request Dr. Prachi Agrawal ma'am and Kandalkar ma'am to please felicitate Mrs. Sandhya S. Katore ma'am.
एजुकेशनचा प्रोग्राम काय झाला
Thank you, ma'am. Now I would like to
For reading of Samman Patra, Mr. Bharati sir.
आदरणीय गुरुवर्य डॉक्टर शिवदास देवमनराव कतवे, आपल्या प्रदीर्घ कार्याचा गौरव म्हणून आज 28 सप्टेंबर 2021 रोजी आयोजित राष्ट्रीय गणित परिषदेच्या निमित्ताने इंदिरा गांधी कला महाविद्यालय राळेगाव आर्य कला श्री NK वाणिज्य व श्री SR राठी विज्ञान महाविद्यालय वाशिम आणि सर्व विद्यार्थ्यांच्या वतीने आपणास हे सन्मान पत्र बहाल करताना आम्हाला अत्यंत आनंद होत आहे. गुरुवर्य, अकोली जहागीर तालुका अकोट जिल्हा अकोला येथील दुर्गम भागातून सुरू झालेला आपला प्रवास अत्यंत दैदिप्यमान आहे. शेतकरी कुटुंबातील वडील देवमनराव व आई देवकीबाई यांच्या संस्काराची शिदोरी घेऊन आपण गोरगरीब तळागाळातील विद्यार्थ्यांशी माहेरी खऱ्या अर्थाने संत गाडगेबाबांचे विचार कृतीतून आणि आचरणातून जीवनशैली अवलंबली. आदरणीय गुरुवर्य, अध्यापन हा तर आपला पिंड आहेच, परंतु विद्यापीठांच्या विविध प्राधिकरणावरील आपल्या नियुक्तीने आपण आपल्या कार्यांची वेगळी ओळख निर्माण केली. गणित RRC समिती सदस्य, पेट ऍडवायझरी समिती सदस्य, IQAC सदस्य, फायनान्स समिती सदस्य इत्यादी अनेक समित्यावर आपल्या कार्यांची अमिट छाप पडली आहे. कोणतीही जबाबदारी पार पाडताना सामान्य विद्यार्थीच आपल्या डोळ्यासमोर राहिला आहे. प्रिय गुरुवर्य, आपले शैक्षणिक व संशोधनात्मक कार्य अत्यंत मौलिक व व्यापक आहे. आपण आतापर्यंत 11 MPhil व 10 PhD विद्यार्थ्यांना मार्गदर्शन केले आहे. 138 शोध निबंधाचे तर 5 संदर्भ ग्रंथाचे लेखन केले आहे. 28 विविध राष्ट्रीय तसेच आंतरराष्ट्रीय परिषदांमध्ये शोध निबंधाचे वाचन केले आहे. 3 आंतरराष्ट्रीय आणि 1 राष्ट्रीय गणित परिषदेचे यशस्वी आयोजन केले आहे. आदरणीय डॉक्टर TM करडे सरांचा वारसा पुढच्या पिढीपर्यंत पोहोचविण्यासाठी आपली धडपड सर्वांना ज्ञात आहे. आपुलकीने, प्रेमाने, विश्वासाने, स्नेहभावाने आणि स्वयंशिस्तीने आपण मार्गदर्शन करीत आला आहात. गुरुवर्य, आपले संशोधन हीच आपली खरी ओळख आहे याची आम्हा सर्व विद्यार्थ्यांना जाणीव आहे. बोले तैसा चाले ही युक्ती आपल्यासाठीच आहे. आम्हाला वाटते आपल्या जीवनात शील, चारित्र्य व प्रामाणिकपणा आपण कुठेही ढळू दिला नाही. साधेपणा, सुजाणपणा, चिकित्सक, संशोधक असे आपल्या व्यक्तिमत्वाचे विविध पैलू आहेत. आपण प्रेरणेचा अखंड जरा आहात. म्हणूनच आपणाला महात्मा ज्योतिबा फुले राष्ट्रीय पुरस्कार बहाल करण्यात आला. याचा आम्हा सर्व अभिमान आहे. आदरणीय गुरुवर्य, अज्ञात आपल्या अर्धांगिनी संध्याताई, मुले मयूर आणि पियुष यांनी आपणास मोलाची साथ दिली आहे. विद्यार्थी, शिक्षक, कुटुंब, वत्सल, मुलगा, भाऊ, पिता आणि मित्र अशा विविध भूमिकांमधून आपण आपले जीवन एक आदर्श म्हणून प्रस्थापित केले. आपण दिनांक 30 सप्टेंबर 2021 रोजी नियत वयोमानानुसार सेवानिवृत्त होत असलात तरी शैक्षणिक प्रक्रियेतून निवृत्त होत नाही. आपल्या पुढील आयुष्याकरिता आमच्या सदिच्छा सोबत आपणास हे सन्मान पत्र आदरपूर्वक प्रदान करण्यात येत आहे अशा आम्हा सर्व आवर्जून सांगावशी वाटते. धन्यवाद.
थँक्यू सर. क्वेश्चन करून घेतलं पण आपलं अजून काम हे आहे म्हणते, बंद आहे म्हणते त्या थर्ड समजा. हो लागला आता कारण का काय माहिती.
I request all the participants Now I would like to request Honorable Dr. T.M. Kurde sir to express his views about Dr. S.D. Katore sir. I think the sir has not joined. Now I would like to request Honorable Dr. D.R.K. Reddy sir to express his views for Dr. S.D. Katore sir.
Thank you.
Sir,
Am I audible?
Reddy, sir. Okay.
Am I audible?
Yes sir, yes sir. Yes sir, yes sir.
Thank you for giving me this chance to speak a few words about my great friend Guruji. I usually call him Guruji. Whenever I go to Amravati, I usually call him Guruji. Even in front of the Vice Chancellor, I told him my Guruji. He was also very much surprised to see that I am his Shishya. Okay. Now, apart from his credentials, I should say, he has published so many papers, he has produced so many PhDs, he has worked very well in the department, he has completed complete service, and he is now retiring after completing the complete service. And what I heard is he is also going to be a senior professor. He is going to retire as a senior professor for health. So, as if you see the academic side, he is a very nice and perfect gentleman. And he is personal, from personal side also, he is a perfect gentleman. Now, have you seen at any time perfection and satisfaction? Personification of perfection and satisfaction. If you have not seen, see him. See S.D. Katore, Professor S.D. Katore, you can see perfection and satisfaction. And yes, let me again stress this fact. If you have not seen the word perfection, the word satisfaction, he is a personification of these two things. I have been observing him for so many years. See, when I have seen that Professor Ada is appointed there in that university, Sant Garge Baba Amravati University. That the university was without mathematics head or mathematics all contributor teachers. When Professor Ada was appointed, I was with that department right from that date. And I have seen that these two people, Vadhav and S.D. Katore, how they have developed the department and how they have developed themselves along with the department. See, developing department, and at the same time, they should also develop themselves. And I have seen S.D. Katore, Professor S.D. Katore, developing himself. Right. So for so many years, I have been visiting that Amravati University, and people used to say that sometimes, "Arey Amravati, aapka sasural ban gaya hai. Mera sasural ban gaya hai Amravati." That way I used to visit Amravati, and I was present in each and every academic event that was held in Amravati or in Nagpur. And I always observed him, that this man, this gentleman, I should call him a gentleman, and not that others are not gentlemen, but this gentleman is perfect gentleman for me. Okay. Now, I remember those days when he was working for PhD. I used to go to Amravati University, and we used to sit in the guest house. Whenever I go to Amravati University, I go to guest house. I was placed in the guest house, and he will never leave me alone. He will be along with me, even at the night time also, leaving the Mrs. Sanjay Katore also. He used to help me that way. Okay. So I remember those days now. Gone are those days. Kahan gaye wo din? क्या बोलते हैं वो song है कहाँ गए वो दिन कहाँ गए भैया कतोरे साहब I still remember those days. Those days and those experiences linger long in my mind, and they will linger long in my mind forever. And I have seen a perfect gentleman and perfect satisfaction, man who is satisfied. No, I don't want to say anything else about his credentials. Yeah, that everybody knows. Professor Katore has published so many papers, produced PhDs, everything. That is a different issue. But as a human being, as a perfect human being, I have to congratulate Professor Katore at this juncture. And even Mrs. Sanjya Katore also, whenever I go there, she used to come and see me even if I don't go to her house. So that way, I congratulate them and I thank them. And at this juncture, I should congratulate Professor Katore and Mrs. Sanjya Katore. And I have nothing else to say about Katore, only these few lines. Thank you for giving me this opportunity to say a few words about my great friend, philosopher, Guruji. Whenever he talks to me or whenever he puts a message in WhatsApp, ये क्या बोलते हैं पता है? चरण स्पर्श. हम चरण स्पर्श करते हैं. ये बोलता है चरण स्पर्श. Even in WhatsApp, even in whenever he talks on phone. Can you see such a gentleman? I have seen. That is Professor Katore. Thank you for the organizers who has given me this opportunity to say a few words about my great friend and Professor Sanjya Katore, Mrs. Sanjya Katore. Thank you.
Thank you so much, sir. Now, Honorable T.M. Kurde sir have just joined. Request Honorable T.M. Kurde sir to please express his views. Hello, Kurde sir. Kurde sir has just joined. I request Honorable T.M. Kurde sir to please express his views on the overall life of Dr. S.C. Katore. I think there might be some issues. Now next, I would like to request Honorable S. Adau sir, ex-professor and head, Department of Mathematics, IGNT University, Amarkantak, Madhya Pradesh, to express his views regarding with Dr. S.C. Katore sir. Honorable Adau sir. Hello.
Hello.
Hello. Over to you, sir. Over to you.
कौन बोलता है?
Sir, Dr.
हाँ?
Hello.
Hello.
Adau साहब, it is your turn.
तुम्हाला बोलायचं आहे सर.
आपको बोलना है.
तो मुझे बोलना है, लेकिन मुझे म्यूट करके रखा था ना, इसलिए कैसे बोलेंगे?
किसने म्यूट किया? आपने म्यूट कर दिया होगा.
नहीं, किसी उधर से म्यूट भी कर सकते हैं ना.
अच्छा.
If you don't want to listen.
अरे आडव साहब को म्यूट करने वाला कौन है?
वही तो मैं पूछ रहा हूँ, उधर से कौन है करके. इधर हर्षल परळेकर मुझे नाम लिखकर आया है.
अरे अनम्यूट करो भैया इनको.
नहीं, अभी किया है.
ठीक है.
So, my Guruji, Professor Kurde sir, my next Guru, Professor Reddy sir, और सब ये ऑनलाइन वाले जो वहाँ पे रिव्यूअर्स है, ऑब्जर्वर्स है, रिसर्चर्स है, कुछ लोग मुझे देखकर पीछे दौड़ रहे हैं, पीछे भाग गए हैं, आगे आ रहे हैं. So leaving apart all these things. I am here to congratulate Professor Katore. मुझे कल ही पता चला है कि he has been promoted as a senior professor. So this is good for him, his family, and to my department also. Good achievement. So I would like to congratulate him and his family. Karde sir, he is also facing the same difficulty which I am facing. ये किसी का कॉल अगर आ गया है, इसमें रिंग आ गई है तो ये डिस्कनेक्ट हो जाएगा. तो ज्यादा समय बर्बाद न करते हुए श्रीमती संध्या जी इधर देखो, स्क्रीन की तरफ आपको दिखाई देते हैं कि नहीं हम लोग? हाँ, आता हसून ना ले. और ये मयूर एंड पीयूष, मुझे तो एक ही दिखाई दिया. इधर ही में भी मयूर और पीयूष दोनों ने ही दिखाई दिए. So enjoy with your father. Now,
yes, sir, yes.
Now Katore will waste his all time with his family. मॅडमला RDI कॉलेज मध्ये सोडून देता येईल, घेऊन येता येईल वगैरे वगैरे वगैरे. मग नंतर प्रत्यक्ष भेट झाल्यानंतर आणखी बोलूच. I will not consume more time. Again, I would like to congratulate. I would like to welcome in our retired professor's family with Professor Reddy sir, Professor Sriramji, Karde sir.
मेरा तो 17 years हो गया है, अब क्या वेलकम.
हाँ नहीं, अभी भी आप यंग हो सर. You have delivered very nice speech. वो किसी ने मुझे वहां पर भी म्यूट कर दिया था तो मैं साइलेंट ऑब्जर्वर करके आपको सुन रहा था. Okay, that is not my problem. So again, wishing everything good, all the best on your retirement. फिजिकली मी इथे अमरावतीमध्ये असून कालपासून तिकडे येऊ नाही शकलो, याबद्दल मी क्षमा मागतो दोघांची, संध्या अँड SD कतोरे बोथ. त्याचं कारण तुम्ही समजून घ्या. ओके, ऑल द बेस्ट. थँक्यू व्हेरी मच ऑर्गनायझर्स. Thank you very much. Great, thank you to all.
Thank you, sir.
Thank you, sir.
Now I would like to request Dr. J.N. Salunke sir, ex-professor and head, School of Mathematics, SRTM University, Nanded, to express his views.
Good afternoon to all. ऐकता येते ना? माझा आवाज ऐकू येतो का?
आवाज आ रही है.
Yes sir.
Honorable Reddy sir, Adao sir, other dignitaries of felicitation and superannuation ceremony of Professor SD Katore. It is a great event of celebration of his completion of successful teaching works to his students and all well-wishers. I wish him and his family members good future and health, and wishing him for continuing research and guidance to students. He is sober in nature and not involved in any controversy, which is his greatness. I think I know him from 1985. I have worked in his hometown, Akot. He has done MPhil, PhD from Nagpur University under supervision of Honorable Karde sir. He joined Department of Mathematics, Sant Gadge Baba, Amravati University in session 2008 to 2009, I think. Before that, he was working as a head Department of Mathematics RA College, Washim. Now, he has worked in university with the various positions, capacities as a member of BOS, Faculty of Science, Chairman, RRC, BUTR, Academic Council, Management Council, and by default, other positions as he is head of the department of University Department. He also worked as a member of BOS, RRC in some other state universities. Under his guidance, students has awarded MPhil, 11 student, I think, and 10 PhD. And his research paper published in reputed national, international journals. And he is co-author of some BSc level mathematics books. In earlier session, Reddy sir has given some list.
क्या हो गया? म्यूट हो गया उनका भी.
Just maybe there.
Some problem? सोलंकी का प्रॉब्लम है साहब. सोलंकी साहब. अरे आप बोले ये कौन है? पीयूष और मयूर?
मयूर है सर, मयूर.
मयूर, अच्छा.
जी जी सर.
बड़ा पीयूष नहीं आया क्या?
Due to some technical issues.
पीयूष भी है बैकग्राउंड में.
Due to some technical issues.
He is there. Okay.
Yes, yes, sir.
This is a nice occasion. Both of you should be here. That is what I thought.
Yes, sir. We are.
Due to technical issue, I think Dr. Jain sir left. So now I like to request. Now I would like to request Dr. S.P. Kandalkar sir, ex-head at Department of Mathematics, Government with the Institute of Science and Humanities, Mahavidyalaya. Kandalkar sir.
Hello. Am I audible?
Yes, sir. Yes, sir. Yes, sir.
I thank. First, I congratulate Dr. Katore sir for his completing 36 years of service and retiring on this on 30th September. So, although today I have technical issue, instead of that, the felicitation program of the Katore sir, we are enjoying very lot. So many people are also gathered in department, and also our this connected online on our I don't know exactly what many people attended this कार्यक्रम. I first Unmute केला आहे ना? हा. All the dignitaries present here, I call the name of Dr. D.R.K. Reddy sir, Dr. Adhav sir, Dr. Solonke sir, in this felicitation program of the Dr. S.D. Kothari sir. So, what to say about Dr. Kothari sir? Just like that, Reddy sir has called him very nice and honest person. So the same opinion is of mine. He is really honest in his service, in his in all way. He take so much time here because situation not permits us to speak him about a lot in this situation. So I hello.
You are audible, sir. You are audible, sir.
चला हा. तर या प्रसंगी जास्त वेळ न घेता थोडक्यामध्ये मी त्यांच्याबद्दल दोन शब्द बोलतो. सर आणि मी एकाच कॉलेजचं प्रॉडक्ट आहोत. माझ्यापेक्षा 10 महिन्यांनी सर ज्युनियर असतील. 10 महिन्यांनी ज्युनियर आहे, कारण की माझं रिटायरमेंट मागच्याच वर्षी 2020 ला नोव्हेंबर मध्ये झालं आणि त्याच्यानंतर एक्झॅक्टली 10 महिन्यांनी सप्टेंबर 21 ला कथोरे सरांचं रिटायरमेंट होत आहे. स्टुडंट लाईफ मध्ये आम्ही सोबत असताना फारसा परिचय आमचा कधीच नव्हता. पण ज्यावेळेस आढळून सोबत आम्ही जेव्हा दौरे करायचे अमरावती युनिव्हर्सिटीमध्ये, आणि मग त्या दौऱ्यामध्ये आम्ही आमचा एक गाडी काढायची आणि 5-6 लोक त्यामध्ये बसून आम्ही ज्यावेळेस फिरत होतो अमरावती युनिव्हर्सिटीमध्ये, एक आमची संघटना चांगल्या तऱ्हेने मजबूत व्हावी या दृष्टीने. त्यावेळेस पहिल्यांदा वाशिमला जेव्हा आम्ही गेलो आणि माझी ती पहिलीच भेट होती त्या वाशिमला जाण्याची, आणि तिथे गेल्यानंतर आमचं ज्या पद्धतीने स्वागत कथोरे सरांनी तिथे केलं, त्यावरूनच माझं असं लक्षात आलं की या माणसामध्ये काहीतरी एक विशेष गुण आहे. आणि कारण आम्ही कधीच या बाबतीमध्ये गुलगुच्छ देऊन किंवा म्हणजे काही आणून स्वागत असं करण्याचा काही आम्ही प्रयत्न केला नव्हता. पण पहिल्यांदा वाशिमला मला वाटतं ही गोष्ट बरेच वर्षापूर्वीची गोष्ट आहे. त्यावेळेस अमरावती युनिव्हर्सिटी जॉईन केलं होतं त्या काळात, आणि तेव्हापासून मग आम्ही सतत संपर्कामध्ये आहोत. त्या सरांच्या बद्दल सांगायचं म्हटलं म्हणजे मेहरे सरांचे एक मला एक प्रसंग आठवतो. मेहरे सर इथे असताना, आता मेहरे सर म्हणजे आमच्या या फॅमिलीमध्ये खूप चांगले सद्गुरुस्थ होते. ते आता आपल्यात नाही आहेत, पण त्यांनी एक आठवण त्यांच्याबद्दल नेहमी सांगितली आणि ती माझ्या आजही स्मरणात आहे. कारण आम्ही सर्वजण एकमेकाला ओळखत होतो नावाने, पण चेहऱ्याने कधीच ओळखत होतो. कारण नाव काय बोलतो पटवारी सर कुठे काम करतात. मेहरे सर एकदा अडिगलला युनिव्हर्सिटीमध्ये लिटरेचर कोर्स करण्याकरता गेले होते, आणि त्या लिस्टमध्ये त्यांच्या असं लक्षात आलं की कथोरे नावाची व्यक्ती आहे म्हणजे लिटरेचर कोर्स अटेंड करणारी. तिथे गेल्या त्यांनी एकच काम केलं. ते काम असं केलं की तिथे रूमचं जेव्हा अलॉटमेंट झालं, त्या रूमच्या अलॉटमेंट मध्ये मेहरे सरांनी तिथे आग्रह धरला की मला रूममेट म्हणून कथोरे सरच पाहिजे, येणार आहे ती व्यक्ती. आणि त्यावेळेस मेहरे सर त्यांना ओळखत नव्हते. नाव ऐकलं की कथोरे आहेत आपल्यापैकी आहेत आणि वाशिमला आरे कॉलेजला जॉब करतात म्हणून. तर असा तो प्रसंग त्यावेळेस काळामध्ये होता. आणि हे असे एक चांगले म्हणजे स्वभाव असणारे आणि एकच इंटरेस्ट असणारे लोक जेव्हा आम्ही एकत्र आलो आणि मग पुढे ही संघटना आम्ही चांगल्या तऱ्हेनं अमरावती विद्यापीठामध्ये चांगल्या तऱ्हेनं म्हणजे राबवली आणि या मॅथमॅटिक्स ग्रुप खास असं म्हणजे गोष्ट अशी सांगावीशी वाटते की कमी राजकारण किंवा राजकारण शून्य म्हणजे कोणताही भेदभाव नाही किंवा काही मतभेद असतील तरी ते म्हणजे आपला एकमेकाशी बोलून हे करून ते करून आम्ही ते मिळून वगैरे या संघटनेमध्ये कधीच झालं. त्यामुळे आज सर्व सदस्य या संघटनेशी जोडलेले आहेत आणि त्याच पद्धतीने पुढे कार्य करतील ही मला पूर्ण खात्री आहे. कतोरे सर आणि माझ्याबद्दल बरंच साम्य आहे. माझंही एसके आहे, त्यांचं एस फॉर शिवदास, एस फॉर शरद, के फॉर कतोरे, के फॉर कांडलकर. त्यांनाही 2 मुलं आहेत, मलाही 2 मुलं आहेत. त्यांची दोन्ही मुली इंजिनियर झाल्या, माझी दोन्ही मुली इंजिनियर झाल्या. आणि विशेष म्हणजे त्यांच्या बहिणी एस पासून सुरू होतात आणि माझ्या मिसेसचं नाव सुद्धा एस पासून. त्याच्यामुळे बरेचसे साम्य त्यांच्यामध्ये आहे आणि त्यांची सर्व्हिस 36 इयर्स झाली, माझी सुद्धा सर्व्हिस 36 इयर्स झाली. मी 84 पासून माझं करिअर सुरुवात केलं, सरांनी 83 पासून करिअर सुरुवात केलं आणि खूप प्रामाणिक आणि कामामध्ये झुकून देणारा व्यक्ती म्हणजे कतोरे सरांचा आहे. त्यांचा मदर एकच म्हणजे एक सारखा आणि तोच दोष सुद्धा आहे की आमच्या दोघांमध्ये आणि आम्ही अतिशय प्रामाणिकपणाने या फील्डमध्ये काम केलं. 1985 1984 पासून जेव्हा आम्ही या सेवेला सुरुवात केली त्या कॉलेजमधून आम्ही शिकलो. त्या कॉलेजमध्ये एक असं कल्चर स्टॉलवर आम्हाला शिकवण्यात येतं. त्यांचा आदर्श आमच्या समोर होता. त्यामध्ये बॅनर्जी सर होते, कोरडे सर होते, आपल्या देशपांडे मॅडम होत्या, नागावकर सर होते, पराडे सर होते, हिरुडकर सर होते. या लोकांनी आम्हाला जेव्हा शिकवलं त्यांच्या टीचिंगचा जो प्रभाव आमच्यावरती होता तोच प्रभाव आमच्यामध्ये आम्ही जेव्हा या प्रोफेशन मध्ये आलो तोच आमच्यामध्ये होता. आमची पहिली प्रायोरिटी होती आमची टीम. आम्ही जास्तीत जास्त आमचं नॉलेज कॉर्पोरेट करण्याचा प्रयत्न विद्यार्थ्यांना केला आणि हे आमचं कर्तव्य जवळपास 2002 पर्यंत चांगल्या तऱ्हेने चाललं. कारण तोपर्यंत रिसर्च काय असतो आम्हाला जास्त माहिती नव्हतं. आमच्यामध्ये सर्वात पहिले रिसर्च करणारे व्यक्ती होती डॉक्टर अडव सर. त्याआधी डॉक्टर तुझे मॅडम होत्या, त्याही आता सेवानिवृत्त झाल्या, पण ते करायचे आणि त्यानंतर तो रिसर्च पुढे मोठ्या प्रमाणामध्ये त्याचा काही म्हणजे आहे त्या तो थांबलेला होता. आणि मग ज्यावेळेस सरांनी युनिव्हर्सिटी जॉईन केलं आणि युनिव्हर्सिटी जॉईन केल्यानंतर देशमुख सरांचं नाव घ्यावंच पाहिजे, कारण की देशमुख सर होते आमच्या डिपार्टमेंटला. डॉक्टर ए जी देशमुख ते माजी सहसंचालक सुद्धा होते. त्यांनी सुद्धा या रिसर्च मध्ये चांगल्या तऱ्हेनं काम केलं. आणि अडव सर, रिसर्च गुर्दे मॅडम, देशमुख सर यांच्या माध्यमातून आम्हाला आमचे जे म्हणजे खरे मार्गदर्शक म्हणजे डॉक्टर करडे सर यांची प्रेरणा घेऊन आम्ही जेव्हा रिसर्च चालू केला तर तेव्हा या भागामध्ये अमरावती विद्यापीठामध्ये फार मोठ्या प्रमाणामध्ये रिसर्च आम्ही चांगल्या तऱ्हेनं करण्याचा प्रयत्न केला. आमचे ज्यावेळेस सुरुवातीला पेपर इंटरनॅशनल जर्नल्स मध्ये प्रसिद्ध व्हायचे त्यावेळेस आम्हाला एक चांगलं भूषण वाटायचं की आपला पेपर इंटरनॅशनल जर्नलला पब्लिश होतोय. म्हणजे ते एक क्रिएटेबल होतं आमच्याकरता की कुठेच आम्हाला रिसर्चचा गंध नसताना ज्यावेळेस आम्ही ऑनेस्टली या मेहनत घेऊन जेव्हा काम करायला लागलो आणि आमचे पेपर इंटरनॅशनल जर्नलला पब्लिश झाले तर एक म्हणजे आमच्याकरता खूप चांगली एक गोष्ट ती त्यावेळेस घडत होती. आणि आम्ही मनाशी असं ठरवलं होतं की आपण रिसर्च करायचा, याच्या पुढे तो ऑनेस्टली रिसर्च करायचा. की म्हणजे जास्तीत कमी विद्यार्थी आपल्याकडनं प्रोड्यूस झाले तरीच चालतील, परंतु जे काही आपण विद्यार्थी प्रोड्यूस करू ते चांगल्या दर्जाचे आणि त्यांनी पुढे जाऊन तो कंटिन्यू केला पाहिजे रिसर्च, हाच आमचा प्रयत्न राहिला. आम्ही कधीही त्याच्याशी तिथे कॉम्प्रोमाइज केलं नाही. तर याच आम्ही म्हणजे विचारधारेतून तयार झालेले लोक आहोत. त्या कटोळे सर इथे विद्यापीठामध्ये वेगवेगळ्या
म्हणजे प्राधिकरणावरती काम केलेलं आहे, अतिशय चांगलं काम केलेलं आहे. त्यांचे कौतुक करणारे बरेच लोक मला दिसतात की कतोरे सर त्यांच्याकडे दिलेलं काम कोणतेही चांगल्या तऱ्हेने करतात, पार पाडतात. आणि ते एक आमच्याकरता अभिमानाची गोष्ट आहे की एक चला आपल्यात कोणतरी मनुष्य चांगल्या तऱ्हेने काम करतो आहे. आणि आज ते सेवानिवृत्त होत आहे, 2 दिवस बाकी आहे आणि कालच त्यांना सिनियर प्रोफेसर म्हणून त्यांचं प्रमोशन झालेलं आहे. तर हे सिनियर प्रोफेसर म्हणून प्रमोशन झाल्याचं त्यांचं जे आहे खरंच ते म्हणजे कौतुकास्पद गोष्ट आहे. कारण की सिनियर प्रोफेसर आपल्या याच्यातून बहुतेक अजून कोणी झालेलं नाहीये आपल्या या फॅमिलीमधून. तर ते पहिले व्यक्तिमत्व आहे की त्यांना सिनियर प्रोफेसर म्हणून या ठिकाणी विद्यापीठाने त्यांची म्हणजे निवड केलेली आहे कॅशच्या मार्फत. तर त्यांच्याकरता मी स्वतः आणि या फॅमिलीचे सर्व मेंबर फॅमिलीतर्फे त्यांचं अभिनंदन करतो. आणि त्यांना या सेवानिवृत्तीनंतरचं जे त्यांचं जे लाईफ आहे, आयुष्य आहे, ते अतिशय चांगल्या तऱ्हेने जावं, सुख समृद्धी समाधानाचं चांगल्या आरोग्याचं जावं असं मी या ठिकाणी म्हणजे या ठिकाणी माझं मत व्यक्त करतो. त्यांना शुभेच्छा देतो त्या पद्धतीने. त्याच पद्धतीने आमच्या वहिनी ज्या आहेत त्यांना आता रिटायर झाल्यानंतर चांगली साथ मिळेल. कारण आता रिटायर झाल्यानंतर सर घरीच राहणार आहे. त्यामुळे जो माणूस कधीही म्हणजे घरी न राहिलेला आहे आणि शेवटी पूर्णपणे आपलं स्वतः करून टाकलं होतं डिपार्टमेंटला, सकाळी उठून संध्याकाळी केव्हा तरी यायचं परत, ते आता तसं राहणार नाही. त्यामुळे त्यांना जास्तीत जास्त त्यांना सहन करायचं आहे. तर त्यांना मी इथे विनंती करतो की त्यांनी ते समजून घेतील. आणि त्यांना त्यांच्या मुलाबाळांना सर्व कुटुंबांना शुभेच्छा देऊन मी माझे 2 शब्द ऑर्गनायझरला धन्यवाद देऊन संपतो.
Thank you so much, sir. Thank you so much. Now, Dr. G.S. Khadek, Professor, Department of Mathematics, RTM University, Nagpur University, Nagpur, to express his experience about Professor S.D. Khatore, sir. Dr. G.S. Khadek. I think sir has left. Now I would like to request Dr. B. Mishra, sir, Professor, Department of Mathematics, BITS Pilani, Hyderabad, to express his views.
Thank you very much. In the morning, I have left in a hurry. As I have told, I have different commitment. And my association with Professor Khatore, it's since my student time when I was a PhD student of Professor Ganeshwar Mahanti at Sambalpur University. And we often met either at Amravati or at Nagpur during these scientific events. So initially I was going to these places as a student with my supervisor, and we have maintained that relationship. So since last 20 years, I am a regular visitor of these two universities, the Nagpur University and the Amravati University. Now, starting from a student time to now, I have several good times spent with Professor Khatore and his team. So my observation, though I am very much junior to him, but still the legacy they put in by Professor Karade, Professor Reddy, Professor Mohanty, as well as Professor Shriram, the North, South, East and West, all these 4 pillars of relativity, Professor Khatore was successfully taken that legacy to the next level. Of course, I do not wish to miss Professor Adhav in between, who has also played a major role in taking this relativity cosmology in the domain of mathematics. Because you all know there is always a fight between the physicists and the mathematicians who own this relativity and cosmology. And I think that legacy is well taken to the next level by Professor Khatore. In several occasions, we had some discussions, like it will be academic discussions, it will be some personal discussions also. And it was a nice experience to spend some quality time with him. He's a very simple man, and I always admire his, his attire. So whenever I saw him in the department or so, he's always well dressed. So just look like a professor in a university. So that was the sum of the, at that time. Nowadays the situation might have changed, but at that time it was the identity. A professor should come well dressed, a teacher should come well dressed, and he has completely followed that ideology to be in well dressed always whenever I have seen him. And coming to the research part, yes, he has done not only the research for him, but also he has delivered research to others. So research will always grow if the idea has been disseminated. He has successfully done that, nurture young minds, pass on the research so that others can take it forward. So whatever the legacy he has now left behind in the department or in the domain of relativity and cosmology, I am quite confident that the next generation will certainly take it up. And in lighter sense, just I was listening the discussion from the beginning, Professor Reddy told that no, Katori, you have become old, this thing, that thing. But let me to point out that here, post-retirement, our professors become more younger. Then their age is not increasing, rather their age is decreasing. Look, Professor Reddy, Professor Adhav, they don't look like an old man. They are still young. So I must pray God for his good health and a path ahead. He has 2 young sons. So I hope his family life should be peace and maintain a dignified life. Being a teacher, maintain a dignified life throughout his career and will continue to do so. So I must wish Professor Kature, Madam Sandhya, his 2 sons to be live in peace, harmony among the family. Thank you very much, and thank you the organizer for giving me an opportunity in this auspicious occasion to share my views with Professor Kature. Thank you.
Thank you, sir. Thank you so much. Now I would like to request Dr. G.S. Khadekar, sir. Khadekar sir have joined. I request Dr. G.S. Khadekar, sir, to explain. Sir is not there again. Next,
No, I am audible. I'm audible. I am audible now.
Yes, sir. Yes. Yes, sir.
Okay. Thank you.
Yes, sir. Yes, sir. Yes, sir.
Hello. Okay. Hello. Hello. Now I am audible now. Okay. So today, good afternoon, everybody. I am Dr. Khadekar. I am audible, please.
Yes,
yeah.
Sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
So today's chairman for this function, Dr. K. Sarao, and our mentors, Professor Reddy sir, Dr. Kalde sir, and today's big personality that we are going to retire to after 2 days, Dr. S.D. Kature sir, and all the participants. There are 90 to 100 participants are joined here, and all my fellow colleagues, my friends from Hyderabad, Dr. Mishra, Dr. Sahu sir is also, Solanki, Professor Solanki sir, all my fellows, all colleagues. Today is a very, so I don't have the word to say what about the Professor Kature sir. So there are a lot of things in my mind, but due to some time constraint, I will say some few things about our colleague, our big brother, Dr. S.D. Kature. I know Dr. S.D. Kature from long time, that is since 1995, when first time I was become the member of the Board of Studies in Amravati University. Dr. Adao gave me the chance first time when I was in engineering college. The first times I know that how is the board of studies, that is the beginning from the Dr. Adao sir, is give me the chance to become the member of the board of studies. So from that day, I know Dr. Katore, how is that person's, what is the simplicity of this person's, what is the contributions toward the university of this person, what is a man, that is the very important things, and how the man will be settled each and every problem very nicely and very smoothly. This is the biggest nature or good natures of Dr. Katore. And that's why Dr. Reddy told that he is not a simple man, he is the guru of Dr. Reddy. My dear friends, my colleagues, my senior mentors also here. Today, जे काही मला बोलायचं आहे, that will be my feelings will be very different about Dr. Katore. Dr. Katore is a man. He is. I know Dr. Katore from Nagpur University also. He joined PhD program to the Department of Mathematics. At that time, I was a reader in the Department of Mathematics. How is doing the work? How is hard worker? And how to publish the paper and what is the motivations behind our all the groups. Dr. Karde is there, and only because of Dr. Karde sir, we are on this platform now. मला तुम्हाला बरेच लोकांना सांगायची एक इच्छा अशी आहे की मी आज एका कमिटीवर काम करतोय. बरेचसे माझा बायोडेटा सकाळी वाचला तुम्ही, मला त्या बायोडेटाशी तेवढं लेनदेन नाही. मी एका कमिटीवर काम करतोय, ती रिसर्च कमिटी कॅश प्रमोशनची आहे. आम्हाला कर्डे सरांची का आठवण येते त्याबद्दल बोलतो आणि नंतर मी कटोरे सरांबद्दल बोलतो. कटोरे सरांनी कर्डे सरांना कसं म्हणजे ज्याला काय म्हणतात की चेले कसे असू शकतात त्याचं एक जिवंत उदाहरण, एक कालचं एक उदाहरण तुम्हाला देतो. आणि कर्डे सरांनी आम्हाला काय शिकवलं आणि आज ते आमच्या किती फायद्याचं आहे ते तुम्हाला सांगतो. मी कॅश कमिटीचा नागपूर विद्यापीठात, आय एम द चेअरमन ऑफ द कॅश कमिटी, प्रमोशन टू द टीचर फ्रॉम द व्हेरियस पोस्ट, from lecturer to reader, associate professor to professor, and all these things. And there is one things in very important things in the UGC regulation 2018. That important thing is that if you are going to promote the teacher from the various grader, then the very important thing is that the API score. And in the API score, we are going to show the authentic paper, good impact factor papers to the committee. And on the basis of that, you should promote. कर्डे सरांनी आम्हाला जे शिकवलं, आम्ही कधीही रिसर्च करताना आम्हाला फेक जर्नल काय असतात ही कल्पनाच माहित नव्हती. म्हणजे आम्ही ज्या एरियामध्ये काम करत होतो त्या एरियामध्ये फेक जर्नल्स असतात का ही कल्पनाही आमच्या डोक्यात नव्हती. आणि अशा माहोलमधून अशा वातावरणातून आम्ही पुढे गेलेलो आहोत. मित्र, कटोरे सरांचं जे कॉन्ट्रीब्युशन्स आहे, काल एक एक्सपर्ट आले होते, जाताना ते मला भेटले नागपूरला, कारण त्यांचं फ्लाईट नागपूरहून होतं. त्या माणसाशी ज्यावेळेस मी बोललो त्यावेळेस त्यांनी एका शब्दात मला समजून सांगितलं की सर, व्हॉट इज द कॉन्ट्रीब्युशन्स ऑफ डॉक्टर कटोरे. बऱ्याचशा लोकांनी उल्लेख केला इथे आता की डॉक्टर कटोरे सरांना सिनियर प्रोफेसर कार देण्यात आलं. तिथे एक क्वेश्चन विचारण्यात आला की व्हॉट इज द कॉन्ट्रीब्युशन्स ऑफ आफ्टर द रिटायरमेंट, वाय वी आर गोइंग टू गिव्ह द senior professorship to the Dr. Katore because he is going to retire after the 2 days. इथं इतकं सुंदर उत्तर त्या कमिटीच्या लोकांनी दिलं, कारण त्या लोकांनी माझ्याशी डिस्कस केलं, कारण त्यांच्याशी मी ती चर्चा करत होतो. जे नागपूरहून गेले एक्सपर्ट, ते मला भेटून गेले. त्यांनी सांगितलं की या माणसांनी 36 वर्षामध्ये जे काही त्यांचं कॉन्ट्रीब्युशन, त्यांचा एक्सपिरियन्स आहे, ते काम केलं, त्या कामाचा मोबदला त्यांना म्हणून आम्ही इथे देतोय. आणि त्यांचं कॉन्ट्रीब्युशन इतकं चांगलं आहे या एरियामध्ये, या अमरावती रिजन मध्ये, तिथे कॉन्ट्रीब्युशन्स पाहूनच एक्सपर्टनी सांगितलं की ह्यांचं हे कॉन्ट्रीब्युशन तुमच्या फ्युचरच्या कॉन्ट्रीब्युशन करता कामात येईल, फ्युचरच्या स्टुडंट करता कामात येईल. आणि म्हणून आम्ही या व्यक्तीला इथे एक्सपर्ट म्हणून घेतो, कारण की त्यांना क्वेश्चन करण्यात आलं की तुमचं 2 दिवसानंतर रिटायर्ड आहे आणि तुम्हाला सिनियर प्रोफेसर का द्यावं. तिथे एक्सपर्टने समजून सांगितलं की याच माणसाला तुम्ही सिनियर प्रोफेसर देऊ शकता बिकॉज देअर कॉन्ट्रीब्युशन इज व्हेरी इम्पॉर्टंट. आणि मी तुम्हाला एक सांगतो मित्र की या सरांनी जे कॉन्ट्रीब्युशन्स केलंय त्यांचं रिफ्लेक्शन त्या माणसांनी जेव्हा मला दिलं त्यावेळेस त्यांनी सांगितलं की सर बोले, इनका जब बायोडाटा मेरे पास आया तो मैंने उनके पेपर जब देखे तो मुझे ऐसा लगा कि इनके पेपर में कुछ भी प्रॉब्लम्स है. मैंने पूरे पेपर चेक किया. बोले यांचे सगळे पेपर, मॅक्सिमम पेपर हाय इम्पॅक्ट फॅक्टर जर्नल मध्ये. आम्हाला कर्डे सरांनी तेच शिकवलं होतं की तुम्ही पेपर पब्लिश करताना चांगल्या जर्नलमध्ये करा. त्याचा इम्पॅक्ट चांगला असायला पाहिजे, तुमच्या रिसर्चला व्हॅल्यू असायला पाहिजे, तुमचं रिसर्च कोणी वापरलं पाहिजे. आज एका एक्सपर्टने आमच्या समोर जेव्हा हे कमेंट्स केले त्यावेळेस मी धन्य झालो की असो, आम्हाला जी शिकवण मिळाली आणि त्याच्या पावलावर पाऊल ठेवून कटोरे सरांनी जे कॉन्ट्रीब्युशन्स या विद्यापीठाला दिलं ते मोलाचं आहे. मित्र, कटोरे सर एक साधारण सिंपल व्यक्ती आहे. बरेचशा वेळा माझ्यासोबत त्यांचं इंटरॅक्शन झालेलं आहे. बऱ्याचशा कॉन्फरन्समध्ये आम्ही सोबत काम केलेलं आहे. आम्ही अमरावतीच्या कॉन्फरन्समध्ये सोबत काम केलंय, त्यांनी माझ्या कॉन्फरन्समध्ये नागपूरला काम केलंय. कधी कधी मी हॅम्पर होऊन जातो, चिडायचं, पण कटोरे सर मध्ये क्वालिटी आहे. ती क्वालिटी तुम्हाला सांगतो, ती क्वालिटी अशी आहे या माणसामध्ये, ही इज अ व्हेरी नॉर्मल पर्सन अँड प्रत्येक गोष्टीला विचार करताना ते 4 वेळा विचार करून दुसरी गोष्ट सांगतात. आणि आपण जर चिडत असेल किंवा आपण जर रागात असेल तर आपल्याला शांत कसं करावं याचं खरं म्हणजे शिकण्यासारखं हे कटोरे सरांकडून आहे. कुठल्याही गोष्टीला काही मर्यादा असतात, परंतु त्या मर्यादेच्या पलीकडे वागणारा व्यक्ती आणि त्यांना समजून घेणारा व्यक्ती म्हणजे कटोरे सर आहे. कुठलंही काम असेल की सर हे होऊ शकत नाही, याला असं असे प्रॉब्लेम्स आहेत, परंतु नाही सर 2 वेळा 3 वेळा फोन करतील, समजून सांगते, नाही कडेकर सर हे आपण असं करू शकतो, पहा बरं तुम्ही समजून. आणि ते समजवण्याची जी त्यांची भूमिका आहे, शांततेत प्रत्येक गोष्ट ऐकून घेण्याची. पहिली गोष्ट तर ऐकून घेण्याची आणि दुसरी गोष्ट दुसऱ्याला समजून सांगण्याची. हा जो सरांचा स्वभाव आहे, दॅट इज द व्हेरी वॉर्म आणि व्हेरी इम्पॉर्टंट थिंग्स इन हिज नेचर. हे फार कमी लोकांच्या याच्यामध्ये मिळतात, ते आम्हाला लाभले आहेत. आणि यांचं जे कॉन्ट्रीब्युशन्स, मी अमरावतीच रिजनचा असल्यामुळे मला अमरावती रिजनच्या प्रत्येक डिस्ट्रिक्टचं माहिती आहे. प्रत्येक डिस्ट्रिक्टमध्ये आमचे मॅथमॅटिक्सचे लोक जिथे इथे आहेत ते माझ्याही कॉन्टॅक्टमध्ये असतात आणि त्यांच्यामुळे मला त्यांच्याकडून जो फीडबॅक येतो कटोरे सरांबद्दल, तेही सांगतात की नाही सर, डिपार्टमेंटला त्यांनी व्यवस्थित सुपुढं आणलेला आहे. अढाव सरांनी सोडून गेल्यानंतर अढाव सरांच्याच पावलावर पाऊल टाकून त्या व्यक्तीने आज डिपार्टमेंटला पुढे नेलेलं आहे. आणि आम्ही एक अशी चर्चा पण केलेली आहे, मी एक्झिस्टिंग व्हाईस चान्सलरला, आमचे जे आता जे व्हाईस चान्सलरला आहे त्यांच्याशी फोनवरच एक वेळा बोललोय, त्यांना शुभेच्छा दिल्या. त्यावेळेस त्यांना एकच सांगितलं की सर मी मॅथमॅटिक्सचा व्यक्ती आणि मी या विद्यापीठात आहे, पण तुमच्या इथे एक मॅथमॅटिक्सची व्यक्ती आहे, ते आमच्यासारखीच आहे आणि त्यांचं रिटायरमेंट आहे. विचार करा, डिपार्टमेंटमध्ये कोणी ना कोणीतरी राहायला पाहिजे. तुम्ही लवकरात लवकर एक तर फुल पोस्ट फिलअप करा आणि या डिपार्टमेंटला पुढे नेण्याचा प्रयत्न करा. त्यांनी सांगितलं मला की सर म्हणे आम्ही बिलकुल प्रयत्न करू. आणि मित्र, कटोरे सरांचं विद्यापीठाचं कॉन्ट्रीब्युशन, समाजातलं कॉन्ट्रीब्युशन, त्यांच्या सोशल स्वभावाचं कॉन्ट्रीब्युशन आणि त्यांनी केलेल्या प्रत्येक कामाचं कॉन्ट्रीब्युशन, हे त्यांच्याकरता खूप मोलाची वस्तू आहे आणि तेच त्यांनी यावेळेस करून दाखवलं आणि केलं आहे. त्यांनी या जर्नीमध्ये, त्यांचं रिटायरमेंट आहे, या जर्नीमध्ये बरेचसे चढ उतार बघितलेले आहेत. कारण ते वाशिम मधून आले होतात. वाशिम मधून आल्यानंतर ते अमरावतीत आले, अमरावतीतून पीएचडी करण्याकरता आमच्याकडे नागपूरला आले आणि पुन्हा अमरावतीला जॉईन झाली त्यांच्या पीएचडी प्रोग्राम नंतर. त्यावेळेस मला त्यांचा पूर्ण स्वभाव हा म्हणजे आमच्या म्हणजे ग्रुप मधला एक खूप चांगला व्यक्ती की ज्यांनी चांगलं कॉन्ट्रीब्युशन या विद्यापीठाला दिलेलं आहे. आणि मित्रो, अशी व्यक्ती आज आपल्याकडून 2 दिवसानंतर कांडलकर सरांनी सांगितलं. कांडलकर सर हे एक आमचे चांगले विद्यार्थी आहेत, तरी मला सिनियर असले तरी त्यांची पीएचडी नागपूरहूनच झालेली आहे. त्यांनी सांगितलं की 2 दिवसानंतर का होईना पण कटोरे सर रिटायर होणार आहे, परंतु माझी अशी इच्छा आहे की कटोरे सरांनी फ्युचरमध्ये जोपर्यंत नवीन कोणी येत नाही तोपर्यंत या विद्यापीठाची धुरा सांभाळावी, या डिपार्टमेंटला राहावं आणि स्वतःला रिटायर न करता रिसर्च मध्ये पुन्हा यावं. कारण की बऱ्याचशा कल्पना असतात रिटायरमेंट स्टेजला की आपण असं करू तसं करू, परंतु एक वेळा बाहेर निघाल्यानंतर त्या कल्पना सत्य होत नाहीत. आणि जर आपण रिसर्च मध्ये राहिलो तर त्याच्या बरेचसे फायदे होऊ शकतात. आणि आता न्यू एज्युकेशन पॉलिसीमध्ये बरेचसे स्कोप्स आहेत, बरेचशी स्पेस आहे आणि मॅथमॅटिक्सला खूप डिमांड आहे. त्याच्यामुळे आम्ही कटोरे सरांना तसंही सोडणार नाही आणि त्यांच्या सोबतच राहून त्यांना सोबत घेऊन राहूच, प्रश्नच नाही. आणि मित्र हो, आता खूप जास्त वेळ न घेता वहिनी पण आलेल्या. वहिनी, तुम्हाला पण आता सरांना आता घरी सांभाळायचं आहे आणि त्यांना एज्युकेशन मध्ये सुद्धा त्यांना आमच्या सोबत ठेवायचं आहे. म्हणजे त्यांचं रिसर्च, तुम्ही घरी आले म्हणून रिसर्च बंद करू नका, ही एक माझी आग्रहाची विनंती राहील तुम्हाला की की बाबा तुम्ही जेवण खावण झालं, आता थोडंसं आपलं अभ्यासाचं घ्या आणि रिसर्च करा. तेवढं जरी केलं तरी सरांचं कॉन्ट्रीब्युशन आमच्या स्टुडंट करता खूप फायद्याचं ठरेल. इतकंच बोलून आज सरांना मी रिटायरमेंटच्या शुभेच्छा देतो आणि माझे 2 शब्द इथंच थांबवतो. नमस्कार. So with this I conclude my talk. Thank you very much. सर रेड्डी सर, आपको समझा नहीं होगा, लेकिन कुछ भावना ऐसी होती है वो हमारे लैंग्वेज में अगर बता दिया तो वो अच्छा रहता है. आपने नहीं समझा, मैं आपको बाद में समझा दूंगा, बट दैट इज द थिंग्स दैट आई एम गोइंग टू एक्सप्रेस अबाउट डॉक्टर कटोरे सर. Thank you, sir. Thank you very much. And organizer team, I am very much thankful to give me this chance and say some things about Dr. Katore sir. So thank you all of you. Thank you.
Thank you so much for sharing your experience, sir. Now I would like to request Dr. P.K. Sahu, sir, Professor and Head Department of Mathematics, BITS Pilani, Hyderabad, to share his experience.
So good afternoon to all. So thanks for the organizers to giving this opportunity to speak about Professor Katore. So going back to 2001, 2001 March 1 to 5, March 1st to March 5th is the conference conducted by Professor Khadekar and Professor Adhau in Nagpur University for the superannuation of Professor Karade. And that was my first conference in my life, because I entered as a PhD student in 2000. And my first conference was in 2001, and that is in Nagpur. So I met Professor Katore in that conference. And the fortunate is I did my PhD in biometric theory, and Professor Katore and my both the presentations are in the same session. And I recall that Professor Katore presented the talk on biometric theory. So both of us are working in biometric theory in 2001. So we met from that day, because we both are presented the paper in the same room, in the same session. So from that day, I have an association with Professor Katore till today. And I never saw such a simple person, such a simple and humble person, Professor Katore. Every time we'll call, we'll discuss. So humble he is. So that is what the greatness of Professor Katore. And I'm a regular visitor to Amravati University and Nagpur University. So whenever we used to go Nagpur or Amravati, so if there is a conference or there is a meeting in Nagpur, Professor Katore will come with his car, and we used to meet there, even if in Amravati University also. So it is a very good association with Professor Katore last 20 years. So in this day, I will wish Professor Katore for a happy retirement life, and enjoy with your family, and wish you all the best, sir. So thank you, sir. Thank you, all of you.
Thank you so much, sir. Now I would like to request Dr. S.D. Tade, sir, ex-associate professor, Department of Mathematics, Jawaharlal Nehru College, Nagpur. Tade, sir.
Okay. Thank you, sir. Hello.
Yes, sir.
So, good afternoon to all. Honorable Professor Karade sir, Professor Reddy sir, Professor Adhau sir, and all my dear friends. It is a matter of great pleasure to express my happy feelings on the occasion of felicitation of my friend Professor Katore sir, who is retiring from university service by the end of September 2021. So I met Professor Katore more than 25 years ago as friends from our hometown. Since then, it has been a very warm and pleasant relationship. Since then, I know almost every person coming in his contact has become his well-wisher. His ability to keep his cool and composure even when confronted with adverse situation is a remarkable quality which very few people in the academic life possess. Professor Katore worked in various capacities in a large number of university bodies, not only on his own university, but also many other universities such as Nagpur University, Gondwana Universities, Nanded University, and more, where he has showed his sense of assessment and always aimed at achieving the best in the university system. Gentle in his manner, usually soft-spoken and easily accessible, he has been liked, admired, and respected by one and all, especially large number of his students and many of his friends like me. Ever smiling, attractive personality is loved by the students and his colleagues. Arriving at 60 years is a milestone in one's life, and I am sure Professor Katore can look back with satisfaction at what he has achieved. The community can look forward to benefiting further from his expertise and experience. I summarize the personality of Professor Katore by stating a devoted teacher, a dedicated researcher, and generous host and dependable friend. So, Professor Katore, you cannot retire from academic life, but you will only be regenerating to take up different types of activities for the service of society, which could not be done while in service because of the pressure of work. It is with great pleasure and admiration that I wish Professor Katore, Mrs. Sandhya Vaini, Dr. Mayur and Piyush a long, happy life and a very fine health to enable them to scale new peaks in all walks of your life successfully. Thank you. Thank you and congratulate Dr. Katore for becoming as a senior professor in Sant Gadge Baba Amravati University, Amravati. Thank you. Thank you very much.
Thank you so much, sir. With the permission of all the dignitaries, again, breaking the protocol, I think Professor Dr. T.M. Kurde sir have joined. So I request Dr. T.M. Kurde sir to please share his experience. Sir have just joined. I request. Hello.
Hello.
Yes, sir. Yes, sir.
Yes.
Okay. Honorable Chairperson of this today's event, Professor Kadhav, all the teachers of mathematics, Professor Katore, Mrs. Katore. Today you organize an event. The first part is the academic discussion on the various aspects of mathematics. This is the, I hope this is the not the last, the middle session where you are felicitating or giving a send-off to Professor Kathore. It is the dichotomy I feel in India. Teacher is retired. Teacher gets retirement after 60 years. He serves for 60 years. And he jumps into void. He works for 10 clock hours or 8 clock hours as per the rules. And the next day, he becomes zero. It's a very funny country, I say. If you go to abroad, if you see the other countries, teacher never gets retirement or superannuation. Because teacher is a teacher. And you know, this was our glory in India. If you read the past of our country, you will see the first instance is in Mahabharata, when there is a Mahabharata war between Pandava and Kauravas, and how the role of Arjuna, he was definitely a disciple of Lord Krishna. When Arjuna sees that his relatives are before him and he has to start fighting, killing, then he says, Krishna, nakangshe vijayam Krishna, nacha rajyam sukhani cha. Krishna, I don't need anything. Because the war, which is intended to fight between our brothers, this is for what? For the benefit of power, money. I don't need, I don't want. Nakangshe, I don't wish, I don't expect. But the moment he says this, the next he says, if you see that, Katham Vishmamam Sankhe Dronam cha Madhusudana. Krishna, you're my friend. You ask me to fight with Bhishmacharya, to fight with Dronacharya. So this is the tradition of a teacher and a student. And here I find this is an event where Kathore is retiring. In India, only teachers are retired, only servants are retired. No politician. What is the contribution of politician? Who builds the nation? Nation is built only and only by teachers. And here is the instance of Dr. Kathore. I have seen him as my student, MP scholar, PhD scholar. I don't remember whether I taught him mathematics and MSc. He possesses all the qualities of a good, excellent teacher, as well as a very obedient student. I have seen him as a very hardworking. As regard to his work, I think many of his friends has narrated the many things about him, about his research capabilities. Forget about the research capabilities. I know he is a man with firm conviction. And I hope that he will definitely, after his retiring means his superannuity means what? He is leaving the chair in the Department of Mathematics. But I am hopeful that he will continue his work, his dedication to the subject mathematics. Madam Kathore is responsible for bringing him to the, because I tell you, there is a saying in Marathi, की प्रत्येक काय ते एक सक्सेसफुल टीचरच्या मागं, व्यक्तीच्या मागं तिच्या एका पत्नीचा हात असतो. म्हणजे माणसाचे केस जर पांढरे होऊ द्यायचे नसेल तर बायको चांगली पाहिजे, म्हणजे असं म्हणतात लोक. तेव्हा मला असं वाटतं की प्राध्यापक कतोरेचे केस अजूनही, डोक्याचे केस अजूनही पांढरे झाले नाहीत, अजूनही काळे आहेत, आणि त्याला कारण म्हणजे त्यांच्या सौभाग्य होती. सो आय होप दॅट he will dedicate his future life for the service of mathematics. And being an experienced teacher, I hope all his students, past, present, and his friends will contribute to him in his efforts and success. I wish him great success, excellent health, and he will continue not as a professor of the head of Department of Mathematics, but a mentor of mathematics in the Vidarbha region. Thank you very much. I have to say many things, but this is not the occasion because there is a time constraint and I don't want to go over it. So once again, thank you for giving me an opportunity to speak about him. Thank you very much.
Thank you so much, sir, for your valuable words. Now I would like to request Dr. D.D. Pawar, sir, Professor and Director, School of Mathematical Sciences, SRTMNU, Nanded. Pawar, sir.
He's not there?
Pawar,
If the permission of the chair, can you allow me 2 minutes?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Can I say 2 sentences? Because बीच में हमने एक कविता लिखा है.
अच्छा, yes, sir.
बीच में हमने एक कविता लिखा है. क्या बताऊं शिवदास, क्या बताऊं शिवदास, मार दिया कोरोना बदमाश, हमको आने नहीं दिया आपके आसपास. क्या बताऊं शिवदास, मार दिया कोरोना बदमाश, हमको आने नहीं दिया आपके आसपास. पर क्या करें, तू तो है मेरे मन के पास. क्या करें, तू तो है मेरे मन के पास, आप तो है शिवदास. हमेशा शिवजी और सरस्वती को प्रार्थना करता हूँ, आपको रखे अपने चरण के पास. थैंक यू.
Very good.
Very nice, sir. Thank you so much. Thank you so much.
Sorry
Sir.
to interrupt.
Now I would like to request Dr. D.D. Pawar, sir.
अरे कविता भी आ गई इनको.
I think sir is not there. Now I would like to request Dr. S.B. Thul, sir, Principal, SFS Mahavidyalaya, Nagpur.
Sorry. Alfred, sir.
हाँ sir, हाँ sir.
Uday Thul, Professor Uday Thul from Institute of Science, Nagpur, not principal of SFS College. So please correct it.
Okay, sir. Sorry, sir. Sorry, sir.
Okay.
So over to Thul, sir. Yes.
Audible? Yes. Thank you. Respected Chairman of the function, Professor Vasantrao Ji, guest and inaugurator of the function, my guru, my inspiration, my source of energy, unlimitedly flowing stream of knowledge, Dr. T. Gardesar, dignitaries, distinguished guests, Dr. Reddy sir, Dr. Pawar sir, and all the dignitaries, Dr. Tade, Dr. Auchar, Dr. Basker, Dr. Mapari, Dr. Mete, and today's Satkar Murthy, my Dr. Katore sir and Sandhya Varengi. It's a privilege that I got this opportunity to express my views about Dr. Gandhi, sir. I describe him as a true disciple of Dr. Gandhi, sir. He started his work selflessly in a slow and steady manner.
Hello.
To you?
Nitin?
Am I audible to you?
Yes.
How is mother? Okay. He started his work selflessly in a slow and steady manner. He indulged himself in the dirty practice of university, but focused on academics only. Unlike Dr. Kardasar, he opened his doors for everyone, especially for rural areas people, and helped them out of the ways without any expectation. Hello. Am I audible, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay. He opened his doors for everyone, especially for rural people, rural area people, and helped them out of the ways without any expectations, even not a single cup of tea. As a person, he is loving, very caring, humble, and having very good understanding. As an academician, he is having most knowledge without any kind of pride. As an academician down to the earth, easily accessible. And as a disciple of Dr. Kardasar, I describe him as the race turtle. This is an exaggeration. All of you are well aware that. So, Dr. Katore, he is a real hero and a role model for people of Amravati region. He single-handedly successfully handled two big departments, Department of Mathematics and Department of Statistics of Amravati University. Guided many students, published number of research articles in national and international journals, actively participated in various conference, workshops, seminars, organized national, international conferences, and there are many more in his knowledge. His simplicity speaks the volume of his greatness. I salute such a high-profile personality, and I'm very much fortunate for having him as my friend, as one of my friends. On 30th September, by superannuation, he is going to retire from his services. I wish him very happy and healthy retired life. Sir, though you are retiring from your services, but don't let yourself to be retired from academic and academics attachment. I think now you will get more time as you will be freed from extra responsibilities. So continue your research work and enlighten upcoming new generations. My best wishes to both of you, and you, sir. I am very much grateful to the organizers for giving me this opportunity to express my views. Thank you. Thank you very much.
Thank you so much, sir. Now I would like to request Dr. P. Shiv Sarup, sir, Regional Director, IGNOU Nagpur. Dr. P. Shiv Sarup, sir.
Good evening. Good evening. I am delighted to be part of this function on the eve of superannuation of Professor Katore and Madam Katore. Professor Katore, I know him since several years, and we are associated, of course, as part of IGNOU activity. And I am very much happy to say that he is so committed to whatever activity he has undertaken, and he did extremely well and dedicated service to all the IGNOU students of Amravati region, and he helped a lot in students not to travel far distances, and he activated several programs in Amravati itself. And sir, we are very much happy on behalf of IGNOU. We wish you a very happy and pleasant post-superannuation life, and I am sure that an active mind has no retirement. You will be active even after this function also, and we will be happy to be associated with you throughout period. So nice, and I wish you all the best. Thank you very much for the organizers to give me this opportunity. So nice. Thank you.
Thank you so much, sir. Now I would like to request Dr. Ms. Chetna Kamlaskar, Madam, Assistant Professor, School of Science and Technology, YCMOU, Nasik.
Hello.
Yes, ma'am. Yes, ma'am.
उपस्थित मान्यवर, प्रथम मी थोडक्यात माझी ओळख करून देते. मी डॉक्टर चेतना कामळस्कर, असिस्टंट प्रोफेसर, स्कूल ऑफ सायन्स अँड टेक्नॉलॉजी, मुक्त विद्यापीठ नाशिक इथे कार्यरत आहे. माझी आणि सरांची ओळख मुक्त विद्यापीठामध्ये MSc मॅथमॅटिक्सचा सिलेबस तयार करण्यासाठी महाराष्ट्रातील वेगळ्या वेगळ्या विद्यापीठातून विषय तज्ज्ञांची प्रोग्राम ॲडवायझरी कमिटी तयार करताना झाली. MSc मॅथमॅटिक्सचा सिलेबस तयार करताना सरांचा मार्गदर्शनाचा, त्यांच्या एक्सपर्टाईजचा आम्हाला खूपच फायदा झाला. सरांच्या प्रदीर्घ अनुभवामुळे सिलेबस डिझाईन करतानाच विद्यार्थ्यांना नेट सेट एक्झामची पद्धत, म्हणजे एक्झामची तयारी सुद्धा कशी करून घेता येईल याचा विचारपूर्वक नियोजन करता आले. कटोरे सरांचं बुक्स डेव्हलपमेंट मध्ये सुद्धा खूप चांगलं मोलाचं योगदान आहे. सरांनी ऑथर म्हणून, कंटेंट एडिटर म्हणून मॅथमॅटिक्सचे बुक डेव्हलप केलेले आहे, आणि हे त्यांचं हे कार्य असंच पुढे चालू राहील यात काही शंका नाही. आणि मला सांगायलाही खूप आनंद वाटतो की यावर्षीपासून MSc मॅथमॅटिक्स प्रोग्रामला UGCची मान्यता मिळालेली आहे, आणि मुक्त विद्यापीठाने हा प्रोग्राम यावर्षीपासून लॉन्च केलेला आहे. सरांच्या कामातील उत्साह, डेडिकेशन आणि हार्डवर्क खरोखरच वाखण्याजोगं आहे. सरांनी जेव्हा मला 3-4 दिवसापूर्वी सांगितलं की मी आता 30 तारखेला रिटायर होणार आहे, तेव्हा त्यांच्या मला वयाचा अंदाज आला. आतापर्यंत मी अजून सरांना रिटायरमेंटला खूप वर्ष बाकी आहेत असं समजत होते. इतके वर्ष सरांनी नोकरी केल्यानंतर म्हणजे जवळजवळ आता कळालं की 36 वर्षापेक्षा सरांची सर्व्हिस जास्त झालेली आहे. मित्र आणि सहकाऱ्यांच्या सोबत आयुष्य घालवल्यानंतर या सेवानिवृत्तीच्या क्षणी प्रत्येकाला आपला संपूर्ण आयुष्याचा प्रवास डोळ्यासमोर येतच असतो. सर, तुम्ही तुमच्या टीचिंग प्रोफेशनल मध्ये एक स्वतःचा पॉवरफुल पोर्टफोलिओ तयार केलेला आहे, आणि तुमच्या यशाचे गमक मला एका शायरीतून नमूद करायची इच्छा होती इथे. मंजिल उन्हीं को मिलती है जिनके सपनों में जान होती है. मंजिल उन्हीं को मिलती है जिनके सपनों में जान होती है. पंख से कुछ नहीं होता, हौसलों से उड़ान होती है. पंख से कुछ नहीं होता, हौसलों से उड़ान होती है. सर, आता हे जे काही आज आपलं रिटायरमेंटचा दिवस आज आहे, पण तुम्हाला आता सिनियर प्रोफेसर म्हणून पण बढती मिळालेली आहे. म्हणून मी फक्त एकच नमूद करते आजच्या या दिवशी, आयुष्याच्या प्रत्येक वर्णावर तुमच्या आयुष्यात आनंद यावा. या पुढचा प्रवासही असाच हसरा आनंद देणारा व्हावा हीच अपेक्षा. आणि वायसेमी तर्फे माझ्या सर्व कलिगांतर्फे आपल्याला ह्या सेवानिवृत्तीच्या हार्दिक शुभेच्छा. थँक्यू सर. आणि आय ऑलवेज थँक टू ऑर्गनायझिंग टीम ऑल्सो फॉर गिव्हिंग मी चान्स टू स्पीक 2 words अबाउट द सर. थँक्यू सर.
Thank you so much, ma'am. Now, I would like to request Mr. Siddesh Gujar Hire, Section Engineer, Central Railway, Pune Division, Pune, to express his views.
Hello, everyone. Am I audible?
Yes, sir. Yes, sir.
Okay. So, hello all. I am Siddesh Gujar. First of all, I am thankful to coordinator who allowed me to talk here, though there is a lack of time, and I will not take much time as I had texted your coordinator. Dear respected Katore sir and madam, I am glad for you being part of my life from my childhood. Guru Kumhara Shishu Kumbh hai, gadi gadi kaadhe khot, antar haath sahaya de, bahar bahe chot. Yes, it happens many times with me. Not many times, but moreover, I can say every time. Your words were seems so harsh and strict to me. But sir, all the scenario just changed when I started to realize that it's the only thing that's shaping my future. And now, at the same time, I feel glad for myself that I trust you always, whatever the conditions were. And sir, I will. At this time, I remember a line from Marathi drama in which Lord Krishna said to Karna that तुम्ही म्हणजे या धरेवरचे दीपस्तंभ, तुमच्या प्रकाशात आम्हाला आमच्या वाटा सापडतात. Yes, sir. You are lighthouse for us who enlighten the correct path of many of passengers like me. Here, point to note is if lighthouse is showing a path to generate the light, the tower has to endure a large energy in it. Finally, a big thank you from all of us to both of you, and also from them who couldn't join us today. Actually, it's a small word, sir. It's not enough. So today, I promise you, I will continue my work, and that one day, on beautiful morning, you will feel like I'm proud of you for me, sir. Enjoy the second inning of life, sir. Thank you.
Thank you so much. Now I would like to request Dr. G.R. Avchar sir, Head Department of Mathematics, Shivaji Science College, Nagpur.
Am I audible?
Yes, sir. Yes, sir.
Respected chairperson, respected Professor Karde sir, Professor Reddy sir, Professor Adau sir, Professor Misra sir, Professor Pawar sir, Professor Salunke sir, Professor Sau sir, Professor Khadekar sir, and Professor Katore sir, Mrs. Katore, and all other dignitaries who gather here through online platform for felicitation programs of Professor Katore sir on the occasion of superannuations. Simplicity and positivity are the two major things which I have seen in Professor Kature sir and which brighten his personality in teaching and research field. I first met him while we went to Calcutta for international conference. You all know that he is the PhD student of Professor Karde sir. And you also know the peoples who work under the guidance of Professor Karde sir, how they are. They are disciplined, confident, honest, and energetic in the research field. For success in life, in every field, many hands of blessing on head are essential. Professor Kature sir is very lucky in the sense that such a hands of blessing of Professor Karde sir, Professor Rao sir, will always be ready for blessing Professor Karde sir, Professor Kature sir. I remember the day when he had resigned from his previous assignment at Washim and joined the Department of Mathematics, JJB Amravati University. At that time, I also remember how Professor Rao sir, Professor Karde sir, including Professor Salunke sir, back him at all time. Under the guidance of Professor Rao sir, he had made a lot of contributions toward research in the subjects and towards the departments of mathematics, JJB Amravati University. I have also taken a lot of guidance from him in research, as well as when I had conducted the International Conference on Mathematical Science in 2012. I am lucky that I got his guidance. On this occasion, I express my best wishes for his happy, prosperous, and great healthy life in future. I am also thankful to the organizer giving me this opportunity to express my best wishes. Thank you.
Okay, sir. Now I would like to request our principal, Dr. S.V. Agarkar, sir, to express his views.
सर 2 मिनट लगेंगे
हेलो 2 मिनट लगेंगे बोलते
सर 2 मिनट
ओके ओके
हेलो ये लास्ट राइट बोल
हेलो Indira, sir, are you there?
हाँ सर बस 2 मिनट लगेंगे सर या फिर आप कोई और लीजिए अभी
ओके 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 नाउ the most important part or the aspect in the life of Dr. Rathi Katore sir.
Hello sir.
Hello.
हाँ sir. आ गए.
Okay. Over to Agarkar sir.
बोला sir.
Hello.
Yes sir.
Good afternoon. Hello.
Yes sir, you are audible sir. Yes sir.
Yes. I welcome all the dignitaries and delegates in the special session of felicitation of Honorable Professor Katore sir. Since many years I am associated with him. One specialty I have observed in his association is that he is highly devoted for development of faculty members and students of rural area. As my colleague Professor Phul has rightly pointed out, and I expect same cooperation and guidance in future to come. On the behalf of our organization and my colleagues, I express best wishes and good health in post-retirement life, Professor Katore. Thank you.
Thank you so much, sir. Now I would like to request Dr. Mayur Katore to express his experience throughout his life regarding his father. Over to Dr. Mayur Katore.
Hello. Am I audible?
Yes.
Yes. So good afternoon, everyone. So before expressing my manogat here, this I couldn't begin without taking name of few people that are associated with my father. First and foremost, his father, my grandfather, Devman Rao Katore, who is the reason of his strong character, and my grandmother, that is Devika Bai Katore, whose Mayadu nature is everyone that appreciates in my father. These are the two people who are behind all the qualities that my father possesses. And also the excellence that he has achieved in his career could also be credited to all the personality you can see hanging behind him. कि अगर आप उनके पीछे देखोगे तो जो जिनके सानिध्य में वो रहते वो और डॉक्टर कर्डे सर, डॉक्टर अडाउ सर, डॉक्टर रेड्डी सर, and many such all excellent expert colleagues of my father. So I will just start. Give me a second. So first of all, this is such an overwhelming and emotional moment for my whole family, as well as our extended families, including friends, students, and colleagues who know my father closely. I have seen many people retiring throughout my life because of the career that my father has. So many people has retired before me, but it was just in these few recent days that I actually understood the meaning of retirement and what it actually feels like. So after realizing that my father is about to retire, I got the meaning of what does the retirement mean. And it hit me very hard, because when I remembered his memories from my childhood, कि जब बचपन में जब भी मैं उनको देखता था, he has always been surrounded by students and mathematics. And when I look back to him when I was a teenager, he has been surrounded by students and mathematics. And now as an adult, whenever I see him, he is surrounded by students and mathematics. So that is all the memory that I have of my father. And though I was not his official student, but I guess all of you know, and all of you may agree, that once a teacher will always be a teacher. सिखाते ही रहते. So more than his son, I was also his student all my life, and I hope not, but would be stuck for all my life ahead also. Anyways, apart from that one of the great lessons I have learned from him is dedication, which everybody has expressed their views also. He has literally dedicated his whole life to mathematics and in the service of student. I still clearly remember many students of my father and the incidents that how my father has impacted their lives. He has always kept his student first, and it may be because he was also from the humble background, so he has the realization. So being from the humble background, a farmer's son who have earned his place not only in designation of his career but also in the heart of students. Papa, for me you are the true symbol of the power of education. Being a teacher myself, I hope I speak for everyone that we were damn lucky and blessed to be your students, which goes a mile further for me being your son. Greatest quality of yours that I admire and that everybody admires is the kindness. You are the most kindest person I know, and I am not being biased here because अगर आप उनको देखोगे तो कभी भी कोई अगर इंटरेक्शन होता है, फॉर एग्जाम्पल वो दुकान में कुछ खरीदने भी जाते हैं, तो he always live by saying धन्यवाद or thank you to that person. Sometimes looking at my own self, I realize how well you have raised me. Lastly, I would just say, as now your service is about to end, I wish you fulfill all your remaining wishes and give yourself more time now. Because जितना भी टाइम यूनिवर्सिटी में पापा जब से लगे 8 बजे से पहले घर पे तो कभी आए नहीं है. So I hope that you now give yourself more time, my mother more time, and to us more time, and to most importantly to yourself more time. And one wish that I have is that, and I hope I speak for everyone, that the most beautiful and blissful and peaceful smile never leave your face. And it is a reason for a smile and happiness for so many of us. आमचे गुरु असल्याबद्दल, सगळ्यांसाठी आदर्श असल्याबद्दल, माझे वडील असल्याबद्दल, आमच्या आयुष्यात असल्याबद्दल धन्यवाद. Now this equation of your life is coming to end. So I wish you blessings in multiplication for the journey ahead, in squared relationship with my mom, and hope now we, your son, carry this chaotic equation of our family with the power of 4. But in that equation, don't be too much of a dependent variable. So that's how I can express my. It is very hard to speak about your father. Just try it once for yourself and then you will know. But this is a very, very emotional moment for all of us. Thank you. Thank you so much. And I love you, Papa. You are an inspiration for all of us. Thank you.
You are very
Thank you so
lucky
much.
that you got a chance to express about your father, but we did not get any chance like that.
Yes, sir. Yes, sir. I could feel that. Thank you, sir. But it's very hard also, na?
Of course, you said it is very hard. You try once, you said. That is why I told you. We
Yeah,
did
yeah,
not
yes,
get
sir.
any
Yes.
chance to try that way.
Yes. Thank you. Thank you. Thank you, sir.
Thank you. Thank you
Thank
so
you.
much. Thank you so much. Now
Thank
I
you
would
for
like.
everyone's presence. Thanks a lot for everyone's presence to each and every one of you. Thank you.
Thank you. Now I would like to request the dynamic personality in the life of our beloved Dr. S.D. Katore sir, Mrs. Sandhya Shivdas Katore ma'am, to express her experiences throughout her journey in regard with Katore sir. Over to you, ma'am.
इथनं बोलायचं का? सर्वप्रथम विद्येचे आराध्य दैवत सरस्वती माता व संत गाडगे बाबा यांना नमन करते. आजच्या या नॅशनल कॉन्फरन्सच्या निमित्ताने आयोजित सत्कार समारंभात सहभागी झालेले सर्व मान्यवर मंडळी, प्राध्यापक वृंद आणि संशोधक विद्यार्थी, आपण या अशा कोविडच्या परिस्थितीमध्ये सुद्धा सरांचा सत्कार सोहळा आयोजित केला, हे खरंच खूप कौतुकास्पद आणि अभिमानास्पद आहे. तुमच्या सरांबद्दलच्या भावना काय आहेत हे मला पूर्णपणे माहित आहे. ऑफलाईन कार्यक्रम घेता आला नाही याची सर्वांनाच खंत आहे, पण ही ऑनलाईनची कल्पना व त्याला मिळालेला उत्स्फूर्त प्रतिसाद खरोखर वाखाणण्याजोगा आहे. यातून तुमचे सरांविषयीचे प्रेम, आदर, आपुलकी किती आहे हे शब्दात वर्णन करू शकत नाही. सरांचा शैक्षणिक प्रवास जवळपास सर्वांनाच माहीत आहे. आरे कॉलेज वाशिम ते अमरावती विद्यापीठ, आम्ही कधीही विचार केला नव्हता की वाशिम सोडून इथे यावे लागेल. पण हे ऋणानुबंधच असतात की कधी, कुठे, कुणाशी जुळतील हे त्या परमेश्वरालाच ठाऊक असते. आमचे अमरावतीच्या लोकांशी ऋणानुबंध असतील, त्यामुळेच इथे येण्यासाठी काही घटना कारणीभूत ठरल्या. परंतु आमचे वाशिमचे प्रेम मात्र काही वेगळेच आहे. आणि योगायोग बघा, ही कॉन्फरन्स पण तेच कॉलेज आणि सरांच्या तैनातीत तयार झालेले शिष्य ज्या कॉलेजमध्ये कार्यरत आहेत ते राळेगावचे कॉलेज मिळून घेत आहे. एका गुरुसाठी हा केवढा मोठा सत्कार आहे. इथे मला एक गोष्ट अभिमानाने सांगावीशी वाटते की आरे कॉलेजचे प्राचार्य डॉक्टर संचेती सर हे सरांचे शिष्यच आहेत आणि मित्र पण आहे. व एक आपला शिष्य या पदावर असणे आणि त्याच्याकडून सत्कार होणे हे त्या गुरुसाठी सुद्धा किती अभिमानाची गोष्ट असते व ज्या शिष्यांसाठी सुद्धा ही अभिमानाची गोष्ट आहे. आणखी काय हवं असतं एका समाधानी आयुष्यासाठी? यापेक्षा मोठा सत्कार कोणता असू शकतो? ज्या गुरुचे शिष्य इतके पक्के तयार झाले, पण इतके पक्के तयार करण्यासाठी त्या गुरुला मात्र घरावर तुळशीपत्र ठेवावं लागतं, तेव्हाच तो गुरु इतके पक्के शिष्य तयार करू शकतो. सरांनी आपले तन, मन, धन यासाठी दिले, तेव्हा कुठे आज हे गणिताचं कुटुंब एकजुटीने उभं आपल्याला दिसून येते. आणि हे कुटुंब तयार करणारा सर्वात मोठा घटक म्हणजे डॉक्टर करडे सर. त्यांनी हे गणिताचं वर्तुळ तयार केलं. सरांनी आपल्या विषयालाच आपलं पॅशन बनवलं. सर नेहमी म्हणायचे की पॅशन म्हणजे काय, आणि मी नेहमी सांगायचे की पॅशन म्हणजे जो तुमचा विषय आहे गणिताचा, ज्याच्यासाठी तुम्ही दिवस रात्र देता, दिवस रात्र त्याचाच ध्यास करता, तासनतास त्यात रममाण होणे आणि गणितासाठी वेड होणे याला म्हणतात पॅशन. फरक इतकाच होता की सरांनी आपल्या विषयालाच पॅशन बनवलं. गणिताची जी तुमची चिन्ह आहे ती सरांनी स्वतःमध्ये भिनवली. म्हणजे प्लस, मायनस, मल्टिप्लाय आणि डिव्हायडेशन. सरांनी माणसांची बेरीज करणं शिकवली, रागाची वजाबाकी करणं शिकवली, प्रेमाचा गुणाकार करणं शिकवला आणि द्वेषाचा भागाकार करणं शिकवला. ही गणिताचे जे 4 चिन्ह आहेत ते प्रत्येकामध्ये असावं अशी त्यांची इच्छा आहे. आता हे गणिताचं बनवलेलं कुटुंब, हे जे तुमचं वर्तुळ आहे, याचा परीघ जो आहे तो दिवसेंदिवस वाढत चाललेला आहे. आणि या वर्तुळातून एक एक जण बाहेर पडत जरी चालला तरी सुद्धा त्यांचं मार्गदर्शन तुम्हाला लाभणारच आहे. तर आता हे जे गणिताचं तुमचं कुटुंब बनवलेलं आहे, याची आजपर्यंतची धुरा करडे सर, त्यानंतर अढाऊ सर, त्यानंतर कतोरे सर यांनी सांभाळली आणि ही धुरा आता तुम्हाला सांभाळायची आहे. तेव्हा या तिन्ही लोकांकडून त्यातल्या त्या डॉक्टर रेड्डी सर, त्यांच्याशी तुमचा फारसा संबंध आला नसेल, हे सगळे लोक आमच्या अगदी कुटुंबात, म्हणजे नुसतं गणित हा भाग माझ्यासाठी नव्हता, हे लोक पर्सनली माझ्यासाठी माझ्या मध्ये अटॅच होते. आमचं वेगळं कुटुंब होतं. करडे सर, अढाऊ सर, रेड्डी सर आणि आमचं असं वेगळं नातं होतं, एक वेगळं गणिताच्या पलीकडे काहीतरी. जसं आपण शब्दांच्या पलीकडे म्हणतो, भावनेच्या पलीकडे, तसं तुमच्या गणिताच्या पलीकडे वेगळं आमचं नातं आहे, आजही आहे आणि ते अबाधितच राहणार आहे. या लोकांकडून तुम्हाला काय शिकायचं हे तुम्ही तुमचं ठरवलं पाहिजे. आता यामधलं तुम्ही अगदी डेडिकेशन, माझं स्पष्ट म्हणणं आहे आजच्या काळामध्ये की हे लोक जेवढे डेडिकेट राहिले कुटुंबाला सोडून, तेवढं आजच्या याच्यामध्ये राहू शकत नाही. कारण परिवर्तन ही काळाची गरज आहे. जसा आपला अभ्यासाचा सिलेबस बदलतो, कारण ती काळाची गरज बनते, विद्यार्थ्यानुरूप आपण तो पॅटर्न तयार करतो, तसं आमची जी पिढी आहे पूर्वीची, त्या पिढीसारखी तुम्ही डेडिकेट राहू शकत नाही. आणि माझं म्हणणं आहे की ते राहूही नाही, कारण काळ बदलला, परिस्थिती बदलली. कोविडने आपल्याला शिकवलं की सगळ्यात महत्वाचं जर काय असेल या जगामध्ये ते म्हणजे आपलं कुटुंब. तरी सुद्धा कुटुंब तर सांभाळावं लागतंच. या लोकांनी पूर्ण तुळशीपत्र ठेवले घरावर, तेव्हा कुठे तुम्हाला तुमच्यासारखे शिष्य ते तयार करू शकले, तेव्हा कुठे त्यांचं इतकं सगळं नाव होऊ शकलं. पण माझं स्पष्ट म्हणणं असं आहे की तुम्ही या काळामध्ये, आजच्या बदलत्या जगामध्ये प्रत्येकच जण इतका काही धावपळीचं जीवन जगतोय आणि विभक्त कुटुंब पद्धती आहे. पूर्वीची एकत्रित कुटुंब पद्धती होती. आमच्याजवळ आमचे सासू सासरे होते. आमच्या लहान मुलांना काही पाहायचं असेल, काही झालं असेल तर घरी कर्ता पुरुष नसला तरी ते लोक लक्ष द्यायचे. पण आज विभक्त कुटुंब पद्धती आहे आणि या विभक्त कुटुंब पद्धतीमध्ये अर्थातच आपण दोघं आणि आपले मुलं, त्यामुळं तुम्ही यांच्या इतकं डेडिकेशन देणं शक्यच नाही आजच्या काळामध्ये आणि खरंच ते देऊही नाही इतकं. पण सर्वात पहिल्यांदा आपल्या कुटुंबाकडे लक्ष द्या आणि या लोकांमधून जे तुम्ही गुण घेतले की म्हणजे डेडिकेशन, पण त्याच्यानंतर माणसं कशी जुळवायची, त्याच्यानंतर संयम कसा ठेवायचा आणि मुख्य म्हणजे ज्या गोष्टीमुळे आपल्या समोर 2 वेळेस ताट वाढल्या जातं, त्या गोष्टी ती देवानी कसं आपल्याला याच्यामध्ये आणलं या प्रोफेशन मध्ये आणि त्याच्याकरता प्रामाणिक राहणं, हे जरी गुण तुम्ही घेतले या लोकांकडनं तरी सुद्धा ते सरांना सत्कार असं मी समजेन. आणि म्हणून ही जी सगळी या गणिताच्या कुटुंबाची ती धुरा आहे जी ह्या लोकांनी आजपर्यंत चालवली, तुम्ही लोक तेवढी नाही हे करू शकणार, पण तरी सुद्धा ह्या सगळ्या गुण घेऊन जरी तुम्ही सांभाळली तरी पुष्कळ आहे. तोच सरांचा सत्कार असं मी समजे. तर आता ही धुरा तुमच्याकडे सर सोपवत आहे आणि ती तुम्ही नक्कीच समर्थपणे पेलाल, कारण तुम्ही शेवटी त्यांचेच शिष्य आहे, त्यांच्याकडून तुम्ही घेतलेलंच आहे सगळं. आणि त्याच्यामुळे आमचा हा दोघांचाही पूर्ण विश्वास आहे की तुम्ही ती गणिताची जी ही धुरा आहे किंवा हे जे तुमचं सर्कल आहे गणिताचं, शून्य आणि सर्कल, हे जे तुमचे गणितामधले 2 भाग आहे, शून्य पूर्णपणे रिकामं राहतं, परंतु सर्कल हे पूर्णपणे भरलेलं राहतं. एक जण त्यातून गेला तरी 2 जण त्यामध्ये ऍड होणार आणि तुमच्या सर्कलाचा परीघ वाढणार. तर हे तुम्ही लोक अर्थातच सरांच्या तैनातीमध्ये तयार झालेले असल्यामुळे सरांना पूर्णपणे विश्वास आहे की तो तुम्ही अगदीच समर्थपणे पेला. त्याच्यामुळे ही धुरा सोपताना आम्हाला अत्यंत आनंद तर होतो आहेच, पण केव्हाही तुम्ही हाक द्या, आम्ही ओ देणार. आणि आम्ही केव्हाही तुम्हाला हाक मारू तर तुमच्याकडनं आम्ही ओची अपेक्षा ठेवतो आहे. सर्वात शेवटी 2च ओळी ज्या लिहिल्या, एवढं बोलायचं नव्हतं मला, पण शेवटी आपलं आपण मनोगत म्हणजे जे इतके वर्षात आपण कधी सांगत नाही ते आपण सांगण्याचं हाच एक हे असतो, भाग असतो. 2 ओळी लिहिल्या, त्यामध्ये सरांचा पूर्ण त्या 2 ओळीचं प्रत्येक शब्द न शब्द ऐका. त्या 2 ओळीमधूनच तुम्हाला सगळा हे जीवन प्रवास सरांचा दिसेल. जिसने कष्ट संकटों में सहे, जिसने कष्ट संकटों में सहे, उनका जीवन सुमन खिला, गौरव गंध उन्हें उतना ही अत्र तत्र सर्वत्र मिला, अत्र तत्र सर्वत्र मिला। धन्यवाद।
आप टीचर है ना?
जी जी सर।
आप टीचर हैं, टीचर बहुत अच्छे बोलते हैं। देयर इज डिफरेंस बिटवीन बहुत बोलते हैं, बहुत अच्छे बोलते हैं। ये तो बहुत अच्छे बोलते हैं। और पीयूष नहीं बोलते हैं क्या?
पीयूष सिर्फ थैंक यू बोल रहा है सर। सर आई वुड लाइक टू जस्ट एक्सप्लेन अ लिटिल बिट ऑफ दैट पार्ट कि उन्होंने जो बोला था माँ ने कि हमारा जो रिलेशन है वो बियॉन्ड वर्ड्स है, कि शब्दांच्या पलीकडे आपलं एक रिलेशन, हमारा जो रिलेशन है इट्स बियॉन्ड वर्ड्स. सो
thank you so much for your lovely words. Now I would like to request the man of the moment.
आपल्या सर्व आयोजकांचं मनापासून धन्यवाद.
समझा नहीं.
सर मैडम ने बोला है कि जो ऑर्गेनाइजर्स है उनके लिए थैंक यू.
अच्छा जी.
Now I would like to request the man of the moment, Professor S.D. Katore sir. Now I would like to add one thing, that is Senior Professor and Head, PG Department of Mathematics, Sant Gadge Baba, Amravati University, Amravati, to express his overall experience throughout his life. Please sir.
Thank you sir.
इनको रेस्पॉन्स बोलते हैं.
Respected chairperson and our mentor, Honorable Urke sir. Good afternoon to one and all. At the outset, my tribute to a complete human being and mentor of our nation, Sant Gadge Baba. I thanks to all for their blessing words. I thanks the organizer for presenting a Sanman Patra. The felicitation is in this national conference by the organizers and all the participants during this pandemic situation is to be appreciated by one and all. This felicitation is the felicitations of our mentors, Honorable Urke Sahib, Professor Karde sir, Professor Reddy sir, Professor Adao sir, Professor Jayan Sadunke sir, Professor A.G. Deshmukh sir, Professor Gurde madam, Professor C.L. Majan sir, and late Professor Mehere sir, and all those have inspired us, motivated or supported to develop mathematical culture, research culture in our region. For me, there is, for academic excellence, for my academic excellence, I have three Dev, that is Karde sir, Reddy sir, and Adao sir. Due to these three mainly personalities, I could achieve some of the academic excellence in this research area. Here we must note the contributions, cooperations of mathematics teachers and authorities of the universities, my own university, Sant Gadge Baba Amravati University, Rashtrasant Tukdoji Maharaj, Nagpur University, SRTM Nanded University, Kavitribai Chaudhary, North Maharashtra University, BHU, Bits Pilani, Andhra University, Yashwantrao Chauhan Mukta Vidyapit, IGNU, Gondwana University. All these universities contributed for the excellence in our region. I must thank the honorable management, teachers, principals of my parent institutes, that is RN Mahavidyalaya, Washim, for their kind cooperation during my academic development. Otherwise, I will not be here today. Here, I would like to let Ramkrishnaji Rathi, let Subhashji Rathi, and a inspiring personality, Rajeshji Somani. I must thanks the blessings of Professor T.M. Karde and family and Professor Adau sir and family for continuously inspiring and kind support as a family members. We can do something in a team because of my all research students and departmental students supported me. Lastly, the support of my family members, in particular, blessings of my parents, continuous support of my wife and my sons, Dr. Mayur and Piyush, and the mathematics teachers from our university is the main source to develop today's mathematical academic culture, which was the dream of my guru, Honorable Professor T.M. Karde sir. I thanks the organizer, especially Principal Agarkar sir, Principal Sancheti sir, for their efforts and organizing this event on my superannuation. Special thanks to Dr. Alfred, Mr. Gore, Dr. Gore from RA College Washim and his team for their efforts for organizing this event. मी सर्वांना हात जोडून एक माफी मागत आहे की जर माझ्या या सेवा काळामध्ये कोणाचे माझ्याकडून अनावधानाने मन दुखावले गेले असेल किंवा काही नाराजी झाली असेल किंवा गैरसमज असतील तर त्यांनी कृपया आज मला मोठ्या अंतकरणाने माफ करावं. माझे मित्र संचेती सर आणि प्राचार्य आगरकर सरांचे मी I thanks to these personalities for encouraging the teams and collecting on a national platform to our mathematical family. Thanks to one and all. I again thanks to my best friend, Professor Mete sir from RDIK and KDK College, Badnera. He is continuously with me like a brother in whole mathematics, my service from 1985 to till today. He is also here and he is the backbone for any situations. He is the strength for me. We have our Bhausaheb Kale, Dr. Gugle madam, Dr. Kapse madam, Dr. Kandalkar sir and family, and many more are here. Dr. Agrawal madam, Dr. Nimkar sir, and all the departmental staff. I thanks one and all again. Again, I thanks the organizer and I congratulate Dr. Alfred for organizing and timely the schedule. Thanks one and all. Okay, sir.
Thank you so much, sir, for your kind words and your sharing throughout your life what you have done. Without wasting any time, as the time constraint is there, directly we are shifting towards the valedictory function. So my humble request is there that due to time constraint, please, we are considering now valedictory function. So I would like to request, as our Honorable President, Professor Vasantrao Purke sir is busy with his political meeting. So I request our Honorable Principal, Dr. S.V. Agarkar sir, to be the chairperson of this validatory function.
Hello.
Hello. Agarkar sir. Now I would like to request Dr. K.S. Adau sir, ex-professor and head, Department of Mathematics, IGNT University Amarkantak, to be the chief guest of this validatory function. Thank you, sir. Now I would like to request Professor V.G. Mete sir to be the guest of honor, Professor and Head, Department of Mathematics, RDIK and KD College, Badnera Railway. Again, I would like to request Professor V.R. Chede sir, Professor and Head, Department of Mathematics, GS Gavante College, Umarkhed, to be our guest of honor. Also, I would like to request Dr. V.B. Raut, Principal, Mungsaji Maharaj Mahavidyalaya, Darwa, our guest of honor. Also, I would like to request Dr. V.R. Patil sir, Principal, Arts, Science and Commerce College, Chikaldara. Also, I would like to request Dr. S.D. Tade sir, ex-associate professor, Department of Mathematics, Jawaharlal Nehru College, Nagpur, to be our guest of honor. Also, I would like to request Dr. R.M. Dhaigude sir, Professor and Head, Department of Mathematics, Government Vidya Institute of Science and Humanities, Amravati, to be our guest of honor. And the man behind this scene, along with our Honorable Principal, Dr. M.M. Sanchiti sir, Principal, R.A. Arts, Shri M.K. Commerce, and Shri S.R. Rathi Science College, Washim. Now, without wasting any time, I would like to request Dr. M.M. Sanchiti sir, the convener of this nationally conference, to express his views. Dr. Sanchiti sir. I think sir is some technical issues is there. Now I would like to request Dr. R.M. Dhaigude sir, Professor and Head, Department of Mathematics, Government Institute of Science and Humanities, Amravati, to express his views. Dhaigude sir. I think sir is also not there. Now I would like to request Dr. S.D. Tade sir, ex-associate professor, Department of Mathematics, Jawaharlal Nehru College, Nagpur, to express his views. Tade sir.
सर मी आधीच बोललो आहे. माझं मनोगत आधीच व्यक्त केलेलं आहे.
सर दिवसभराचं काही असेल सर ते प्लीज त्याच्या आम्हाला शेअर करा सर प्लीज.
ओके. आपल्या सर्वांच्या वतीने आजची कॉन्फरन्स जी पूर्ण कंडक्ट झाली आहे आणि पूर्णपणे रेड्डी सर आपल्या सोबत होते. तर माझी तुम्हाला अशी विनंती आहे की रेड्डी सरांनी आजच्या कॉन्फरन्स बद्दल त्यांचं मनोगत जर व्यक्त केलं तर ते आपल्याला चांगलं वाटेल. कारण आपण सगळे मंडळी ऑर्गनायझेशन मध्येच होतो आणि सरांनी आपल्याला जे मार्गदर्शन केलं आणि पूर्णपणे हजर होते. आपले आदरणीय करडे सर आहेत, अढाव सर आहेत, साळुंके सर आहेत, रेड्डी सर आहेत. तर आपण विनंती करू यांना की कोणी मनोगत व्यक्त करावं आहे ना, म्हणजे वेळ जाणार नाही तेवढा. थँक्यू.
Thank you so much, sir. Just by not considering the protocol, I would like to request Honorable Dr. D.R.K. Reddy, sir, to express his views for the overall performance of this national conference and the event organized by the organizers. Please, sir.
Hello. Oh. Bar.
Respected chairman of the function and the dignitaries, I am really happy to see that these two colleges conducting e-conferences and this pandemic situation. And right from the morning, I have been sitting through. Right from the morning, I have been sitting through, and I think I was talking for 1.5 hours. Well, so the main aim for me was to introduce the students, the PG students, to attract or motivate the students to do research. That is why I have taken that keynote address, the fundamentals. Fundamentals, why you should do research, what is the importance of research, everything. Okay, that is about my talk. And I have observed all the invited talks also, they are very good. And Professor Mishra from BITS Pilani, Professor P.K. Sahu, they have talked about the new theories that are coming up. FR theory, bouncing cosmology, and P.K. Sahu, Dr. P.K. Sahu was talking about the FQT gravity. So I told you in the beginning itself in my keynote address, what everybody is doing is field equations. Take any theory, take field equations, take geometry, take matter distribution, and feed them into field equations. Feed them. Geometry, feed it. Matter, feed it. Right hand, left hand, and geometry, right hand side is matter. So, solve the field equations. Solve the field equations, write the physical concepts. So this is what is happening, complete research in relativity. No, for that matter, any subject, research is that. It is only modeling, whatever you are doing mathematical modeling. Now, I have observed the research papers also, some of the papers. The young researchers, they are trying to do good research, of course. There are certain concepts, they should be clear about it. I told you in the morning itself, because everybody is coming in their anxiety to get their degrees. They are just entering into field and doing some research and getting away with the degrees. After that, I have observed some people are doing continuing research and some are not doing research. They are forgetting. Once they get PhD, they are forgetting research. This should not be the case. This type of conferences will help them to perpetuate or to continue the research. The continuation of research is very important. Not that you are going to do something great to the country, but you will help the country, all right. But for all overall department, the development of yourself, personality development, research is important. So what I suggest to the researchers or who got PhDs also, they should not leave research. They should continue the research. Now even our Professor Katore is retiring today. I suggest that he should not leave research. He should continue research and he should be in contact with the department. Some people, once they retire, they don't go to the department at all. This is also not correct, because that is the place which have given you life to you. The place that has given life to you is the department. So after retirement, why are you forgetting that place? You should go there and have contacts and do something and help the students if at all possible. So the overall views you have asked me to say. Anyway, there is good conference. All the things have been conducted in a systematic way, and everybody has participated. And I hope all the participants must have benefited by this conference. And I suggest again to the young participants, go through the fundamentals. Whatever may be the subject, if you are going to do research, first have a good foundation in fundamentals and then take up research. Then you will enjoy research. See, once you know the fundamentals thoroughly, what you are doing, then you will enjoy research. Otherwise, you will do the research for publication's sake or your degree sake. That is not correct. So there are some young students I have seen presenting the papers. Anyway, they are young people and they are beginners, so they will learn. And I wish that they should develop themselves and do good research. Overall, my view is this type of conference should be conducted in the in that area or any area. This will help the people to do continuous research and have a continuous contacts with the people in the subject. Thank you very much for giving me the opportunity. And what I suggest also is not the what you call the feedback, not from me. It should be from the participants.
Yes, sir. Yes, sir.
Not from DRK Reddy. DRK Reddy. Of course, you have given me respect and you have asked me some views I have given. But this conference is not for me. Sorry, it is gone. 1 minute.
Sir, you are audible, sir. You are audible, sir.
Audible. No, anyway, I am finishing. Okay. So thank you very much for giving me this opportunity. I suggest that you should have feedback from the participants, if it is possible, if the time permits. Okay. Thank you.
Thank you. Thank you so much, sir. Thank you so much. Now, as per the suggestions given by Honorable DRK Reddy, sir, I would like to invite the participant to express their views about the National League Conference. Those who want to express their views, please unmute yourself and please express your views. Anybody from the participant side, please?
The participants should come forward to express themselves. Then only the use of this conference. The conference is successful. Otherwise, listen and go. What is the use?
On behalf of the organizing committee, I again request to the participant, please express your views about the overall organization of this conference.
If there are nobody else, you ask somebody else what is there. If nobody is coming forward, you can ask some other people here present.
सर मला बोलायचं होतं. बोलू?
Yes, madam. बोला. बोला मॅडम. प्लीज बोला. प्लीज बोला.
सर, आजच्या कार्यक्रमाचे अध्यक्ष, सन्माननीय अध्यक्ष आणि सगळे आयोजकांचे मी खूप खूप अभिनंदन करते. आणि स्पेशली आमच्या वाशिम कडून डॉक्टर आदरणीय कतोरे सर, आदरणीय कतोरे मॅडम यांना वाशिमकरांकडून खूप खूप शुभेच्छा देते. खरं तर कतोरे सर आणि मॅडम आमच्यापासून वाशिमकरांपासून जेव्हा लांब गेले तर आमच्या सगळ्यांच्याच जीवनातच एक पोकळी निर्माण झाली होती. कारण कसं असतं की चांगले लोक जेव्हा आपल्यापासून दूर जातात तेव्हा खूप वाईट वाटतं. खरं तर ह्या भावना कधी व्यक्त करायला एक असं प्लॅटफॉर्म तुम्ही आम्हाला जो आज दिला आहे, तर खरंच मी या ऑर्गनायझिंग कमिटीचे खूप खूप आभार मानते की आमचे हे 2 शब्द तुम्ही सरांपर्यंत पोहोचवण्यासाठी आम्हाला उपलब्ध करून दिलं या कॉन्फरन्सच्या माध्यमातून. आणि अतिशय सुंदर पद्धतीने सरांचा हा सत्कार सोहळा इथे साजरा केलेला आहे. आणि सरांबद्दल काय बोलणार, म्हणजे इतकं छान असं व्यक्तिमत्व की जे सगळ्यांनाच खूप आवडतं आणि आमच्या वाशिमकरांना तर खूपच जास्त आवडतंय. तर खूप काही न बोलता सर नेहमीच सर आणि सरांची फॅमिली मॅडम नेहमीच आमच्या वाशिमकरांसाठी नेहमीच आमच्या आठवणीत होते. भलेही ते शरीराने तिथे जरी असले तरी मनाने ते नेहमीच आमच्या सोबत होते. आणि जेव्हा केव्हा आम्हाला त्यांच्या मार्गदर्शनाची गरज होती तेव्हा तेव्हा त्यांनी वाशिमकरांना नक्कीच साथ दिलेली आहे. हा माझा वैयक्तिक नाही तर सगळ्यांचाच अनुभव आहे. मी असं म्हणते आहे इथे की आमच्या सगळ्या वाशिमकरांकडून मी इथे त्यांचा जे फ्रेंड सर्कल आहे त्यांच्याबद्दल बोलते आहे. सर मला इथे आपण बोलण्याची सरांबद्दलची जी संधी दिली त्याबद्दल खूप खूप आभार. आणि सरांसाठी मॅडमसाठी भविष्यासाठी त्यांच्या उज्ज्वल आयुष्यासाठी आणि त्यांच्या स्वस्थ जीवनासाठी खूप खूप शुभेच्छा. धन्यवाद सर.
Thank you so much, ma'am.
Thank you.
Any other participant? Those who want to please express their views about the conference.
About the conference only they should express.
Yeah. Anybody on the participant side, please express your views about the conference.
Yes, sir. May I?
Yes. Yes, ma'am. Yes, ma'am. Yes, ma'am.
I would like to thank to the organizers for organizing such a mega event in relativity and cosmology, because almost maximum participants were from the same field as Honorable Dr. D.R.K. Reddy sir and Honorable Dr. T.M. Karde sir was the keynote speakers. And I would like to thank organizers for inviting such great eminent personalities. And all the participants are delighted by their talk. And I like to thank to the organizers for organizing such event, and also for the felicitation of our Honorable Dr. S.D. Katore sir, because everybody knows that he is the person, he is the academician, and he will continue, definitely he will continue his research work along with us. And he is a great guidance, he gives the great guidance to all the students every time. And being the part of the SGB Amravati University, I would like to thank Professor Katore sir for guiding us every time. Also for all the research students, because all the students are doing their research work now in a great way, because we know that in pandemic situation there is a lack of communication. But in this situation also, by organizing such event, we got the opportunity to express our research work before the researchers. And I would like to thank for this to all the organizers, especially both the colleges, like college from Ralegaon and from Washim, for organizing this event. Thank you one and all.
Thank you so much, ma'am. Thank you so much. Any other participant who want to give a overall view about this conference? Okay, let's move forward. Now I would like to request Dr. V.R. Patil sir, Principal, Arts, Science and Commerce College, Chikaldara, to express his views. Patil sir.
Namaskar to all of you. First of all, I will congratulate both the colleges, Department of Mathematics and IQAC, Indira, Gandhi, Mahavidyalaya, Ralegaon, District Yavatmal, and Department of Mathematics.
is not audible. Not audible. Not audible.
Yes, sir.
You unmute your mic perhaps.
Audible, sir.
Now audible. A bit louder. Okay.
To all of you, I first of all congratulate both the colleges, the Department of Mathematics and IQAC, Indira Gandhi Mahavidyalaya, Ralegaon, and Department of Mathematics and IQAC, RA College, RA Arts, Shri MK Commerce, and CSR Rathi Science for Washim.
Not audible. Dr. Patil, not audible.
The problem with his mic.
Remove your earphones. Dr. Patil. Remove it. Earphones.
Please remove your earphones.
तो आवाज नहीं आता है सर.
आवाज नहीं आता है. Something wrong with the mic for his. Now you go ahead with somebody else. Somebody is here. Some gentleman is here.
Yes, sir.
Somebody sitting. Some gentleman came onto the screen with yellow shirt.
सर आवाज नहीं आ रहा है सर.
Yeah. Dr. Kailash Mule. Kailash Mule is there. इनका आवाज नहीं आ रहा है भैया.
सर अनम्यूट हुआ.
हेलो.
आता है तो सर.
I congratulate both the colleges for the type of mega event.
No. Not audible.
Not audible.
Remove these things. Please remove this. Remove this and talk.
Hello. Hello.
Dr. Patil, remove your earphones and then talk.
Hello. 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 Sir, am I audible or not?
Yes, sir. Yes, sir. आप बोलिए sir, please.
I congratulate both the colleges and the QC department of the colleges for organizing type of mega event. We confer on different advances and innovative of mathematics. So this conference will organize and the speakers will talk about the subject.
Sarkate.
Dr. Yavatmal, Dr. Professor, we are our and group, no problem. And the basic idea about the cosmology, nativity, and black hole, and all these things, we are inspiring our new researchers. आमच्या सरकारमध्ये research करणाऱ्या विद्यार्थ्यांसाठी
Not audible, sir.
Not audible.
Sir, please increase the volume of your device.
So this type of event
Yes, net mass.
या संदर्भात बोलायचं म्हटलं
He is on cell phone, that is the problem. Okay.
नवीन टॉपिक सरांनी या ठिकाणी
There, Babu,
पाटील सर एक वेळेस रिमूव्ह होऊन जा लेफ्ट परत जॉईन हो तेव्हा
You are audible, he is not audible. Some problem. Next, go to next. If it is. चिकलदर. ये चिकलदर कहाँ पर है? चिकलदर.
सर अमरावती के पास है सर ये।
अच्छा।
हाँ हाँ अमरावती के पास है सर ये।
Hello.
Now you are audible, sir.
Hello.
Yes,
Audible,
sir. Yes,
sir.
sir. Yes, sir. Yes, sir.
Yes. Go ahead,
Yes.
please.
Okay. So, again, Namaskar, all of you. I congratulate both the colleges to organizing such a type of mega event, a national national conference on the disadvantage, a platform for new researchers to the research in the field. The speakers are invited in this conference are very knowledgeable persons like Dr. T.M. Kurde, Dr. D.R.K. Reddy. These are our grand gurus of our galaxy of the researchers. And the sessions organizing in this conference are well planned, well organized, and the topics covered in this conference is a very nice. It is a motivation for the new researchers to do the research in this field. Also, some new topics that are give the idea that is like black hole, wormholes, and all these ideas. These are the useful the new researchers, and I congratulate the both colleges to take यांनी एक प्रकारे या ठिकाणी कतोरे सरांचा सुपर ॲनिमेशन याचा कार्यक्रम या ठिकाणी घेतला. याबद्दल या दोन्ही महाविद्यालयांचं करावं तेवढं कौतुक कमीच आहे आणि यांनी हा बहुमान या ठिकाणी स्वतःकडे घेतला. असो या अतिशय चांगल्या प्रकारे कार्यक्रमांचं या ठिकाणी आयोजन झालं. कतोरे सरांना या ठिकाणी सर्वांनी शुभेच्छाही दिल्या. सर्वांनी या ठिकाणी त्यांच्याविषयी मत व्यक्त केली. अतिशय छान असं व्यक्तिमत्व, सादर आणि उच्च विचार या उक्तीप्रमाणे चालणारं हे व्यक्तिमत्व आणि या ठिकाणी गरीब अगदी ग्रामीण भागातून आलेल्या सर्व शिक्षकांना म्हणा, रिसर्चर्स म्हणा किंवा रिसर्च मध्ये काम करणाऱ्या सर्व विद्यार्थ्यांना या ठिकाणी घेऊन चालणारं असं एक व्यक्तिमत्व आणि त्यांचा या ठिकाणी या प्रसंगी जो सत्कार आयोजन केला त्याबद्दल या दोन्ही महाविद्यालयांचं या ठिकाणी मनापासून अभिनंदन करतो. त्यांना कॉंग्रॅच्युलेशन देतो. त्याचप्रमाणे सरांविषयी जर बोलायचं असेल त्यांचं अगदी व्यक्तिमत्व साधं, सरळ आणि या ठिकाणी सर्वांना घेऊन चालणारं होतं. तर त्याविषयी ज्या दोन ओळी मला ज्या आठवल्या त्या मी या ठिकाणी आपल्या समोर मांडतो. तेरा मेरा करते एक दिन चले जाना है, जो भी कमाया है यही रह जाना है, कर लो अच्छे कर्म साथ तेरे यही जाना है, रोने से तो आंसू भी पराया हो जाते हैं लेकिन मुस्कुराने से तो पराये भी अपने हो जाते हैं. अशा प्रकारचं व्यक्तिमत्व आपल्याला या ठिकाणी आज त्यांच्या वयानुसार ते जरी रिटायर होत असले तरी आपल्यासोबत नेहमी सतत आपल्यासोबत राहतील, आपल्याला मार्गदर्शन करतील आणि नवीन नवीन रिसर्च आयडिया आपल्या सर्व लोकांना, सर्व नवीन सुपरवायझर्सला, नवीन रिसर्च करणाऱ्या प्राध्यापकांना किंवा या ठिकाणी विद्यार्थ्यांना या ठिकाणी देत राहतील. पुढे असं म्हणता येईल, रोने से तो आंसू भी पराया हो जाते हैं लेकिन मुस्कुराने से तो पराये भी अपने हो जाते हैं. अशा प्रकारचं हे व्यक्तिमत्व आपल्यातून आज या ठिकाणी रिटायर होत आहे. मुझे तो रिश्ते भी पसंद है जिनमें मैं नहीं हम हो, इंसानियत दिल में होती है और हैसियत में नहीं लेकिन ऊपर वाला कर्म देखता है, वैसियत नहीं. अशा प्रकारचं व्यक्तिमत्व आपल्या ठिकाणी वयाप्रमाणे जे नियम असतात या सर्व धरून तरी या गॅप मध्ये, या रिसर्च मध्ये, या रिलेटिव्हिटीच्या या पूर्ण 9 सारखे या ठिकाणी आपल्यासोबत राहतील आणि आपली साथ ते सोडणार नाही या ठिकाणी एवढी अपेक्षा त्यांच्याकडून व्यक्त करतो. सरांनी आपल्याला वेळोवेळी प्रत्येक ठिकाणी, प्रत्येक पायरीवर, प्रत्येक स्टेपला या ठिकाणी मार्गदर्शन केलेलं आहे आणि त्यांच्या मार्गदर्शनामुळे या ठिकाणी एक चांगल्या प्रकारचे रिसर्च मध्ये एक स्थान प्राप्त करून दिलेलं आहे. आढाव सरांच्या मार्गदर्शनामध्ये कतोरे सर तयार झाले. कतोरे सरांच्या मार्गदर्शनामध्ये आता सध्या तरी कोणी नसलं तरी भविष्यात कोणीतरी येईल आणि त्या ठिकाणी त्यांच्या पाय ठेवून या ठिकाणी या विभागाची, या संत गाडगेबाबा अमरावती विद्यापीठाचं गणित डिपार्टमेंट असेल त्याची या ठिकाणी उन्नती होईल आणि या उन्नतीसाठी सरांचं मार्गदर्शन आपल्याला नेहमी लाभत राहील आणि त्यांच्याकडून हीच अपेक्षा करूया. सरांनी आपल्यासोबत नेहमीच या ठिकाणी वेळ द्यावा अशी सर्वांची अपेक्षा राहील. सरांसोबत काम करत असताना, विद्यापीठाच्या विविध प्राधिकारणींवर काम करत असताना किंवा वेगवेगळ्या समितीवर काम करत असताना सरांना अगदी जवळून आम्ही पाहिलेलं आहे आणि कतोरे सरांचा स्वभाव हा मनमिळावू, कोणालाही न दुखवणारा, कोणालाही या ठिकाणी न रागवणारा किंवा या ठिकाणी कोणावरही कुठल्या प्रकारचा राग न काढणारे व्यक्तिमत्व या ठिकाणी आढाव सरांच्या मार्गदर्शनाखाली तयार झालेलं हे व्यक्तिमत्व होतं आणि त्यांनी या ठिकाणी अतिशय चांगल्या प्रकारे या ठिकाणी सांभाळलेलं आहे. तसेच आढाव सरांनी या ठिकाणी जी शिस्त या ठिकाणी मॅथमॅटिक्सच्या लोकांना लावून दिलेली आहे त्या शिस्तीमुळेच या ठिकाणी या गणित विभागाचं या ठिकाणी उन्नती ही उत्तरोत्तर होत आहे. म्हणून या ठिकाणी आढाव सरांचंही या ठिकाणी तेवढंच या ठिकाणी आपण हे मानूया की त्यांनी या ठिकाणी चांगल्या प्रकारे आपल्याला मार्गदर्शन करत या स्तरापर्यंत आणलेलं आहे. TM कर्डे सर असतील, नंतर DRK रेड्डी सर असतील, कतोरे सर असतील, JN साळुंके सर असतील किंवा अन्य या रिसर्च मध्ये खडेकर सर असतील, SRTM युनिव्हर्सिटीचे डॉक्टर पवार सर असतील किंवा JM चौधरी असतील, असे अनेक प्राध्यापकांनी या ठिकाणी आपल्याला सर्वांना या रिसर्चच्या फील्डमध्ये वेळोवेळी सहकार्य करत आलेले आहेत, करत राहतील आणि या ठिकाणी पुन्हा सर्वांकडून अपेक्षा ठेवून मी माझे 2 शब्द संपवतो. सर्वांना शुभेच्छा देतो. विशेषतः ऑर्गनायझर, त्याचप्रमाणे दोन्ही महाविद्यालयांचे संचालक मंडळ, प्राचार्य आणि IQAC कोऑर्डिनेटर यांचं सर्वांचं अभिनंदन करतो. अतिशय चांगल्या प्रकारे ही कॉन्फरन्स वेल प्लॅन, अतिशय सिस्टमॅटिक, पद्धतशीर, टाइम टू टाइम चालणारा कॉन्फरन्स या ठिकाणी यांनी आयोजित केली. त्या सर्व टीमला माझ्यातर्फे, आमच्या महाविद्यालयातर्फे, तसेच गणित विभागातर्फे व संत गाडगेबाबा अमरावती विद्यापीठातर्फे व संत गाडगेबाबा अमरावती विद्यापीठातील सर्व प्राधिकरणांचे सदस्य, त्याचप्रमाणे वेगवेगळ्या डिपार्टमेंटचे या ठिकाणी हेड्स, या सर्वांतर्फे मी या ठिकाणी अतिशय अभिनंदन करतो आणि माझे 2 शब्द थांबवतो. धन्यवाद. थँक्यू सर.
Thank you so much, sir. Thank you so much, sir. Now I would like to request Dr. VB Raut, sir, Principal, Mungsaji Maharaj Mahavidyalaya, Darwa, to express his views.
So, may I audible?
Yes, sir. Yes, sir.
So, Honorable Chairperson of this validity function, Principal Dr. Agarkar sir, our mentor and Mahaguru, Honorable Professor Karde sir, Honorable Professor DRK Reddy sir, my Guru, Professor Adhav sir, and all the dignitaries present here over, I salute to all of them. Now, dear friends, I was started my journey in the teaching field since 1986 from RA College, Washim, under the able guidance and help of Senior Professor Dr. S.D. Katore sir. Since then, I am associated with him and got each and every help from him. Regarding him, I want to just say that he is good friend, good supporter, well-wisher, and best guide, and very good helping person. I wish him and so many, along with Dr. Mayur and Piyush, very healthy and wealthy life in future. But on the occasion of this event, I congratulate the organizers of this well-planned academic event for nice organization and providing the delicious mental and academic food to the participants. Thank you. Again, I am thankful to the management of both the colleges, principal of both colleges, my friend Professor Sancheti, and to give me a chance to say something about my co-guide, say Dr. S.T. Katore sir, and also listen the views from all over the participants. Thank you all. Thank you, sir.
Thank you so much, sir. Thank you so much for your valuable words. Now I would like to request Professor V.R. Chide sir, Professor and Head, Department of Mathematics, G.S. Gawande College, Umarkhed, to express his views.
आवाज येतो का सर?
म्हणजे थोडं बारीक होऊन राहिलं सर.
आता?
नाही सर, म्हणजे एकदम स्पष्ट नाही होऊन राहिलं सर.
एक मिनिट. हा, आता येतो का सर?
नाही, थोडं दबून राहिलंय सर. ऍक्च्युली पाटील सरांसारखंच होऊन राहिलंय सर ते.
शिर्डे सर बोलत आहेत का?
हो सर, हो सर.
अल्फ्रेड सर.
हाँ सर.
आवाज येतो का?
नहीं सर, आवाज नहीं आ रहा है सर आपका. क्लियरली आवाज नहीं आ रहा है सर.
आता येतो का?
हाँ, यस सर, यस सर, यस सर, यस सर.
Good evening to all of you. Chairperson of this valedictory function, Professor Vasantrauji Purke sir, Chief Guest Dr. K. Sadau sir, ex-professor and head Department of Mathematics, SGBU Amravati, Honorable Karde sir, Honorable Dr. Reddy sir, Salunke sir, Guest of Honors, Dr. V.G. Mete sir, Professor and Head Department of Mathematics, RDIK and KD College, Bandera, Principal V.B. Raut sir, Principal V.R. Patil sir, Guest of Honors, Dr. S.D. Tade sir, Dr. R.M. Daigode sir, Professor and Head Department of Mathematics, JV Amravati, Convener of this conference, Dr. S.V. Agarkar sir, Principal Indira Gandhi Kala Mahavidyalaya, Ralegaon, second convener, Dr. M.M. Sancheti sir, RA Science College, Washim, coordinator of this conference, Dr. A.Y. Sheikh, and the organizing secretary, Shri S.V. Gore sir, also Dr. and Professor S.D. Katore sir, Professor and Head Department of Mathematics, SGBU Amravati, University Amravati, all the dignitaries and the participants join this event. Firstly, I will congratulate to both the conveners, Dr. Agarkar sir and Dr. Sancheti sir, and also the coordinator, A.Y. Sheikh sir, and his colleague Gore sir, for successful organizing of this event. And also thanks for giving me an opportunity to interact with you. Such conference will be beneficial for the new researchers and also motivate the PG student to do the research. I hope new researchers will follow the ideas given by Honorable Dr. Reddy sir. Before publication of any article in any journal, we should discuss it with the concerned people, at least online, for the good quality of research. आणि ज्यांच्या सुपरएन्युएशनच्या निमित्ताने आपण ही इव्हेंट घेतलेली आहे त्या सत्कारमूर्ती आदरणीय डॉक्टर कतोरे सर. सर, तुम्ही निवृत्त होत आहात. शासकीय नियमानुसार सेवानिवृत्ती ही अटळ असते. सेवानिवृत्तीच्या निमित्ताने तुम्ही आमचा निरोप घेताय हे खरे आहे, पण तुमच्याशी असलेले आमचे नाते सदैव अभंगच राहील. आजपर्यंतच्या प्रवासात तुमच्या सहवासात आम्ही जगलेले अनेक क्षण आताही आठवतात. तुमचा सर्वांनाच आवडणारा निर्मळ स्वभाव, तुमचं सर्वांशी आपुलकीने वागणं आम्हाला नेहमी आठवण राहील. तुमच्या आईवडिलांच्या पुण्याने तुम्ही आयुष्यात खूप सुंदर दिवस अनुभवले. खरे तर हा निरोप समारंभात म्हणजे शुभेच्छा देऊन घेऊन आयुष्याचा महोत्सव करण्याचा, जीवनातील सुंदर क्षण अनुभवण्याचा दिवस आहे. आता इथून मनासारखे जगत जीवानंद घेत आयुष्य भरभरून जगायचे आहे. आता तुम्ही सेवानिवृत्त होणार असलात तरी तुमची कामे करण्याची काम करण्याची शैली, उत्साह आणि तुमचे चिर तरुण व्यक्तिमत्व पाहिले की तुम्ही साखीला पोहोचलात असे वाटतच नाही. असा चिर तरुण उत्साह भविष्यातही कायम राहू ही ईश्वरचरणी प्रार्थना. तुमची शिकवण आणि उत्साह आम्हाला नेहमी पुढे जाण्यासाठी मार्गदर्शक ठरेल असा विश्वास वाटतो. तुमच्या सहवासात राहून मी एखाद्या वेळेस एखाद्या गोष्टीसाठी नकार दिला तरी तुम्ही ते काम माझ्याकडून पूर्ण करून घेऊन मला यशोशिखरावर पोहोचले, त्याबद्दल मी तुमचा कायम ऋणी राहील. PhDच्या रजिस्ट्रेशन पासून मुलाखतीपर्यंत तुमचे अत्यंत मौलिक सहकार्य मला लाभले. अमरावतीला आल्यानंतर तुम्ही तुमची इतर कामे बाजूला घेऊन मला वेळ दिला, आदरातिथ्य केले. काही अडचणी असल्यास केव्हाही फोन केला तरी लगेच सहकार्य करण्याची तुमच्या मनाचा मोठेपणा कायम स्मरणात राहणार आहे. तुमच्या यशस्वी वाटचालीत तुमच्या अर्धांगिनी सौ संध्याताई कतोरे यांचा मोलाचा वाटा आहे. त्यामुळे त्यांचेही मनापासून अभिनंदन आणि तुम्ही सर्व कुटुंबियांनी केलेल्या सहकार्याबद्दल मी कृतज्ञता व्यक्त करतो. तसेच सुपुत्र चिरंजीव डॉक्टर मयूर आणि चिरंजीव पियुष यांना उज्ज्वल भविष्यासाठी हार्दिक शुभेच्छा. सर, या प्रसंगी तुमच्यासाठी एक कविता सादर करायची वाटते. कविता माझी नाही, परंतु त्याच्यातले काही वर्डिंग चेंज करून मी थोडेसे लिहिण्याचा प्रयत्न केलेला आहे. कवितेचे शीर्षक आहे निवृत्ती छे जगण्याची नवी आवृत्ती. घटिका गेली पळे गेली अखेर आली निवृत्ती. घटिका गेली पळे गेली अखेर आली निवृत्ती. आता थोडी चैन करूया बदला आपली वृत्ती. लवकर उठणे विसरा आता खुशाल ताणून द्या. लवकर उठणे विसरा आता खुशाल ताणून द्या. बेटीची लज्जत न्यारी एकदा चाखून घ्या. चवी चवीने वाचा पेपर वरवर फिरून दृष्टी. चवी चवीने वाचा पेपर वरवर फिरून दृष्टी. मापे काढा मित्रांची आणि पुढाऱ्यांची खरटपट्टी. टीव्ही पाहत चाखा नाश्ता रोज नवीन रतीब. टीव्ही पाहत चाखा नाश्ता रोज नवीन रतीब. खिल्ली उडवा भल्या भल्यांची सैल सोडून जे ऑफिसची ना घाई आता रोज रोजची सुट्टी ऑफिसची ना घाई आता रोज रोजची सुट्टी निवांत आंघोळ निवांत पूजा करील मनाची पुष्टी सावकाश करा भोजन मारा आडवा हात पुरणपोळी कधी बासुंदी वा कधी साखर भात तांबूळ सेवन नित्यसे असावे कधी मसाला पट्टी वाम कुशीला नका अंतरू करा तिच्याशी गट्टी पुन्हा एकदा निरामय आणि दीर्घ आयुष्याकरिता आपणास शुभेच्छा पुनश्च एकदा आयुर्वेदिकांचे मनापासून आभार मानतो आणि आपली रजा करतो. धन्यवाद.
Thank you so much, sir. Thank you so much for your wonderful poem, sir, which specify the journey of the life of Honorable Professor Dr. S.D. Katore, sir. Now I would like to request Professor V.G. Mete, sir, Professor and Head Department of Mathematics, RDI and KD College, Badnera.
बंद करायला लागत होतं म्हणजे असं पेपर धरून घ्या.
Dr. Mete, sir. Hello, Mete, sir. I think sir is not there. Now I would like to request Honorable Dr. K.S. Adau, sir, the chief guest of our function, to express his views. Sir. Adau, sir. I think sir is not there. Adau, sir. Sir is not there. Some technical issue might be there. Now, lastly, I would like to request the president of today's valedictory function, Dr. X.V. Agarkar, sir, Principal Indira Gandhi Mahavidyalaya, Ralegaon, to address their presidential speech. Hello. Hello.
Audible? Hello?
Yes, sir. Yes, sir. Yes. Yes, sir.
Good evening, all. I welcome all dignitaries, distinguished guests, and delegates to the valedictory function of National E-Conference on Recent Advances for Innovative Research in Mathematics, organized by our Indira Gandhi Mahavidyalaya, Ralegaon, in collaboration with RA College, Washim. Today we have with us Chief Guest, Honorable Dr. Adau sir. We have with us Honorable Principal V.R. Patil sir, Honorable Principal V.V. Raut sir. We have Honorable Professor Dr. Katore sir. We have with us Professor Chirde sir. We have with us Professor Mete sir. We have with us my colleague, my friend, Principal Sancheti sir. For this validity function, we have our coordinator, Dr. A.Y. Sheikh sir, our organizing secretary, S.B. Gore sir, and all members of organizing committee. At the outset, I am very happy for this organizing mega event by both the colleges. I am firstly very much thankful to the management of both the colleges, especially our inspiration, Honorable Professor Vasantraoji Burge sir, for his motivation and inspiration for organizing this conference. And I am also very much thankful to Honorable Shri Shyam Sundarji Mundada sir, Vice President of Rajasthan Education Society Washim, for his motivation and inspiration also. I am very much glad that our dignitaries in the keynote sessions, they have delivered very nice sessions, and these keynote speakers have covered all the dimensions of mathematics, right from pure mathematics to applied mathematics, and enlighten all budding researchers in the field of mathematics. I am very happy, and I feel I am the richest principal of this region, that now I have a big list of experts in the field of mathematics with me. It is like a directory, because many students come approach for getting solution to their mathematical problem. And if any student come down to me for getting solution, now I have big list of experts to solve the problems of my students. So I am very happy, and I am very much thankful to all keynote speakers and dignitaries for guiding us. Thank you very much, all the dignitaries. Regarding delegates, I am very happy, and I am very much thankful for their active participation. I was present for many sessions. I have seen the bubbling enthusiasm in presentation, interacting, and expressing their new ideas about the innovative research in the field of mathematics. I am very happy. And in all the 3 parallel sessions, the response was very nice. And I am also very happy we have conducted with the support of all as per the code and conduct of national level conference, right from morning 10 a.m. to evening 6 p.m. I am very much thankful to one and all. And regarding Professor Katore sir, we could organize this event very successfully because of his constant support, motivation, and guidance. And his students also supported in a big way for conducting this conference at mega level. And a team of our collaborative college, my friend, Principal Sanchiti sir and his team, IQAC coordinators, they have helped a lot for since initiation of the conference. And regarding our college is located in a remote place. We are facing many problems, but now I am very confident that with the support of these all eminent personality, we can surpass, we can overcome all these hurdles, and we can achieve good quality in higher education at rural and tribal area like Ralegaon. And I am very proud to state that we are very smarter in choosing, in knowing who is retiring from which organization. Eminent personality like we have Professor Katore sir. And after retirement, we are smarter to convince and grab the opportunity to invite to our college, to convert our college into center of excellence, center for research for rural and tribal students. So I and my team will definitely convince Professor Katore sir and his all colleagues to come down to Ralegaon to enrich the knowledge and skills of my students. And we are going to do that also in near future. I expect same guidance and cooperation from all dignitaries, all delegates and experts for organization of various events in future also. And I feel very proud, in spite of many hurdles, in spite of many problems, our organizing team could finally conduct this program very successfully, and they deserve actually appreciation for this successful conduct of program. And in future also, our college is planning to have such a national level event with your support, and I expect same cooperation in that also. With this, I congratulate team of organizers. I am very much thankful to all the dignitaries, delegates, principals of all colleges, heads of the departments, and my colleague teachers, mathematicians, and research scholars for supporting us for conducting this program. With this, I am once again thankful to all and congratulate the team of organizers. And with this, I close. Thank you, and I know. Thank you.
Thank you so much, sir, for your valuable words. Now we come to the conclusion. So I request the man of the mission for organizing such a beautiful event and giving his total 100% dedication as a organizing secretary, and nearly he contacted each and every person patiently, humbly, and making each and every person request so that he could send the abstract, all these things to that is Mr. S.V. Gore sir to propose the vote of thanks. Over to Gore sir.
Thank you, sir. The best and beautiful thing in the world cannot be seen or even touched. They must be felt by heart. Thank you is one of the such prayer among them. I consider it a great privilege to propose a vote of thanks. All dignitaries who have witnessed it as a memorable and successful mega event. Now let me move to the duty ensured to me. Today, my words are not enough to express the gratitude on behalf of Department of Mathematics and IQAC, Indira Gandhi Mahavidyalaya Ralegaon, and Department of Mathematics and IQAC, RA College, Washim. I would like to thank our mentor, ideal, and great visionary President, Professor V.C. Purkesar, for giving his valuable time with particular direction and information to organize such a mega event. Today, our chief guest, my guru, Dr. K.S. Adao sir, ex-professor and head Department of Mathematics, IGNT, University Amarkantak, highly energetic and paternal person. I am thankful for accepting our invitation and giving us inspiration, huge support. Also, I would like to thank Dr. V.J. Mete sir for giving his valuable time and direction to organize this function. Also, I would like to thank Dr. V.R. Childe sir for sparing his time and giving motivational guidance to overall development of research in mathematics. Also, I would like to thank Dr. V. Raut sir for giving his valuable time and suggestion to organize this event. I would like to thank Dr. V.R. Patil sir for giving his valuable time throughout the organization of the National E-Conference. Now, I would like to thank Dr. S.D. Tade sir for his valuable time with particular direction and information for making this event a successful one. Also, I would like to thank Dr. R.M. Gaigude sir for giving his valuable time throughout the organization of this event. I am also thankful to the convener, Dr. S.V. Agarkar sir and Dr. M.M. Sanchiti sir for giving constant encouragement and guidance throughout the organization of this National E-Conference. Now, I would like to thank the one of my motivational person and coordinator of this National E-Conference and head of the department, Dr. A.Y. Sheikh sir, who is totally understand and protecting me in any situation. Thank you, sir. Also, I am also thankful to all the participants from all over the India as they have shown a huge response to our request. I am also thankful to the IQAC coordinator of both the colleges for giving a chance to our department for organizing such an event. I am thankful to Mr. Bhushan Bhatti, Mr. Amol Litkar, Mr. Yashwant Barate, Mr. Sandeep Gore, Mr. Satish Wankhede, Mr. Apur Gurwa, Mr. Dr. Hatkar sir, Sachin Hatkar sir, with all the head of the department and supporting staff of both the colleges for giving hand-to-hand response and support for the organization of this mega event. If anybody left in this, my thanks to everyone. I pray my humble thanks to those who have helped by staying behind curtains. Now, by permission of chair, I here to declare that the program is over.
Thank you so much, sir. Thank you all the participants and Honorable Reddy sir for the whole day. He has guided us in this event.
चलो चलो इथं झोपणार आहे का